wild paper from 2002 called Language Trees and Zipping, which shows how you can find structure between languages just by using very general file compression. For example, let's say I give you a bunch of text documents in many different languages, and your goal is to automatically cluster them by language. And actually, you can aim even higher than that. Suppose you also want to recover which languages are most closely related to each other in a way that lets you rediscover the tree of shared lineage between them, and all you can do is write a function that processes the text in each one. There's no pre-baked knowledge of linguistics. Now keep in mind, this is almost a quarter century ago, so nothing like modern language models is available. What's crazy is how the authors showed that you can do this just by using gzip, basically the same operation that you might use on your computer to make files a bit smaller. Here's the basic idea. Given two documents, A and B, append a small snippet of B to the end of A and compress the result. Now compare that file size to what you get just by compressing A on its own. One way to think about this difference is it's telling you how well a little snippet of B gets compressed when the compressor is mostly optimized for A. You'd expect that result to be small when the linguistic patterns of B are similar to those in A, but larger when B is more different from A. The authors used this general idea to define a specific metric for how far away two documents are, based exclusively on how well they compress together. And then, evidently, this co-compression-based distance was enough to recover the tree of language lineage. And it doesn't stop there. The same trick can be used for other natural language tasks, like identifying who authored a given document. What I like about this paper is what a pure example it is of when the theory and the engineering behind compression can be surprisingly useful to tasks which would seem to fall in the domain of machine learning and artificial intelligence. The specific concept underlying this example is something known as cross-entropy, and what's interesting is that cross-entropy is also a very core part of how modern language models are trained, which gives a whisper of an unexpected connection between that training and compression. Most of what I want to do with this video is provide a lesson that goes back to the basics. We're going to spend the first half on the fundamentals of what cross-entropy is, how it naturally arises in the study of compression, and how you can visualize it. Then after that, we're going to go through the fundamentals on pre-training and distilling language models. And what's interesting is how, in that second half, the way that cross-entropy arises initially looks completely different. It seems unrelated to compression. But whenever you see the same formula pop up in two separate contexts, it's math's way of kind of winking at you and hinting at a connection. So at the end, armed with an understanding of where cross-entropy really comes from, combined with an understanding of pre-training, I want to show you how you can reframe the way you think about training large language models to not be about next token prediction, but instead to be about compression. It's easiest to motivate cross-entropy in the context of encoding messages into sequences of bits. This is a topic we began discussing in part 1, where the framing is that we treat messages as sequences of symbols, something like characters of text, and if you treat each new symbol like it's being sampled from some probability distribution, those probabilities tell you something about the fundamental limits on compression. Now, the case of natural language is incredibly complicated. Those distributions would be very difficult to describe. So we centered a lot of our discussion on a very simplified toy example. And I want to pick up from that thread here, since that example also helps motivate cross-entropy. The setup was that we're sending
Um, Palestine have to die before you call for a ceasefire. Over 7,000 children have died. Over 7,000 children have been slaughtered by Israel. This is unacceptable. What happened to human rights? What happened to democracy? We call for peace, we call for democracy, and we don't see it.
かその夢暑いんだけどマジでほかほかその夢さあうちに帰ろうありがとうそのレトロメモリーそんな夢さあうちに帰ろうありがとうほかほかその夢さあうちに帰ろう
Sequences of
ほかほかその夢さあうちに帰ろう
When we just got started, there was a very smart guy named Juan Levy who was working at Latin. He said you gotta speak with a very smart guy named Hirsch. And we had a conversation. And in that conversation, he told me that there's a lot of people on back then Twitter that have a lot of influence.
ほかほかその夢
And now it's my part of the story. When I started looking into that, I could see that there's one common denominator for both people, which almost all of them are educators, whether they're doing that as their job or whether they're doing that for passion. But this is what is common for everyone. And you told me you need to start commenting, engaging, to become friends with them. And become friends with them really like stick with me. And for about a month, I was constantly asking myself the question, like, how can I become friends with them? Because eventually a lot of them, especially those who are doing this for a living, they have a business, you know, you can reach out to them and you can ask for sponsored tweets or collabs or whatever. But then you're walking through the door that all the other big brands are going to. So first of all, we didn't have money to speak here. We didn't have a lot of money. We're bootstrapping. So that was a great constraint to have because we couldn't just throw money on them and buy their friendship with money. So we had to figure it out in another way. So I tried to think, how can I become friends with you? And what we ended up doing, we said, all right, these people put a lot of effort in creating content. We know how hard it is. We know that they're not very often get the recognition for it. So I've just started DMing these people, saying that look, I've seen, it was very personal, but like generalizing the content. I've seen all the contributions you've been doing to grow the global book. We want to send you a small thing as a sign of gratitude, and we expect nothing in return. And we were very serious about expecting nothing in return. And we sat down in my flat and we prepared a bunch of boxes with like cool swag. It was very personal with handwritten notes and the branded biscuit and like not fancy things, but things that you could see that we mean from the bottom of our heart. And we shipped those boxes to about 100 sort of like influencers. By the way, I hate that word. But and
Peter No has written one of the most important papers in computer science. It's called Programming as Theory Binding. In this paper, Peter refers to the act of programming and the act of building software and especially its modification is a consequence of the theory which the original programmers had built in their head. But before we actually get original programmers, is a consequence of the theory which refers to the act of programming and the act of building software and especially its modification is a consequence of the theory which the original programmers had built in their head. But before we actually get into the paper, I want to tell you a little bit about who is Peter Naur, and once you hear who he is, you will see why we should listen to this guy. Peter Naur is a Danish computer scientist and a Turing Award winner. He is best known as one of the contributors to the Backus-Naur form, which is abbreviated as BNF notation, used in describing the syntax for most programming languages. He also contributed to the creation of the programming language Algol 60. If you take Kent Beck's extreme programming methodology, then you would see that it's rooted, at least some of it is rooted in Peter Naur ideas, and Kent Beck actually admits it. So this guy has a huge influence on programming languages and on theories behind it. And therefore, if this guy has something to tell us about the maintenance and the creation of softwares and how programmers are dealing with software and how it relates to other areas, then we as admiring ships should listen to this guy. Peter Naur is widely known as one of the authors of the programming language syntax notations, the BNF, and in 1985 he presented this research papers, which is titled Programming as Theory Building. In this paper he's trying to understand what's going on in the design and in the coding of the program. How much documentation should you create? And is documentation important? We know that the program itself changes faster than the documentation, so what exactly should be the documentation and how important it is? Some people claim you don't really need documentation. What is Peter Naur's view on this? He is especially interested in what I'm actually also especially interested in. How do you maintain a program? We have the previous programmers who coded this program, and let's say they are not around anymore, so what is the approach, or how do you maintain such a program? Because as we know, when you build something, let's say you are building the Empire State Building, then you don't really do many changes there. You don't say, I need to take this window and color it with red, let's move the building to the 2nd street, let's make it a little shorter because the clouds are like this, and it would be better if it would be horizontally placed and the entrance would be there. Alright, you don't do this with buildings, but with programming and with software packages, you do this all the time. You could actually claim that the whole target of programming, the whole target of what you're doing is to enable this flexibility. So therefore we should handle with care, and we should understand how the paper advises us to work with such things. So in Naur ideas, the designer job, the architect work, is not to pass along the design to the next developer, programmer who is maintaining the software, but to pass along the theory, deriving the design. So it's not that you design something and then you implement it. You build a theory for yourself about the state of the world, about how you model the state of the world in the program, and then based on this theory you are going to create your design. This is like an empirical thing. This is what's happening. He is only describing it in the paper. He does not claim you should build step A, a theory, and then you should do a design, and then you should implement. He claims this is what's going in the heads of the people and the programmers. They build some kind of a theory around the state of the matters, and then they build the design, and we should take care, special treatment for this theory, which was placed before the design. And once you understand this point, you understand the whole paper. because then when you transfer the software to be maintained by other programmers, or you yourself get to maintain the software, the target is to understand the theory that was sitting in the minds of the programmers who created the original design, and not just reading the code, okay? And he actually claims in the paper that you cannot understand this theory just by reading the code or reading the design. It's just impossible. You can get hints into them, but the theory needs to be explicitly referred to. So in this paper, the programming is theory, he claims that what is programming, he asked what programming, and he said that programmers, what they do is they achieve some kind of an insight, a theory into the state of the matters, and this is in contrast to the standard notion that programmers just are a production of programs, they just produce text. Okay, this is the other extreme. But it's not just the production of this button should be here, okay, so let's write this line of code that places this button here, but it's a theory behind it and the connection. He has a conviction that it's important to have an appropriate understanding of what programming is, and only once we understand what is programming, then only then we could move on and understand how do we maintain programs. So yes, while it's true that programming and the programmer's knowledge is an activity that refers to the real world, and then it's using simple manipulation, the writing of symbols that is taking place on your monitor in order to create a program. But then a major part of programming is the manipulation and the modification of this existing program. So let's say you have some group A, this is from the paper, right? You have some group A which is building a program to solve some problem, and then comes along group B and decides that for the program they need to do some changes. So what I do is that they communicate with group A, they read the documentation and they get personal advice from group A. Then group B manages to develop the additional features they wanted from the application. The special thing here in this example is that group B actually communicated and got the advices from group A because the group A was there. But then when group C comes along and he tries to manipulate the software, they take the review and the suggestions by group B, but because they are not the original group, then they do not understand really the theory behind the software. They are less close to the theory. And then what they saw is that when they use the software, as the software evolved, then the theory got messed up and lost in the software, and they practically destroyed the power of the software. And the reason for that is that the theory was not self-obvious in the software itself. So they could not understand the small things that were sprinkled here and there, but these small things, this small power that was in the software was like from the theory of the original developers. For example, if you have some special code which does the code generation and some structure of the program, so it's not explicitly stated this is the structure of the program, this is what we meant, okay, this is the structure. So you start picking up and start reading feature, but you deviate from it, not necessarily knowing the full power and the full expectation of group A for this specific section of the code. And therefore, seeing the full program text and the additional documentation is insufficient to get a deeper insight into the design and the theory that was presented actually by group A. That thinks that group B was actually able to communicate with group A, but group C was not able to communicate with group A. So this is true, and this is especially true for large code bases where you have more than 200,000 lines of code, because for small code bases then you might get long term. So the conclusion seems inescapable that at least with certain kinds of large programs, then the continuous implementation and modification and the correction of errors of them is essentially dependent on certain kind of knowledge, which is possessed by the group of programmers who were closely and continuously connected with the original group of developers who wrote it. And here he refers to Ryan's notion of theory as a appears in the example of what Karl Popper has said. And the notion of the theory in more details means that there is a difference between an intelligent activity and intellectual activity. Okay? A person must have in order not only to do certain things intelligently, but also to explain them. When you have the capability to also explain them, this moves ahead into intellectualism and not mere intelligence for doing certain things. So the intellectual activity goes beyond the activity that is merely intelligent, and if the person is building and having a theory, he should have this intellectual activity. So what is exactly this theory? This theory that the programmers actually built? It's the theory of how certain affairs of the world will be handled when supported by the computer program. It transcends all the documentation, and it transcends the code, and it transcends the answer. It's an actual knowledge that the original developers had. And it's not merely the program text. It's some word aspect and activities. And the program text is almost irrelevant to this theory that is created in the mind of the original developers. Its relevant can only be made by someone who understands the whole world and the whole aspect of the programmers. The programmers who have this original theory can explain why each part of the program is what it is, and support any actual program text with a justification of some sort. They are also able, because they have this theory in their mind, to respond to constructively to any demand for a modification of the program. Even if this may sound clear to you, the problem is that it's not so clear to people outside of the programming industry, which means
Why does this guy sound fucking Israeli?
To
Oh my god, he is
have
fucking
a
Israeli.
production line of cars. So you have also a production line of code text. You input the specification, you get a good programmer, and he would output the text.
Israel. Hello, my Israeli friend.
Start with basic authentication. So this is
Yeah, he's fucking Israeli. Yeah. Well, that's fine. I mean, it's probably not fine, but it might be fine. So. But it's cool that he's like talking about Pierre Noir. Already saw this. Already seen this, haven't I?
Pick a gender language. The Harvard architecture is named after IBM's so-called Harvard Mark I, a computer that helped to develop the atomic bomb during World War II. In the Harvard Mark I, instructions were stored on punched paper tape, and data was stored in electromechanical counters within the CPU. The principle of storing instructions and data in different places became known as the Harvard architecture. Before we look at the Harvard architecture, let's first consider a traditional single-core computer in which the programs and the data are both stored in the memory, the RAM. This is known as the von Neumann architecture. To fetch a program instruction or a data item into the CPU processing, the relevant memory address is first sent to the main memory via the address bus. Then an instruction or a data item is sent back to the CPU via the data bus. Saving a data item in the memory also requires that a memory address is sent to memory by the address bus. Then the data is conveyed from same memory and the same buses that connect the CPU to the memory. It means that they have to be fetched separately. An instruction to load the data item from the memory into the CPU, for example, will need 2 fetch execute cycles to complete. One for the instruction and one for the data. This is known as the Bob-U bottleneck. The Harvard architecture improves on this by storing instructions and data in separate memories. And because these memories are separate, they don't need to be built in the same way. For example, depending on the application, there could be more instruction memory than data memory. This would require a wider address bus of the instruction memory. Furthermore, the instruction memory might have a bigger word width. That is, each location in the instruction memory could be capable of storing more bits than a location in data memory. Consequently, the instruction bus would be wider than the data bus. Depending on the application, it might also be appropriate to use read-only memory for the instructions, but read-write memory for the data. The Harvard architecture is most often found in digital signal processors. So-called DSP applications include purpose-built hardware for audio and video processing, medical imaging applications such as X-ray, MRI, and CAT scans, fitness trackers and smartwatches, and digital assistants such as Amazon's Alexa and Google Home. What these DSP applications have in common is the capture and digitization of analog information, followed by some form of processing of the digital signal generated. For example, a speech processing application might digitize a spoken instruction, then filter out any interference or background noise before passing it on to an AI to be interpreted and actioned. Even a modern personal computer borrows design principles from the Harvard architecture. A typical CPU has several cores, each with its own arithmetic and logic unit, and their operation is managed by a single control unit. It also contains multiple levels of cache memory. Cache memory temporarily stores frequently used instructions and data, rather than having to make multiple requests to the RAM. Each core has its own level 1 cache, which is closest to the core, meaning it can be accessed very quickly. Each core also has its own level 2 cache, which is larger than the level 1 cache and a little slower to access. The level 3 cache is shared by all of the cores. It has the biggest capacity, but operates more slowly than the other 2 levels. Nevertheless, all of the CPU cache memory is much faster than the main memory, because there's no need for the instructions and data in the cache to travel along the data bus. Each level 1 cache is split in 2. Some of it for instructions and some of it for data. This is sometimes referred to as the modified Harvard architecture. The main benefit of this approach, of course, is that data and instructions can be fetched and processed simultaneously by the same core. So, as you've seen, the original design principle of the Harvard Mark I, that is, different memories for instructions and data, is still relevant today.
Why I prefer
running one type of thing in terms of another. Polymorphism, being able to access things of different types through the same interface. And encapsulation, which allows us to hide.
polymorphism isn't just an OO principle, right? I mean, polymorphism in some sense exists in functional, right? I mean, isn't that just a trait at this point? You're just treating an object with the ability to, you have X different types, but they all have a singular way in which you can access something about it. Is that really, polymorphism is kind of like everything? Yeah. Okay, because people use this term sometimes like as if it's an OO specific technique. It's just like, well, I mean, to think of some kind of function on it don't mean it's you gotta be OO, baby.
It's not interesting detail. I think that most functional programs
encapsulation.
all of these are good things.
Encapsulation is also not really a specifically OO idea. It's just making it so that there's some data that's grabbable or some state that's captured in something. Right? Even like just a plain old struct that has some private members and some functions. I mean, is that OO or is that just encapsulation? You know, again, these terms are very vague and they're very hard for me to understand.
In fact, all of these are principles that also when you do functional programming. It's just that you describe those things into functional terms.
There we go.
Functional programmers talk about declarative programming, which is really a form of abstraction and information hiding, and the use of types, which is polymorphism. Inheritance, though, is tricky because while it is clearly true that it has some strong benefits, it's also often being misused and can have some serious.
I'd say that your argument for inheritance being clearly good really comes down to like I can think of right now. I still have this just one use case that I think is good, and that's it. And I know there's other ones like it, but it's a very rare problem set. Yeah, composition's not even on here. Anyways, the only time I can think OO is really, or the inheritance specifically is really good, is when you have a method that's directly tied to a property that's needed, but you don't want to implement or state that property. So I can think of one right away. I think something that's really great here, hold on. I know where this is COBOL, by the way. Look at that COBOL, by the way. You know what I'm talking about. Me personally, do I have something that ends with TS? Do I have anything? There you go. I'll go to this guy. Something that really makes me happy, I think, in general, is extends event emitter, right? It's just one of those things that I find to be a fine abstraction for OO. And I'm not particularly sure how you do this in Rust without, say, a macro, right? So if you're using a macro, it kind of sucks to do, you know, I'm not like loving the macro approach here for this specific thing. And so this is like one of those few items that I'm fine with being here, because then you can just do that, blah, blah, blah. And now my rectangle has a dot on and no, a trait. I mean, traits only work, you can only have default implementations on a trait if the thing, again, event emitter requires a property to be present. Right? It requires something, so you'd have to make a trait and then a blanket implementation off of a couple traits. Then you could do it. But that would require you to still implement a trait per type. You know what I mean? I've never saw the diamond problem in a real code base. You haven't been programming long enough, son. If you could problem in a real code base. I've never saw the diamond problem in a real code base. You haven't been programming long enough, son.
If you create
virtual
a window
inheritance
on your display,
baby.
to inheritance that you can resize or tweak it. Object orientation was the technical
Not technically true.
step that really liberated code sharing. And it's no surprise that OO and the GUI came from the same place, 0xpi.
It's pronounced GUI. Okay? Not pronounced GUI. Okay, we all call it GUI. Everyone knows it. I know it. You know it.
The GUI is deeply an object-oriented display idea. When non-OO programmers have further OO, often focus on primary inheritance. That's because you can make global metrics of inheritance. To the extent that people who prefer simple binary answers will often say inheritance is bad. Of course, inheritance is bad. But bad inheritance.
I'd say inheritance generally is bad. I'm so confident in that. We're going to go on Twitter where people are going to get angry. Enhance is generally bad. Tweet. Send now. Suck it. I don't even know what Jack Ford said, but I'm just going to like it. Because that's the person that I am. Okay? That's who I am.
It's certainly that. The big mistake in inheritance, and I'd probably say programming in general, is not to model the problem that you're trying to solve with. Tactical programming is often at risk.
That's a no true Scotsman thing, right? I guess you could use inheritance to model any problem. It can totally be done. Alright, I get it. You can solve any problem with inheritance. It's not like it's an incapable problem. It's just how does it scale is the real question. And the fact that you have to just sit down and try to write out on paper your problem regularly to try to understand how to make changes in the system or to be able to model it in general, to me just immediately says that there's something fundamentally wrong here. Because it's not tied directly to programming in the real world, which often is messy and way harder. And then you have to keep doing this back and forth. Like, I find that when I'm doing really strong OO inheritance style things, I actually am thinking on paper. I actually do draw out things because that's the only way for my small pea brain to understand the shape and the size. Whereas when I do it more just like as a series of functions and some strategic objects here and there and maybe some caching for some fast stuff every now and then, so some classes here and there, then yeah, then I don't need to model anything else out. Like, I can just glaze through the program, and then the spots that suck, the spots that are kind of a bit convoluted, they usually always start off as a util folder, right? It's just like, hey, here's a bunch of shit, I don't know where to put them. Start doing that. And once I start seeing a pattern or some things that are really needed, I'm like, you know what? Like, this thing right here, I need to move over here and make it a first-class citizen because it's just really needed. Yeah, it sucks to refactor, but it generally makes it so that I know kind of what I want and how to use it. I don't know. This whole idea that... this whole modeling plan is crazy to me.
Tactical crap. For example, in Java, the set inherits from the vector, and properties inherit from hash tables. This is tactical crap. The set is the vector. Properties are not hash tables. This is a lazy choice because it made implementing sets and properties easier. But
I mean, to be completely fair, he said, you know, you can imagine that it is a vector underneath the hood, right? That's really all a set is. It's either an array, which you have to double the size of and copy everything over, or it's a vector. Either way, it's kind of like the same thing. You know, are you getting anything out of it? I mean, I can understand why they did that. I mean, I just don't like the whole idea of inheritance. Just use a vector.
it is nonsense, really. The set is not a vector, and results in all sorts of features of sets in Java that make no sense at all. What does index of an entry mean for a set?
Yeah.
Or why would I ever wish to rehash my property?
Inheritance
This isn't the fault of inheritance.
Why do you think you can rehash properties? Is there any reason other than it actually is just purely due to inheritance? If that's the case, that's just crazy. You should just use a vector, not inherit it from a vector. I don't know. Sets are sometimes. Sets are often, I mean, sets, let's see. I mean, a set is typically represented by some contiguous chunk of memory somewhere. And that's usually on the heap. And you put that crap in there by performing a hash set. And if there's a collision, you may have a linked list, or you may have quadratic
meant for integrating into the engines, etc. But it tackles specifically the problem of some people call it virtualized geometry, some people call it I'm blanking. Right. So the Ubisoft folks call it, I think, micropolygon. I think they have a term called MPH, micropolygon. I don't know. But basically, Epic invented / popularized the concept of rendering like way too many triangles fairly efficiently through this use of multi-resolution data structure. They call it nanite, and other people call it by other names. Nanite is a trademark, I think. So anyway, so the main library, Mesh Optimizer, is still kind of the main focus of the project, but there is still other satellite ones. And I guess maybe just to give people an idea of, so the most basic way, I guess, to explain why meshes are more complicated than they appear is actually something that probably everybody who did computer graphics courses up until the point where you have to render real geometry probably faced. So like you have a cube, and the cube has 6 faces, but GPUs don't really render like polygons, they render triangles. It has 12 triangles of the faces. And then you ask people, well, what are the vertices of the cube? And they say, well, there's 8 vertices, right? Because there's 8 corners of the cube. And then you look in various runtime-ready graphics formats like GLTF or whatever. You open a file, you look how many triangles does it have, 12, you look how many vertices does it have, and then it's like 24. and you expect 8, and immediately like becomes clear that something is wrong here. So the problem is in graphics. The first problem is in graphics. The vertices that we talk about have attributes. So you have position, but you also have normals, texture coordinates, etc. And there is a terrible problem sort of attribute discontinuities, where a given vertex can have multiple attributes. So for a cube, if you think about the corner of the cube, it actually has 3 normals for a flat shaded cube, because the normal kind of associated with every face of the cube points directly orthogonal to the plane of the face. And so in computer graphics, the way GPUs work is you don't have like 8 positions and then a bunch of other normals that are elsewhere. You have everything jammed inside a single vertex, and so because of this you have, for a cube, 24 vertices. But you could also say, oh, the cube has 12 triangles, and every triangle has a vertex. So you could represent the cube as 36 vertices, just 3 vertices for a triangle. And so there's a lot of different ways to kind of represent a single, even in the basic model of just vertex data and index data, there's lots of ways to represent a single mesh, right? And so what you get out of your model files from Blender or whatever is usually a representation that may not be optimal, even from the perspective of how many vertices you have, right? And then there's like other stuff around GPUs that we can get into in a minute. But yeah, this is kind of the basic idea of the library.
So the basic idea for anybody who has their own engine and they want to load the model and geometry to call into the mesh object and call a couple of functions in sequence, so you kind of have the structure, the vertex and index buffers optimized, taken care of. You don't need to worry about it too much.
Right, this is an important distinction to highlight. So Mesh Optimizer is a collection of algorithms, and it's sort of like a tools to build something out of. It's not an off-the-shelf kind of end-to-end solution where you just feed it a Blender mesh file and something ready for rendering comes at the end. And it's very, very intentional because, so here's the kind of the problem with Mesh Optimizer. There's many different engines, and there are certain things that are very common between the engines. And there are certain things that most engines share, although this becomes, even like mesh rendering after Nanite and after some other stuff before this, even that got very sort of complicated, that you could have very different approaches that are used by different engines. But there are some things that were relatively common, but there were many things that were very different between different engines. And the challenge in Mesh Optimizer is kind of how do you build a library that's useful, given that there's so many different ways to actually implement the rendering part, right? And so the answer is the algorithms that Mesh Optimizer provides are all composable. So it's like, oh, your pipeline for optimizing mesh is like 10 stages, and like 9 of them are mesh optimized function calls, and then the 10th one is preparing, like for example, I mentioned that the vertex data, right, so you have positions, and then you also probably have normals, you probably have texture coordinates, you may have some other stuff. Different intentions have wildly different ways to represent this in memory, because you could have full floating point precision storage for some of these, although bad engines do this. You could have half precision, you could have integer quantization, you could have crazy bit packing methods where you say, oh, I don't know, my normal is like 2 7-bit components and one 1-bit component to represent the sign of the third component. But I will place this 1-bit component next to like some other bits where I store position data in, just because things are, when you deal with compressed vertical representations on the GPUs, you want something that's easy for the shader to decode. And the shaders don't really do even unaligned byte reads very well. Definitely it's more difficult to do sort of bit stream extraction in the shaders. And so you try to pack things into like byte or 2-byte or 4-byte sized quantities, right? And so you jam things together. It's like, okay, 10 bits from this component and 10 bits from that component and like 2 bits from this component go together, and it's all smooshed, and then the shader like decodes this. Cool. So there's no way for me to, there might be a way, but I really didn't want to, let's put it this way to deal with this sort of diverse situation in the library, right? So because of this, Mesh Optimizer doesn't really have a vertex format. It doesn't care. It's up to the engine to decide kind of what the optimal set of attributes, etc. is and how to back them. But then a lot of the other code around this is in the library. So yes, we have a pipeline. Most of this pipeline is hopefully Mesh Optimizer calls. Some of this pipeline is custom. And then you run this to take your mesh from the unoptimal representation to the one that you can pretty much directly feed to the shaders at runtime, and then sort of run from them.
Regarding the types, this means that your library is, as far as I've seen, templated, right? You can have templates for
okay,
types.
so yeah, let's briefly talk about the language choices. So the library is in C++, it's written in C++, the implementation is all C++. The interface it exposes is actually mostly C. This is important because you can use the library from other languages. It's very, very painful to bridge C++ code across the language boundary. It is not painful usually to bridge the C interface. Mesh Optimizer has like Rust bindings, it has Zig bindings. I'm sure people wrote bindings for other new cool languages. It has .NET bindings. Anything that's managed, so .NET is a good example. You have an FFI layer that you use like pinvoke to bridge calls from the .NET runtime. And if things are very neatly like C-like, you have arrays and sizes, then it's very easy to bridge a call through pinvoke. If you have like a class in your API, God help you. So because of the complexities like this, and also because I like short compile times and all of that good stuff, so the interface is almost completely C, with one exception. So the thing you're talking about is when you deal with index data, people can't agree on sort of the size, the types of that index data. The most basic problem is you can have 16-bit or 32-bit integers. And also some people use signed integers for some reason for the index data in their mesh processing code. So I have like template wrappers around many functions that hide the distinction between the types of the index data, but the actual like sort of core interface is just C, is just for this it's like 32-bit data. And then for things like positions, for example, that would be good to call out. So my expectation is that your runtime data is carefully bit-backed positions with like whatever you like half precision, like integer quantization, whatever. Some algorithms need access to actual position data in floats, and so that's what they get. They get floats, and then your pipeline usually would have at some point it would drop the floating point position data and convert it to sort of your optimal bit-backed format. But then if you ever need to call Mesh Optimizer algorithms on it, you would have floating point data kind of on the side that you don't save to the runtime ready file, you just have it on the side to feed it. But yeah, so most of the interface is C, and in fact this is, it's kind of, it restricts in certain ways, of course. I don't know, I can't have default arguments for functions because, everything is like, it's C ABI. Oh, and also, it's not just C API, it's C ABI. Binary interface, meaning so nice libraries are libraries where you can update the library and then the update just works. This means the code compiles without changes, so that makes sense. But also if you aren't using C++, this means your binding layer should ideally just work out of the box. So if you ever have a function, in C++ if you have a function and you're like, oh, let me add one more parameter to it, you're like, okay, sure, I'll just add it. Oh, the source code breaks. Oh, I'll just default it to like 0. Well, in C, the problem is you add a parameter, your binding breaks, and your binding can break in spectacular ways, like, oh, the stack layout of the function call is like different, and there's a crash that you'd never see coming and stuff like this. And so evolution of interfaces of libraries written in C is like peculiar, but this is kind of the property that I want. So going back to what I said earlier, so you have an engine, you have lots of problems, right? The last of your problem is, the last of the problems you want to solve is like, oh, how do I update this library? what unfortunately sometimes common in game development is like you just never update code. You start a new engine, you take the versions of whatever libraries you have. They are from like 10 years ago by the time you ship a game. If you're very lucky, when you start a new game, you update them. Often you don't. So I really really wanted to have this sort of property of people should trust that they can just update code. And now, do they update code regardless? I don't know, but at least, if they ever update code, it won't break, which they might be incentivized to do this again in the future. But yeah, so the templates are just like, to help. There's some helpers where the library is mostly used from C++, and so when you do use it from C++, there's like some extra sort of interface stuff to help you a little bit, but it's not really super important.
So let's talk a little bit about this sort of traditional rendering pipeline, right? So the core mesh optimizer part. As far as I understand, what happens when you create, you update the layout of the vertex and index buffers at the beginning, startup, right? And then afterwards you don't really touch them if you have static data, right?
Mm-hmm.
So this is at the beginning of the application, correct?
Mm-hmm. One clarification about, I guess, all of this is, so there are cases where this is not true, but most of the time I would expect that mesh optimizer is used in the content pipeline. So this means, so you have a separate application, some people call it, content maker, like mesh processor, stuff like this, right? And the job of that is to take the input file that is usually directly produced or indirectly produced by whatever software your artists use. So let's take Blender as an example, right? So you use Blender. Blender saves .blend files, which is like a proprietary format which doesn't really have a clean API to work with. But you can also export stuff from Blender. You can export FBX. And so if you ever want to read FBX, then you have libraries like UFBX or FBXSD, but never use that one. Or you can export GLTF. You could export Colladi, you no longer can. I think the main two interchange formats like this, I guess, are GLTF and FBX. And then there's also older formats. There's a format called OBJ that is very, very popular, but it's very, very strange and sort of restricted in many ways. It's not really a good fit for a production engine pipeline, but it's a great fit for like, I want to do visualization and I just need like a couple meshes. So you export the thing from Blender, and that gives you a file that you can then read. But you shouldn't read it at runtime. You could, and again, so in the web world, there's people who mostly would use GLTF files kind of at runtime. But usually you have your own proprietary engine format, and so you have an application that reads this kind of sum file from the modeling application, and then does a bunch of processing to it, and this is where Mesh Optimizer works. So then you save a binary file, and then that binary file goes, a custom binary file, and that goes directly to your engine, like at runtime, right? Now, sometimes you may have procedural geometry. When you have procedural geometry, sometimes it makes sense to run some of the Mesh Optimizer algorithms on it kind of at runtime after you're done processing. And both because of this, but also because so even when you use it offline, something kind of one of my, I guess, pet peeves is some people don't treat the processing of data that happens before the engine with the same rigor that they treat the runtime. Meaning, we changed the mesh. It's fine, we can wait a minute for it to like recreate the internal engine presentation. So again, my opinion is, it's not fine. What you should have is the artist changes something in the modeling program, they save the file, and then as quickly as possible, the result can be transferred to the engine. And then if the engine is running side by side with the modeling application, then you can live reload. And then it's great because you force your artists to work within the context of the engine and preview changes to their art inside the engine, inside the game, which is how you get the best final result. But the only way that this can work is that the whole thing is passed with friction. Like, I save the thing, it's converted, it's done, right? And because of this, and also because of the runtime use cases, in a lot of mesh optimizer algorithms, there is not just a question of kind of how efficient is the result. There is also the question of how fast is the algorithm itself run, because if it's slow, it might be impractically slow. And it doesn't help, by the way, that a lot of the algorithms that we're going to talk about today, they don't really have solutions. Some of them don't have computable solutions, as in we just don't know how to compute the optimal. And some of them have computable solutions that are like traveling salesman hard, as in like, well, the optimal way to do this is an exponential search, and it's like, there's some approximations that we can come up with. But which is actually funny, so in algorithm theory, people make this distinction between polynomial complexity and exponential, and basically super polynomial. But polynomial means n to a fixed power, so it could mean n to the power of 5. For mesh processing, even n to the power of 2 is way too long. If you have a million triangles, a million squared is like way too long to wait for. And so a lot of this unfortunately is in the space of, well, we kind of have to build heuristics and approximations and try to figure out what works and what doesn't, but we don't really know what the optimal looks like, right? So this is the context behind a lot of this.
So not a startup of the application, but like a separate process preparing the ask.
I should mention, so when you are in development of the game, it could make sense to bundle, sort of for simplicity, the setup that I described where there's a separate processing pipeline, it's very common in the game engine world, but the common, a way you could do this is you could also code this code like it doesn't really matter whether you run it. You could run it inside the engine process. So if you really want to, which is completely fine, some engines do this, while in development, inside your engine process, you could have code that says, oh, I have this file has a runtime ready representation, but the file has changed since the runtime ready representation was updated. So let me rebuild it, save it back to disk, and then when you ship your engine, you take out the portion that like gives the whole kind of baking on the fly part, right, and your users then run it. So like if you want to run it inside the engine, that's completely fine too. And again, a lot of the algorithms are like fast enough so that practically speaking, it's not that big of a deal to run them. But the intent certainly is, this is kind of, a lot of this is offline process.
So now I'm a little bit into the algorithms that actually happen in these steps. And the context for this is that we have like a index buffer where we have the data from vertices. We have an index buffer that points to the index buffer, basically saying, hey, here are the triangles, like laid out. And you have outlined a lot of steps. And the first one is indexing and kind of read what we have in the index buffer. So how does it work?
So the context here, so this is very basic, and the context here is, so I have this cube example earlier. You can think of a cube as it has 30 vertices, because every triangle has. You can think of it as it has 24 vertices, so that's the minimum that you have, that you need to represent the normal. If you remove all of the aspects from the cube, like normal, subtraction, stuff, then the minimum number of vertices would be 8, because you just need one for each corner, you just need to represent. When you start from the model meshes, like the meshes that come from Blender or whatever, they usually have a different model how they represent the meshes generally. For example, it's common in modeling applications to have, they don't really think about this as vertex buffer and specific buffer because they're not really meant for accelerated rendering. It's common to say, oh, I have positions in my vertex data, but I also have attributes that are attached to like triangle corners. And so you have a triangle, or even they usually don't use triangles. But in terms of triangles, you could have a triangle, and the triangle has each corner references the position, but it also may reference like section coordinates by different indexes. And so there's not really, this model doesn't map cleanly, right? And because this model doesn't to the GPU world, and because this model doesn't map cleanly to the GPU world, the first thing you need to do is you need to build an actual index buffer, where every vertex in the vertex buffer, where again a vertex is the composition of all of the attributes that you have, is only referenced once. So the first step usually in the pipeline is the indexing, because your source indexation is usually simply either not existent because your source model didn't really have one, or if you have a GLTF file has an index buffer. But many exporters that save the GLTF file would not produce an index buffer that rather, they would often produce a vertex buffer that has duplicates. Just because kind of the way their data that this stuff comes out of had duplicates because of this complicated sort of modeling data structure, and they just didn't deduplicate it, right? So the first thing that you should do is reindexing, which is basically deduplication, and all it does is it finds the unique vertices in your vertex data, and then renumbers. So it builds a view into your original vertex buffer where only unique vertices are referenced, and then uses that view, which is like a remap table, to remap both the vertex data and the index data so that you don't have, so you don't lose the duplicate data. This is just like a hash table, and if you really wanted to write this code yourself, it's not very hard to write this code yourself. It's a hash table, you write a hash function and stuff like this. There's two reasons. So some algorithms that is measured are like this, where the algorithm itself is very, very simple. It's a hash table. It's like find unique elements in the sequence. Not a big deal. The problem is a high-performance hash table it takes some effort to build, and it's not really readily available. If you write code in C++, C++ now has had for 15 years now a built-in hash table. It's really bad in terms of the performance it takes to run it, because it does an allocation per element, and it uses like often uses inefficient code to index it and stuff like this. So if you just took this code and just built it yourself in C++, it would be slow. Now again, you may not care if you're fine with taking 1 minute to process. I do care, and so because I do care, right, there's a single function in Mesh Optimizer that does the right thing for you on the high level, so you don't have to think about what it does internally. 2, does it as quickly as sort of humanly possible, right? There's like a hash function that can be optimized, so layout of layout of the internal hash data, stuff like this, right? There's some key that's around if your source data is floating point, it's actually not trivial to build it's not hard, but like there's a lot of nuance here, right? So you have a floating point value. You need to compute a hash of it. Again, C++ has a function for it. Out of the box, it has a split hash, I think, specialization for floats. It's really slow because it does, but it's correct because it does like a decomposition, I think, of the floating point value and stuff. You can be tempted to say, well, the floating point is just 32 bits. Let me just take these 32 bits and hash them however I would hash an integer. The problem is, in floating point, positive 0 and negative 0 are two distinct bit patterns because their sign bit is redundant, but they are equal. Is it a huge problem if you're building a hash function that positive 0 and negative 0 would hash to different numbers? Maybe not, but like it's a problem, right? So anyway, there's like a lot of weird complications around some of this, but the big reason why Mesh Optimizer even does this, the big two reasons are A, to have a complete pipeline that can be built out of mesh functions, and 2, just performance of hash table lookups. But yeah, so the reindexing stuff is actually very simple. The difficult stuff is what happens after, right? Because the difficult stuff that happens after is, for example, the vertex cache.
So
and this
we
where
started with the vertex buffer, and now kind of gave them to Mesh Optimizer, and we got back either a table or already the changed vertex buffer, index buffer, like the deduplicate. And now we enter like a second part, which is vertex cache. And now can you do like a bit of an intro for how vertex cache works to you, and how do you want to like optimize it?
Yeah, so this is where we get into so the reindexing is straightforward. If I just told you, oh, your vertex buffer may have duplicates, you're like, oh yeah, that's fine, I'll just look them up. But there is this large class of problems that I mentioned at the beginning where people just sort of don't realize they might have, right? And the vertex cache is one of them. So if we think about the GPU execution model, or the GPU, I guess, pipeline model, the way it's like documented, there's your index buffer, there's potentially vertex buffers, or you may potentially run it without them, and then you submit the brothel, and then your vertex shader magically gets executed with indices out of your index buffer, and then these indices get the vertex data from the vertex buffer, and then your vertex shader does useful computations, and then creates data that then gets fed into the rest drive. So this is a cool model that is conceptually very simple and useful, but there's a lot unsaid about that model, and there's a lot of space for different GPUs to do different things with the data. So the first problem is very simple. It goes like this. So I was talking about a cube. A cube is a complicated example because it's a small mesh. It has very few of everything, and so it doesn't translate into meaningful metrics. So here's a couple of just baseline, just like Euler theorem or equation or whatever it's called, and there's some things that are interacting with. But okay, so like if you have an infinite plane, which if you have a very large mesh, it may be reasonable to think of a very large mesh as an infinite plane. Then this infinite plane has half as many vertices as there are triangles. Generally in an optimal mesh, in a mesh that's very smooth, it has lots of highly tested surfaces and stuff like this, you'd expect around half of as many triangles as you have vertices. Now this is not true of the cube, this is not true of many complex facets, but then I give you the index buffer. The index buffer has 2x the number of vertices approximately, but this means it has 6 times the number of indices because there are 3 indices per triangle. So you give a GPU 6 times as many indices as you have vertices. Again, very approximate for many meshes. This is not like this, it's fine. A GPU could do many things. One thing it could do is it could take every triangle, it could take every vertex in that triangle, run the vertex shader for that vertex, and then you would have your 3 output sets of data for the rasterizer to take in. This is up to 6 times slower than processing every vertex in the original vertex buffer once. You could take the entire vertex buffer, in theory, and run the vertex shader on every individual vertex, just completely ignoring the indices. Save the result of this somewhere to a GPU memory, and then take your index buffer and just find things in the resulting buffer by index. The problem is this doesn't really conform to the model. If I give you an index buffer that references vertices 1, 2, and 7, you're not supposed to run my vertex shader on the index number 6. Spoiler alert, there are some mobile GPUs that misunderstood the assignment and actually do the thing that I just said, where they take the entire vertex buffer, even the vertices that you're not referencing, they run the vertex shader, they save it to temporary memory. The other problem there is how much memory do you need? The answer is way too much, because GPUs have this complicated tension between being a parallel machine and being sort of an efficient machine. The optimal thing, always the optimal thing for parallel processing is to process every single element independently, which means you have to have memory for every single input and every single output, all resident at once somewhere. And so in this case, it's like, oh, you have 1 million vertices in your mesh. Well, we need space for 1 million copies of the output vertex data, which is very bad because your vertex shader outputs, conceptually it outputs floats, there is no bit back in there, and it outputs many of them because it's like however many attributes you are exporting from your vertex shader that are then read from the fragment shader. So so there are some mobile GPUs that kind of approach this horrible, like you should never build hardware like this, but fortunately many of them are very old. The desktop version used to be, so the canonical understanding of reasonably efficient model of how to do this involves something called the vertex cache. So the model there is very, very simple. So I just told you you have an index buffer that's fairly large, and it references a number of vertices that's fairly small, but you kind of don't really have space for the whole thing. So what if there was a small cache? Let's say there was a small cache for 32 vertices. And what we would store in this cache is the result of the vertex shader invocation. And the key for that cache would be just the index value. So the GPU would process the index buffer. It would say, okay, there's 3 vertices, 3 index values for the triangle. Let me just look up every one of them in the cache. The cache either stores the data or it doesn't have it yet. If it doesn't have it yet, I will run the vertex shader, I will get the new data and put this in the cache. And then the cache is fixed size. And so if the cache is small, but the indices in the source index buffer are still coherent in the sense that they're like local, you're likely to see if you're ever going to see the index again, you're going to see it soon after the last time you saw it, right? Then you're fine. And this is kind of how CPU caches work. If you have a CPU cache and you have the same address, and you access the same address sort of soon after you have already accessed it, it's probably going to be there. But if you run a whole bunch of extra code that pollutes the cache with a whole bunch of other stuff, and then access the address again, then it probably won't happen. Now, GPUs actually don't work like this, because the model that I described is sequential. You take the instances from the index buffer, you look in the cache, if the cache doesn't have them, you compute the vertex data, you put this in the cache. But this is a problem because GPUs want to process like thousands of vertices at once. So the real hardware is complicated. The real hardware is complicated and also it's not documented in the sense that, so people have reverse engineered, there's ways for you to reverse engineer the behavior of an individual GPU because there's some side effects from the vertex shader that you can observe. A vertex shader can write to buffers since DirectX 10, I think, and the model, the documentation for the API says basically, we will not tell you how many times a given vertex shader runs for a given index. It could be once, it could be many times, we will not tell you. And if you do anything in your vertex shader that would break this illusion of the vertex shader just running for individual indices that are referenced, it's kind of on you, like, it's your problem. Some different drivers do different things around this and stuff like this, but generally speaking, there are some ways to reverse engineer the behavior of the hardware here. But counterintuitively, for the optimization of this, it helps you less than you think to have the precise model of the hardware. Because of the earlier problem that I mentioned, we don't know how to build optimal solutions. We don't know how to build them quickly, but we also just don't know. Even if you have the precise way to model the behavior of this cache, and by the way, so if people who are into, if people who work at like AMD or NVIDIA are going to watch this, they're going to be offended because the cache doesn't really exist in these GPUs per se. The cache is, as I said, so like the cache makes sense if you have a sequential model of execution. It makes sense as an analogy. It breaks down when you say, oh, the GPU actually processes thousands of processes at once. How does this work? The answer to how this works in some GPUs is, roughly speaking, let's say I gave you an index buffer. Let's say you looked at a small slice of this index buffer. Like, I don't know, like 120 triangles or whatever. Let's say you take these index data and then just found duplicates within that batch. You would have the index value like 13 that's used like 5 times for some reason, and the index value like 17 would be only used once. So then out of this you could build a smaller subset of the vertices that are actually used. And then ask the GPU, can you shade all of these? Ignore everything that happened before or after. Like if later, if inside this chunk of the index data there is a value 17, that's only happened once. But in the next chunk it's going to happen 3 times. It's fine, we will process it again. Because we are trying to be parallel, which means we can't take the full advantage of the kind of sequential reuse. So you take all of this batch, you kind of compact this batch by removing the duplicates from it, and then you send the whole thing to the vertex shader execution, and then the rasterizer has to pick up the pieces and kind of reassemble things back from the data that the vertex shader processed. But it kind of doesn't matter again because, so the interesting fundamental property of this is actually just if your index buffer is optimized for locality, meaning if you have seen an index once, if you're ever going to see it again, it should happen soon. How soon is hard to answer, but it happens soon. And so Mesh Optimizer has a function, to go all the way back, which basically does this optimization. It's based on an algorithm that was invented by Tom Forsyth way back, I forget, like many years ago. The interesting thing about that algorithm is it's driven by a lot of heuristics, or by a few heuristics. So it looks at a few, it kind of models a cache, but it doesn't model it very precisely, and it doesn't use a specific replacement policy. Like, it doesn't have this notion that, a cache is 16 vertices, and we are seeing the vertex that is not in the cache, which means the last vertex that was there should be removed. This is not kind of how it works. It uses heuristics. So I use an algorithm that's based on this. I did an interesting thing many years ago, which is this. So if you have an algorithm that's driven by heuristics, it's difficult to tweak these heuristics. You have, in that algorithm, you have a bunch of like numbers that are saying, oh, if like the vertex is going to be referenced again by like 3 triangles, this is what the score of that vertex should be, and this is how we should model the like value of replacing this vertex now versus later. And what do you set any of the numbers that guide any of your heuristics is always like an impossible question. I feel like half of the time that I spend on all of these algorithms is just like, how do I tweak all of this? So I did something pretty cool a few years ago, must be many years ago now. I have a blog post about this. Some of the stuff that I've done for Mesh Optimizer has nice articles on my blog. Some is like, I don't know, 20%. One day I will get to the rest, 80%.
Zooks.io.
Zooks.io. Yes, exactly. Like and subscribe and all of this. So if you have an approximate description of how hardware works, you could take a given set of index values and you can ask approximately how many times will the vertex shader run on the whole index set. You can actually gather this data precisely if you have a GPU, because the modern graphics APIs expose what's called the pipeline counters that will tell you how many times the vertex shader has run, basically. And it's an interesting value to look at, because you can look at the mesh and it's going to be a number that is not the number of vertices. It's larger because the cache is like imperfect. But it's also not the number of indices. It's much smaller. And so like, you know, you see the cache working pretty good. And you can also see on different GPUs it's going to be small or large. But it's expensive to, so I wanted to run an optimization algorithm that took a large collection of meshes and then had this small set of numbers that determine the heuristics, and then tweak these numbers. It kind of, you know, it's kind of similar to how neural networks are trained these days, but for neural networks you need a gradient, and you don't really have a gradient there, so it's a different method. But it doesn't matter. So like, you have this small table of numbers that you're trying to optimize, right? So take a large collection of meshes. Ideally, what you would want is you want to tweak the table, run the whole optimization process, measure the number of vertex shader invocations on all of these meshes across multiple different GPUs, and then, you know, if it's better, then you keep the adjustment to your table. Many people did genetic algorithms, actually, I think, as part of their computer science courses in the university, and this is similar to that too. So the problem is you don't have, it's too complicated to get like multiple different GPUs and actually run this code and stuff like this. So I built simplified models of how I believe GPUs work that count this number without like running the GPU, and then ran this multi-day optimization process in a large series of meshes, and then came up with like 32 numbers that are perfect. And then you know, I use these 32 numbers that are perfect. So there's like tricks like this that are interesting, intricate. And again, so this problem has an interesting property. You could try to get all the way to the optimal result. It's very, very hard because we don't know how. You could try to get within 1%, or you could try to say, oh, I'm running on AMD GPU versus an NVIDIA GPU. And AMD GPUs do this way, NVIDIA GPUs do this that way. Sometimes you can get like an extra 1 or 2% out of this. On modern GPUs, it's so having run the optimization process at all is already so good that, you know, the extra like small little details matter a little bit less than you would expect. They still matter, but They matter less because this is just one stage of the pipeline. And even if you have a large mesh with many vertices, it's tempting to think, oh, what's taking time during the rendering of this mesh must be all of the vertex shader processing that's going on. It's complicated. Sometimes it is, sometimes it's not. If you haven't optimized your index buffer for vertex cache, probably your vertex shader applications are not doing very good. But if you have optimized it, it's very, very likely that other stages of the pipeline restrict your performance in ways that kind of overshadow the extra like 1 to 2% gains that you could have from like the more optimal sequence or whatever. But yeah, so all of these problems are hard. So going all the way back, this is why mesh optimizer exists, right? It exists for you to not think or care about, oh, like on an NVIDIA GPU, the placement policy is like this, and you run the function gives you an index order, and index order is reasonably optimal for a large set of GPUs. On some GPUs, it doesn't matter as much. So on GPUs that just take your entire vertex buffer and just run the vertex shader on every one of them, like it doesn't matter. They're better in other ways, but this algorithm doesn't matter as much there. But you run it, it basically never hurts. You run it once during the mesh processing, it's fine. And then you get the final index order. And that's what you feed to your GPU, and your GPU is happy. So yeah, this is another interesting property of Mesh Optimizer, which this problem kind of exemplifies is, so you don't really know how your GPU works, because the graphics vendors don't tell you. If you have like console access, then sometimes you have more in-depth information. But even then, A, it's partial, B, it's about a given model. So, for example, in game development, there is this unfortunate trend, there used to be this unfortunate trend, at least, of, so people would build games for consoles, build proprietary engines for consoles and stuff like this. They would get like a lot of knowledge about how the GPU in that console, which all happened to be AMD GPUs until Switch, and it's the same generation of AMD GPUs, which doesn't help. So it's like you have a single type of GPU that you have spent 5 years of your life like digging very deep and like shaving off cycles and stuff. And then you just assume everything else works like this, because this is your model of hardware now. Well, it turns out like different GPUs are different. So the vendors don't tell you how they work, and if you know that the problem even exists, then you can try to figure out the properties of the problem. But sometimes you don't know. So like with this vertex cache, right? The vertex cache specifically is a well-researched subject because there is multiple papers written and stuff like this. But if you don't know that the order of indices in your index buffer matters, it may never occur to you to ask. Does it matter, right? And there's many cases like this where sometimes the answer is yes, sometimes the answer is no, sometimes the answer is on some GPUs it is, on some GPUs it's not. One of the values of Mesh Optimizer is honestly just, if you read through the entire manual, it may teach you things implicitly about the behavior of graphics cards that you didn't know existed. It's like, oh, like why does this thing exist? Well, it's because things are complicated in this way. So yeah. So this is the vertex.
And can you tell me if you have in Mesh Optimizer functions to analyze, like for example, to generate
right.
hash and then like analyze, so get information back? How it come?
So this is actually directly related to the thing I just mentioned, or when I worked on this problem originally. Every time you work on these optimization problems originally, let me backtrack. If I gave you two index buffers that represent the same mesh but had a different order, you wouldn't be able to tell the difference, right? So like, I could, if I showed you right now Mesh Optimizer running, you wouldn't see it other than like, I could show you an unoptimized mesh versus an optimized mesh. And for these optimizations, they don't change the rendering result, unless your rendering is like dependent on the triangle order, which it shouldn't be. Like nothing changes. So how do you know which one is better, right? And it's difficult to work on any of this type of stuff without having any metrics. So I originally built some basic versions of the code that basically looked at an index buffer and asked, okay, how expensive do we think this buffer is in the sense of how many vertex invocations do we think the sort of the GPU would do here? There's a classical metric called ACMR, average cache miss ratio, which is like number of, I think, divided by number of triangles. It's a weird metric to think about because it divides like vertices by triangles, and it's like, who knows? There's a better one called, a lot of the work I do on Mesh Optimizer, at some point in this process of working, I end up having to write some code that gathers some metrics around the specific problem that I'm working on. And then, because we don't know the optimum, and we don't know kind of how to get there, and we deal a lot with heuristics, what I end up doing a lot is, okay, here's like a scatter plot for like my collection of like tests, like 100, well, more than 100, but like hundreds of meshes. Here's like 100 points on the graph, right, that measure some specific property. And I changed an algorithm as here's a different 100 points. Or here's how it changed. Like, is it better, is it worse? Like, it's better on some meshes, it's worse on others. How do you quantify this? So when I did all of this work way back in the day, I wrote some functions to compute these efficiency properties of given buffers. You aren't really supposed to use these functions. They're not for you. They work for me. And actually, after I did this genetic algorithm type stuff I was talking about, I changed these functions to be more accurate to the behavior of the hardware, and then I use these functions to run this optimization process. But it's like, okay, so here's a random example. On an NVIDIA GPU, the vertex shader runs 32 threads. Everything runs 32 threads, like everything runs in warps. And the model that I described earlier, where you take a slice of index data and you like compute duplicates out of this and then you give it to GPU and stuff like this. In that model, it's convenient to assume that if you have a single vertex shader warp, they're called, that runs 32 vertices, processes 32 vertices, it's convenient to assume that these numbers will not have duplicates because it processes 32 vertices, writes 32 outputs to whatever buffer it writes them to, and then the rasterizer can just take any 3 values out of this and like use it. On some older NVIDIA generations, I don't know. So there's like a paper on this, I don't remember the authors, but if you Google for like NVIDIA vertex cache behavior or whatever, there's a paper where people reverse engineer the specific behavior of the NVIDIA hardware of some older generation. I think it might have been GTX 1000 or something like this, or GTX 900, so like an old card, a pre-ray tracing card. And it turns out that you have this reuse, but it's limited. And I think if you have, basically out of the 32 vertices, there's some sliding window that's smaller than 32 that can be used by the rasterizer to pluck things out of the result. But if you have the vertex in the beginning of this 32 sort of thread, and at the end, a rasterizer may not be able to take both of them and use them for like rasterizing a triangle. So my point is basically, okay, the actual hardware behavior is like weird. And it's weird in different ways on different GPUs that you don't want to know because you can't even optimize for this. There's really surprising results from this. So I think when Tom Forsyth came up with his algorithm, at the time, NVIDIA had a version of an algorithm. I think it might not have been open source. I think it might have been on consoles or something. I don't remember. And it like tried to model exactly what happens in the hardware and tried to optimize things carefully for it. And like on many meshes, the heuristics algorithm did better because we don't know how to optimize. And it's very, very easy. An algorithm usually can't have a very perfect local view into the problem. It's like, okay, if I assume right now the vertex cache or whatever, whatever the actual hardware state is at the point, looks like this. If the next triangle we see is this is what happens. This you can model if you know exactly what the hardware does. However, if you try to build an algorithm that uses this knowledge, you end up doing local decisions. You end up being, I think I should pick this triangle next because this is what will happen. Often you end up with a local minima, or maxima or whatever. So like you sort of think you optimize things, but your algorithm make decisions that looked really good at the time for the algorithm state, But if you look at the result, actually the traversal is suboptimal in some way, and it's hard to know. So this is like just a generally difficult property, and this is why it's very difficult, even if you have the precise model, to optimize. And so yeah, you can kind of, you can convince yourself that you can do much better because you know the exact specifics, but then you try to build an algorithm based on these specifics, and sometimes it's not better. So it's a complicated space. But yeah, the good news is that, well, the model that we'll get to mesh shaders at some point, but so the model that I described is interesting, all of the vertex hash and index buffer optimization, stuff like this. It's interesting because it's the one thing until mesh shaders that has survived. For many, I was trying to remember before our conversation when index buffer appeared in earnest. I don't remember, I don't know, but like I know I used them in DirectX 7. I think they may have been there in DirectX 5, I'm not sure. This is a thing that goes back like decades before GPUs got shaders. Vertex caches existed. And so the fact that today there's behavior that resembles a vertex cache, it's not a vertex cache, but it resembles a vertex cache, that has persisted through, it's like many versions of DirectX and vertex shaders and programmability and compute shaders and all of this is kind of like fascinating. But fortunately, whenever you use mesh shaders, you don't have to think about the vertex cache.
Right now, we're not even in the minutes. By the way, I'm looking at how many things are there on the list to talk about, and like maybe we are actually going for the
good news is we talked about the most complicated topic out of the traditional rendering pipeline. I think everything else we can do.
Okay. So in the traditional rendering pipeline, indexes and remapping, then now vertex cache, and then next on the list is over-optimization. Can you highlight how it works?
Let me super briefly talk about overdraw and then a couple other things, just because I think they're less relevant, less interesting, and stuff like this. But let's talk about overdraw briefly. So the overdraw optimization is one of the things where I think in my documentation I say, it's optional. You may do this, you may not do this, and it's a thing that used to be more important, and it kind of stopped being important like many years ago. Depending on the renderer that you write. This is again going back to, it's like a collection of tools. Sometimes a tool is useful for you, sometimes the tool is not. So if you render a mesh and the mesh has triangles that are arranged in the order such that you're likely to see a triangle, so if you have a triangle that's like further away, you're going to render that, and then you're going to render a triangle that's closer. The GPU will generally respect the order that you have put the triangles in, and so it won't render them literally in sequence because it's a parallel beast, but it will preserve the order usually. And so what this means is that if you have the triangles kind of arranged in this way, then you may shade the pixel that these triangles cover twice. Now the caveat is probably you have depth prepass, and if you have a depth prepass, you will process a pixel twice, but you will process it inside the depth prepass where it just writes depth, and that's fairly cheap. And then after this, so like the cost that you will pay for triangle overdraw is actually fairly small. And then in some renders you don't have depth prepass, like it happens. So there's some renders where you don't really have a depth prepass, or depth prepass is only used on some geometry. And then if you render, overdraw is a scene-specific property, really. Like you can't optimize a mesh for overdraw, because what if I render 5 meshes and they're like structured in a way that one includes the other? And even if you render a mesh, I can render it from like multiple different angles, and in one angle the triangle order is this way, and in one angle triangle order is that way. If you have a mesh that is convex, so if you have a cube, it actually doesn't matter what order you draw triangles of the cube, the overdraw is going to be 0. Because usually you have backface culling, and so a cube would have 3 of its faces, or so 6 of its triangles, like facing camera, and then 6 back-facing. The back-facing ones are going to be culled, and then the front-facing ones are going to not cover each other because they're all, they're disjoint. So if you have a convex mesh, generally speaking, your overdraw is 0. But you can have weird meshes that have weird structure. So, okay, let's say you have a house, and the house has chairs inside it. And it so happened that it's all part of the same mesh, because you're very draw call conscious, you merge everything together, all of your textures is one thing, etc. And so you have chairs inside the house. And you're rendering the house, and if you render the chairs first, and then the walls of the house last, then you're going to process the pixels of the chairs twice. And if you're going to render the walls first, then when you process the pixels of the chairs, are going to be rejected by the depth test and not result in any fragment work. And so I have an algorithm that heuristically optimizes this kind of inside-out order, where if you have a complex layered mesh, the parts that are inside should go after the parts that are outside in the index order, so that they're rendered after this. And this is a property that's invariant to the view direction, because if you like the chairs inside the house, regardless of the direction that you look at the house from. But again, it's not there's like reasons for why the library has this algorithm. It's like occasionally useful, but it's not part of the default. So when you're building a pipeline, you have to run reindexing because your index buffer is probably terrible. You have to run the vertex cache optimization because like otherwise it's just like there's no reason not to, and otherwise you just are going to see performance impact on some GPUs. You don't really have to run the overdraw. Overdraw is like, okay, in some specific cases it helps, but like it's not a generally necessary thing to do these days. And then you usually have to do the vertex fetch, and then you usually have to quantize the vertices. But like all of the other stuff is not super necessary. Let's ignore vertex fetch because it's not super interesting. It's like you just have to run it. It's fine. Let me briefly talk about vertex quantization to just conclude the rendering pipeline so that we can get to other like interesting things. Because so you have to realize all of this existed in the library from its first years, and the library was created in 2017. So it's been 9 years, and so like I think last year I wrote. I think in the release announcement last year I wrote 99 and a bit years, something like this. So basically it's almost been a decade, not quite thankfully, and a lot of the traditional algorithms have really solidified in the first few years, right? Because this is the first thing you work on. But this is like kind of distant history for me at this point. So let's just briefly talk about the vertex quantization, because this is this example of you should read mesh optimizer documentation because it will tell you to do a thing, but it will not really do a thing for you. You should just do a thing. And this is this is going back to this: how do you represent the vertex components question? So when you run your vertex shader, the vertex shader has to read data from the vertex buffer. Sometimes this read happens automatically because you use like an API that forces you to bind the vertex buffers, and your vertex shader just declares inputs. Sometimes you can do this, and you often should do this now manually. Like your vertex shader gets an index from an index buffer, and then it can just read the data indexed by that index from whatever buffers you like, in whatever, however you like them to be structured. But the general idea is very simple. If you have less data that you read from memory in the vertex shader, things are going to be better. It's very straightforward. Things are going to be better for two reasons. One is you'll just spend less GPU memory on this. And GPU memory is also an important optimization kind of target for Mesh Optimizer because, memory is expensive these days. The other benefit, of course, is that these reads will come out of memory, and then they go through a cache, which is like a traditional CPU-style cache, I would say, like an L1 cache, L2 cache. They go through a cache if data that's referenced by the vertices is not in the cache. There's a cache miss, and the GPU has to do some other work while it happens. And the less data you read, the less data you have to read from memory, which will reduce the time that your shaders spend not actually doing useful work and all of that stuff. So generally you should just prefer compact data, right? And this is a property where, we talked about vertex cache. The property of the vertex cache optimization that's useful is You do this, you don't think about this, it doesn't change your rendering result, it just makes things faster. If I gave you a float, you can't remove the information from a float without affecting the rendering result. Sometimes the results will not be affected significantly. Maybe the pixels are identical because you moved the float by like an epsilon and it turned out it didn't matter. But maybe it did matter. Maybe you introduced a small gap by moving a vertex, or maybe you were trying to remove so many bits from a value that the results did change, right? So there is a series of trade-offs that you make in your processing pipeline that are potentially affecting the rendering result. And when you make them, you have to figure out, it's like, okay, for example, when I'm storing normals. So it's a bad idea to store normals as 3 floating point, 32-bit floating point values, like a terrible idea. It's also a terrible idea to store them as 3 half precision values, although it's half as terrible, I guess, but it's still bad. There's optimal ways to store a normal that involve using octahedral encoding, or there's a few different encodings that people come up with. But how many bits do you dedicate to each encoding? Which encoding do you use? Because there's not one, there's like 3 or 4, right? And all of that depends on your application. So normals are a good example where if you are just doing diffuse shading, the normals are very resistant to kind of removing information from them. You can store a normal in like, I don't know, 10 bits for the entire vector probably, or something like this, 12 bits for sure, and not see results in diffuse. But once you do specular, it's very, very easy to see quantization artifacts in specular if you quantize the normals, if your mesh was high density, because sort of you removed enough information from your normal vectors, which displaces them, which rotates them kind of in different orders, and you could see artifacts, right? So it's kind of similar, I guess, when you store images in JPEG, right? You can select the quality. And the lower you go in quality, the more quantized the underlying representation is. And the further you go, the more blocks you see. And sometimes like on some images it may not matter, but on some images it does, right? So you have to quantize the vertex data, but how you quantize the vertex data is very, very dependent on the application, right? So Mesh Optimizer has a couple of helper functions, really, just because, so when you take a float and you want to store, let's say you have a float, let's say the float is from -1 to 1, which, normal components are, and let's say you want to store a float like this in a byte. There's a very basic, very classical representation that's hardware supported by like directory, 10, etc. That's called snorm, signed normalized. It's basically you just store an integer, and an integer has an uneven minimum maximum. So like if you have a byte, the maximum byte value, the maximum signed integer value in a byte is 127, and the minimum is -128. It's asymmetric. For normals, it's really, really bad to do asymmetric ranges because you want to represent 0 exactly, and you want to represent 1 and -1 exactly. Otherwise, things break down.
Oh my god, this code is so fucking nice.
So the representation is very simple. It just says 127 maps to 1.0, -127 maps to -1.0. We ignore -128. We lose like one value out of the representative values of the byte. 0 maps to 0, and then there's just like a linear range there. If you take a float to convert this to this range, it's very simple. It's a few math ops, but you have to round correctly. If you have the value that's like, closer to like -37 than to -38, you should use -37. And people who do this, it's very, very easy to write this by hand and mess it up. And when you mess it up, your precision drops, your error basically goes 2x because you didn't do your rounding correctly. And because of this, Mesh Optimizer provides this function, not because it's like very difficult to write, but because it's an example of the function, it's written correctly, and if you use it, you don't have to think about this, right? But otherwise, vertex quantization is kind of up to the application, and the reason why Mesh Optimizer documentation even mentions it is not, it's like, oh, this is a thing that Mesh Optimizer solves for you. It's like, this is a problem that you have, and you should figure out what you're going to do about this problem, right? But it's, you're on your own. But yeah, so the minimum pipeline is basically reindex, optimize for vertex cache, optimize for vertex fetch. We skip this one. It's like go read the docs. I just don't want to take too much time on this. But it's a very basic, important step. And then you do vertex quantization. And then there's some stuff that you can do on top, but this is kind of the minimum bar. If your engine uses Mesh Optimizer, it probably does these things. If your engine doesn't use Mesh Optimizer, shame. But at least you should do these optimizations. If you are not using Mesh Optimizer and are not doing this optimization, then that's like pretty bad. Although again, it's complicated because if you only ever run on Apple GPUs because you're building an iOS only game for some reason, then some classes of GPUs have like sufficiently weird behavior that the degree to which different optimizations affect different GPUs matter in different kind of aspects. The vertex cache matters like fairly like to a large degree on modern desktop GPUs to this day. The vertex fetch that we did not talk about doesn't matter as much, but there are some mobile GPUs. So there are mobile GPUs that I mentioned in the beginning that shade your entire vertex buffer. I actually lied a little bit. It's not your entire buffer. It's the range between the minimum index value and the maximum index value. So if your index buffer has indices 1 and 1000, and it's just two indices, let's say it's a triangle, so it's three indices, whatever, 1, 2, and 1000. It's going to shade like 1,000 vertices. So some older mobile GPUs do this. And vertex cache optimization doesn't fix this because it just reorders things. Sometimes you can be in a position where you have like really suboptimal index data like this. And so when you use mesh opt functions, like you don't have this because everything is like tightly packed and stuff after the result, after the end. But there's like specific cases where you can look at this and you can be like, oh, I used the vertex cache optimization and it didn't save me anything, so I guess I don't need it. And the problem there is A, on some GPUs it may be way more necessary than on others. B, it may not be needed because you tested it in such a scenario that doesn't care. Like if you're rendering a million cubes, you don't really optimize a single cube for a vertex cache. It's so small, there's so many vertices there that it doesn't really matter which order your triangles are in, like it's fine. And so in that scenario, like you don't care, but then you start rendering meshes that are very complicated and you forget about the fact that you haven't really done due diligence on your pipeline, and then this is when it starts to matter. So, but use mesh, it's really fine.
You mentioned a shame if you don't use Mesh Optimizer. We didn't talk about this, but Mesh Optimizer is open source with MIT license. I want to come back to this like at the end, generally. But like, if you want to use Mesh Optimizer, it's right there. It's in the open. You can do it.
Yes.
There's nothing stopping you from using it.
This is not a sponsored episode because there is nothing to sponsor.
On the vertex quantization, last question to sort of wrap it up. It introduces the artifacts, and so far we were kind of like, you just can do it and like don't watch, just call the function, that's it. How would you test it? Imagine like, you already have a scene you're building next to a Witcher game, and like we are now include Mesh Optimizer. So how do we want to now go through all the assets and see what are the behaviors or what are the like artifacts? Like, how do you want to do it?
Yeah, so for quantization, there's a couple of different ways to do this. The industry approach is like, usually to just test it, I guess. There's some things that if you've built pipelines before like this, you just sort of expect that some things will work and some things will not work. And it also depends on, it depends a little bit on the types of the mesh, types of the geometry. So I guess maybe just a couple of quick things. So one is when people quantize vertex data, it's very convenient to use half precision floats because it's just like there, it's fine. Half precision floats have around 11-bit effective precision on a given interval. Like if I gave you if I told you a mesh is like 3 meters, and so the vertex coordinates are from like 0 to 3, then on that entire range you get around 11 bits of effective precision for a component, because it's like a 10-bit multiplier plus an implicit 1 bit. What production renderers usually do is they would usually use integer precision, because integer quantization, because you could have the same 16 bits that a half precision float is, and then you can take the bounding box of the mesh, and then you can rescale the vertices to go from 1 to 0 within that bounding box, and then you can use the integer quantization that I was talking about. And that gives you sort of the full 16 bits of precision. So there's things like this that are different in different representations. And also there's going to be some meshes where, for example, positions cannot really be quantized without a very apparent loss of precision, of like visual fidelity. Things like this get more interesting, I would say, in mesh shading, because there you have more options that are available for you. But I think what I've seen in production pipelines often is, for example, by default you enable quantization. Normals are an example of a component that you can't quantize to a fixed number of bits. So I mentioned like 12 bits for the whole vector, which is too small. But normals you can usually quantize to like, I'd say like 20 something bits for a normal if you use octahedral quantization, etc. It's going to be a thing that you can just enable and just never think about, because it's going to be fine. Some production renderers use like 24 bits. I think some use like 20. So there's somewhere in the range is going to be a value that basically you're never going to hear from an artist again. Positions and texture coordinates are going to be examples of things where you will hear from artists again. So what I have seen, for example, in production pipelines is either we look at the extents of the mesh and we say, oh, this is too large, so we think the apparent error will be too large, so we are not going to quantize. Or we're going to quantize everything, and then artists will occasionally come to us and be like, oh, this mesh looks terrible, and there's a checkbox for them to check to like disable that. Or I think Unreal does this, maybe, but maybe not, I'm not sure. If you're building a complex game, it's very, very handy to give your artists basic classification. So like this is a small prop. So like a small mesh, like a I know I'm looking at my desk. It's like a mouse or a keyboard. I guess you wouldn't have a lot of these in a game, but or like it's a large prop, or it's a character, or it's a piece of an environment, or it's vegetation. So give them like 10 categories, and then usually within the category it's a binary decision. It's like, oh, small props are fine, large props, I don't know, like characters maybe you quantize with like more precision. But there's multiple different things you can do there. I think the critical property there is like to think about this problem and think about what would make sense, and then test a couple options, and then kind of ship something. But I think this is one of the reasons why, if you look at Unity, I believe Unity spent like a long time not doing vertex quantization at all, like anywhere in the import pipeline, which is like very, very inefficient. But I think for them, they didn't really want to build, presumably, I don't know, I never worked there, but presumably they didn't want to build like complex heuristics to figure out if it's fine or not. And because it's a general purpose engine, you don't have an option of artists going to like Unity people and asking what's up. So maybe they just didn't want the complications associated with this. But again, so even if you only quantize the basic vertex format, the most basic thing if you have a PBR pipeline is a position, vertex position, texture coordinate, normal vector, and tangent vector. Sometimes you don't have tangents, sometimes you have other stuff, it's complicated. Even if you just take this, so let's do the math. Positions are 3 floats, normals are 3 floats, texture coordinates are 2 floats, and then tangents are usually 4 floats because there is a vector and there's like a winding component. So that is, I was not actually doing the math, I think there's 14 floats. Even if you ignore position and texture coordinates that are sensitive to quantization errors, even if you completely ignore them and then still store them as floats, you can still take the other half of the vertex and compress it like 4 times by doing quantization with like fairly small bit count, because for all of the vectors, directional vectors, the default 32-bit is just crazily excessive. So even just this is a safe choice that basically any engine can make. And even though it's not optimal, you can get more. But even just that is so much better than doing nothing. And I think Unity didn't really do that, but I'm sure by now they do. Any production engine, I would say, at least advanced vertex quantization, because this is a thing where this is a widely known thing that you can do and should do. Some of the other stuff is less widely known.
Okay, so this wraps up the rendering pipeline. We went through indexing, vertex cache optimization, we kind of skipped fetch, and then vertex quantization. And there are a couple of actions that you can, everybody can read on the Mesh Optimizer docs, which, by the way, crazy good resource to even learn what is actually happening in between the lines. Really good, like on point, like very technical, straight, direct. I really love it. Now we move forward. Do we move to mesh shading?
Let's talk a little bit about mesh shading. Just as a, I won't go too much in depth on this, I guess, just to be conscious of time. But the pipeline that we've been talking about with like vertex shaders and index buffer and stuff like this, so it still exists. It's still relevant. It's still what you'd see probably 90% of the game engines use for like most of their content. So there is a new way to the way this pipeline is structured is literally around this idea of what is how do we know when we need to run the vertex shader. And there is this abstraction, which is the index buffer that sometimes spawns vertex shaders. We won't tell you how much, how often. So when compute shaders got introduced in DirectX 10, before this, all of the shaders kind of told you that they are doing things one element at a time, but just in parallel, and you didn't really have visibility into what happens under the hood. I think compute shaders were the first case where, so when you run a compute shader, it's just general processing. But it's not general processing one element at a time. It's a processing one group of elements at a time. You say how big the group is. And so you say, oh, I want to process things in groups of, like, let's say 64 elements. And I know my function is going to be run 64 times for each element inside the group, but the different invocations inside the group kind of happen together, sort of in lockstep, not quite in lockstep depending on hardware, but and we will even give you special APIs, in compute shaders case it's shared memory, that allow different threads to talk to each other. This API, I guess, got refined later with like other features, but mesh shaders represent a similar shift where sort of it's a different way to think about the pipeline that goes on before rasterization. We did not talk about, and we will not talk about, all the other horrible shader stages that happen before the rasterization, because like, oh, isn't there like tessellation, evaluation shader, and geometry shader, and tessellation control shader, and I don't know, maybe there's more that I'm forgetting right now, but like, so if you look at the entire pipeline diagram in DirectX docs, it's like complicated, there's like many things. And this is a representation of the industry spending many years kind of experimenting with ideas and shipping some of these ideas, and then learning that some of these ideas don't work super well. So geometry shaders were like this, where people thought geometry shaders were awesome for a whole bunch of reasons, and then it turned out they are not efficient from the hardware perspective, and so they're still there, because you can't unship a feature once you ship it, but
welcome to hardware.
So mesh shaders are another attempt, or an attempt, to basically rethink that entire pipeline, right? So there's like vertex shaders and tessellation evaluation shaders and geometry shaders. So what if none of this stuff existed, and you only had one stage? There's task shaders, but let's ignore this for now. The only really important one is mesh shaders. So what if there was one stage that took actually the thing that I was talking about earlier, where one way that GPUs could implement the current model is by looking at a slice of the index data, and then kind of deduplicating this, coming up with like a bunch of things, doing vertex shading on that batch like at once, and then giving the whole bunch of results to the rasterizer, and then having the rasterizer work with that. Mesh shaders are an attempt to do that, but sort of expose this directly to the user in a way that the user can understand and reason about and control on the programmatic level. So forget everything that you know about like existing shader stages and index buffers and everything. What you get instead is you get a shader stage, one shader stage that runs before the rasterization pipeline, and its job is to give triangles to the rasterizer. How does it do this? Well, it would be inefficient to give a triangle 3 vertices at a time. So the way you give it to rasterizer is you give it a bunch of vertices, and then a bunch of triangles that reference these vertices. So it's kind of like a micro mesh. There's a vertex buffer and an index buffer. But the number of vertices is small. And you directly tell the rasterizer the maximum amount there when you build the shaders and stuff. So let's say you have up to 64 vertices. And then let's say you have up to 100 triangles. I will not go into the exact numbers because this podcast will go for too many hours then. Then because you only have 64 vertices, your index data could actually be 1 byte per index instead of 16-bit or 32-bit. You just need 1 byte, 8-bit. And this is what your mesh shader outputs to the rasterizer. And when the mesh shader runs, instead of running like a vertex shader where it processes like one triangle at a time or one vertex at a time, it kind of processes the whole batch of all of the vertices and all of the triangles in one compute-like shader invocation. And it's up to you, so it runs multiple threads. You tell the GPU how many threads you want to run, and then it's up to you as to what to do. For example, you could say, I have 64 vertices, but I'm only going to have 32 threads in my invocation, and this is how the NVIDIA's original extension for this works, because NVIDIA sort of pioneered the extension work there, at least. And because I have 64 vertices, and somebody needs to transform them, but I have 32 threads, I'm just going to take every thread and then process 2 vertices, because there's a total of 64, right? And then you need to output triangles, and there's up to 100 triangles, so maybe I will take every thread and have it process up to 3 triangles. And when we say process, the most basic shape is just give the rasterizer the 8-bit index data. There is complex stuff you can do in mesh shaders. So, for example, you can do calling. You can do geometry synthesis. Like you could say, I'm going to render a bunch of cubes, and you can represent each cube with, let's say, the cubes are Minecraft-style cubes, so they aren't even rotated. So then you can represent each cube with like a center, and that's it. I don't know what else you need, like some texture coordinating, like a material, right? So a mesh shader could literally take a chunk of voxel data and then just generate like a cube from it. Because you're limited in the amount of output data inside one mesh shader invocation, you have to think about how you do this. It's like, okay, a cube has 12 triangles, we can output up to like 128, so I guess it's 10 cubes per mesh shader invocation, stuff like this, right? So you have to think about this, you have to budget things, and also the real hardware works in surprising ways sometimes around mesh shaders, as it usually does. So there's some performance things that are very non-obvious. But the basic idea is a mesh shader gets like a bunch of index data, passes it to rasterizer, gets a bunch of vertices, transforms all of the vertices. There is no vertex model. So the mesh shader literally outputs data to the rasterizer, which means the rasterizer never cares about the workspace position of your vertices. It only cares about the clip space, the post-transformed projected data. Now, so that's cool. How do you get the data that you're going to give the rasterizer? You have to do 2 things. You have to split your mesh into these small chunks. They're called meshlets, usually. Sometimes they're called clusters, but this term predates mesh shading, so I like the term meshlet when referring to the sort of mesh shading specific stuff. So you have to take a mesh, you have to cut it into these tiny blocks of data. For every block, you have to have a bunch of vertex data. You have to have a bunch of triangle indices that are indexing like inside this buffer. So your first problem is you need to cut the mesh into pieces, right? And so this is already a difficult problem. Like, how do you do this? It's not super clear. It's not super clear primarily because sort of how you do. There's many different ways how you could imagine cutting a mesh into like units of like 64 triangles, right? And going back to our earlier conversation, some of them are efficient, some of them aren't. Some of them are efficient on this hardware, some of them aren't. I'd say this is a developing space because NVIDIA was the first to ship mesh shader support in their like ray tracing capable GPUs. And the features are not related, but it's just they had an RTX card. The first RTX card supports ray tracing and tensor cores and mesh shaders. It was a big release. And then AMD shipped mesh shading support starting from RDNA 2 generation, which is Radeon 6000. But there's a lot of weirdness around the hardware support in that generation. And so then when they shipped the next one, the RDNA 3, the efficiency properties changed a lot. So, so there's complicated issues around kind of the efficiency in that one. Also with mesh shaders, there is this fantastic hidden property that I actually didn't learn about. So I wrote some algorithms to basically split the mesh into these clusters. We don't really have time to talk about the internals.
Oh my god.
It's like, it's the same type of problem where it doesn't really have precise solution, you have to do heuristics, it's not super clear what you optimize for, etc. One funny thing is, so if you look at the extension specification, it just tells you here's the API, and then if you look at the NVIDIA blog post, it just tells you, split the thing into meshlets and stuff like this. And so I wrote some algorithms to do that. They got refined since. But one funny property that I accidentally learned about later was that for NVIDIA hardware, the order of the triangles inside this micro index buffer, the 8-bit index buffer, matters. You kind of give the code at once to the rasterizer, but maybe the rasterizer has some magic. This is the type of thing that the vendors don't really tell you about. So Mesh Optimizer has basically two functions, more than two, but it has a class of functions that gives you a bunch of meshes for your input mesh. And that's just a partitioning where for each meshlet you get like vertices and you get this micro index buffer that you can then take this data and then just directly plug it into your mesh shader and then directly render this stuff on the GPU with a mesh shader extension. And now there's also a function called optimize meshlet, which takes a single meshlet and within that meshlet reorganizes the data so that it's like efficient on various hardware. I think in general though this is interesting because so only a subset of GPUs support this. There is some efficiency consideration around like is it a good idea to do it in a given case. There's some complexity around if you are, God forbid, using tessellation. Mesh shaders don't support tessellation. You can implement tessellation with mesh shaders. They are powerful, but they are also constrained and complicated, and so it's difficult to do, right? And so there are some games though that have, so one game that is known to have done this is Alan Wake 2. So Alan Wake 2 switched to using mesh shading basically in their renderer. I think they may have a fallback path for like older GPUs, I'm not sure, but they have a meshlet kind of first render where they think about their meshes as a bunch of meshlets and then they use mesh shaders for this. They use Mesh Optimizer, of course, to prepare the data for mesh, of course, for the mesh shaders and stuff like this. There's reasons why you might want to do this. So Mesh Optimizer helps you by giving you the necessary functionality to even start, right? It doesn't tell you what to put in your mesh shaders. So there's a bunch of things that you can do in the mesh shaders that is difficult to do in the traditional pipeline. For example, you can do additional forms of culling that Mesh Optimizer does help you a little bit with. So one intuition, so we talked a little bit about the overdraw. Let's take a different example. So let's say I have a big sphere, or it could be a big character mesh to make it less abstract. Let's have a character mesh, and you cut the mesh, and it has like many thousands of triangles. And then you cut the mesh into these patches, meshlets. Every meshlet is compact. It's in the same place on the mesh usually. Like it makes no sense to take a bunch of triangles from different places in the mesh. It's much more better when things are local. In a given character, there's going to be a lot of meshlets that are facing away from the camera in their entirety, like they're on like a backside of the character that you don't see. Traditional rasterization pipeline involves taking every triangle, running vertex shaders even for the vertices that are part of the triangle that you never see. Because you don't know if a triangle is going to be seen until you process all three vertices. You have to have done all the work. And then submitting all of this to rasterize, and the rasterizer looks at the triangle and it's like, well, the triangle is like backpacing, so I'm not going to draw it. Well, so you just wasted a whole bunch of vertex processing and rasterizer throughput to figure out that you don't have to render half of the mesh. Great. Mesh shaders way, for example, to do this calling on a higher level. So instead of doing, everybody does process calling for meshes, right? But meshes are large, and a mesh of a character is like has both front-facing triangles and back-facing triangles. But a meshlet might not have front-facing triangles, and there's ways to do ahead of time. So you can ahead of time build basically a code within which a camera will never see a meshlet. And this cone might be fairly wide, and so if the camera is inside a cone, we have a static guarantee that the entire meshlet, all triangles in the meshlet are backfacing from any point within that cone. Mesh optimizer has a function that helps you do this, and this, it doesn't do perfect, like it's a conservative approximation. It can't ever, you know, like if the triangle potentially is visible, it has to tell that some of the triangles might be. But you can build this conservative approximation, and if you use it, you can reject the entire meshlet, or some number of meshlets basically can be rejected by not even looking at the individual triangles. Similarly, if you have an occlusion calling set up in your engine, which modern engines should do, there's a way to do this that's like basically perfect. But if you have occlusion calling, you can even set things up such that the characters meshlets in the back of the character, even if some of them have complex geometry, so it's like partially front-facing, partially back-facing, your occlusion calling system could call it away because it's occluded by sort of the front of the character. And I will not go into details, but basically you can do this, and once you do this with meshlets, you have much higher rates of calling. Because if you do something on a mesh level, if you see a character, right, if you see even a small portion of the character, it would be a waste to process the whole character. And so meshlet-based pipelines give you a way to do a lot of these optimization phases in your runtime shaders on a sort of medium granularity. It's smaller granularity than the whole mesh, but it's larger than a single triangle. And so for this, they're like very, very good. You can build very efficient pipelines with them. And then we talked about quantization. Well, if the vertices of the meshlet are in a tight sort of proximity, the bounding box for the meshlet can be very small, which means you might need much fewer bits to represent each coordinate within the meshlet, because you could have per meshlet you could store like a bounding box, and then every vertex inside the meshlet would be relative to this. All of this has complex stuff that I'm not going to talk about, and also Mesh Optimizer doesn't help with some of this, because it's like, oh, yeah, I can quantize vertices within the meshlet, but then a meshlet next to it shares some of the vertices, and if you quantize a vertex on the boundary between two meshlets in different ways, you will see gaps. So how do you not do this? How do you quantize sort of without this? There's ways to do this. So you mentioned Mesh Optimizer documentation. Mesh Optimizer documentation doesn't talk about things that Mesh Optimizer is literally not involved in. Sometimes that's not great. I have a couple of plans for additional sections at some point that talk about like, so you like integrated Mesh Optimizer, now what, right? Basically, what are the problems that are adjacent to the things that Mesh Optimizer solves directly, that it can kind of put you on the right path, right, without like even having necessarily functionality for it. But anyway, so yeah, so this is meshlets. Meshlets are interesting because it's kind of an evolving space. Everything that we've talked about with vertex cache and stuff like this is kind of, you know, old story. It's been there for years. People have done this, etc. The mesh shading related functionality is new, fresh, and evolving. So, for example, last year I've added a new optimization algorithm for meshlet partitioning that takes a mesh and gives you a set of meshlets. I have 2 of them now. The reason why I have 2 of them now is that NVIDIA now has support for ray tracing from meshlet data. It's NVIDIA only right now. I don't know if it whatever the AMD story for this is, I don't know. But if you're on NVIDIA hardware, you can do meshlet-based ray tracing. They call it, there's a marketing term called RTX mega geometry. But the thing about that is the criteria for how you split a mesh into meshlets differ a lot based on whether you use rasterization or ray tracing. Because when you use rasterization, you're concerned about the efficiency of the rasterization stages and how well things are packaged. And when you do ray tracing, you're really concerned about the boundaries between the meshlets and how axis aligned they are, because the ray tracing hardware builds axis aligned image structures around this. So it's different problems. There is not a single. If you build a single set of meshlet data, it would be suboptimal for one of them. And interestingly, the suboptimality for ray tracing is much worse in the sense that, so if you took raster data and gave it to the ray tracing stuff, you would see more of a performance drop versus if you took the ray tracing optimal structures and you use the raster pipeline. So you could have a game where you almost don't use ray tracing, in which case even if you use these extensions, the raster only data is fine. You could have a game where you mostly run ray tracing with occasional rasterization, in which case rasterization data, ray tracing data is fine. If you have a game that wants both to be optimal, I don't know what you do. I don't work in games which is working like this. So this is not ideal, but this is kind of how the world works, right? I think the mesh optimizer tries to kind of embrace and grapple with the real problems of how the real world, how the real hardware, how the sort of real engine pipelines work. Without, you can't wave away something like this where it's the data is just fundamentally different efficiency properties. So anyway, and this new algorithm is literally used last year because NVIDIA only released this new capability last year, so it only really became important last year, right? So a lot of the stuff is evolving, but
for people who are following, to make sure that they're on board. We first talked
and
about
we lost everybody notice.
People are vertex shader, rasterization, and fragment shader. This is the traditional pipeline. It's heavily used, and this is what we discussed in the beginning: vertex buffers and index bufferization of the ordering stuff. Now we talked about replacing vertex shader with mesh, a new concept regarding meshlets. This was the second part of it. And with both, Mesh Optimizer helps and has a function that you can call. Now we're moving forward. I feel like we're skipping mesh compression, or do you think we should talk about?
Let me briefly, I'm going to cover it in 5 minutes. I think mesh compression is interesting to talk about also because it's a different way how to use the library that's not like the other ways. So when we talked about the other ways, we said, okay, it's usually an offline process. Sometimes you use procedural geometry, but often you don't try to do this offline. So the other thing that Mesh Optimizer has, it has several compression algorithms that are specialized towards mesh data. So you give it vertex buffers or you give it index buffers. I'm working on a new thing where you give it meshlet data. It's not fully ready yet, but it's coming along. And so it compresses it and then it decompresses it at runtime. Very straightforward. You can think about this as I don't want to use the word replacement, but you can think of it like a traditional general purpose compression algorithm like Z standard or ZLean or whatever. So there's a question of why the reason why these are different at all is that if you compress the data, you need to decompress it, right? So the idea is in your offline tool chain, you use mesh optimizer algorithm to compress your data after you like prepare the document and stuff like this. And then in your asset streaming code at runtime, you load the bytes from disk from whatever that don't have the GPU ready representation yet because they're compressed, and then use mesh optimizer algorithm to decompress it. So this is the one case where you kind of have to link the library into the main runtime code, right? Because you have to compress. So I don't want to talk about the details. Are very interesting and complicated. I don't want to talk about them, or we just don't really have time to talk about them. But so, like, why do they exist is the question, because there is still even standard stuff, right? There's two things to say about this. So one is there is a lot of types of redundancy in the mesh data that traditional algorithms can't recognize because they don't know what to do for. The basic thing is the vertices are likely to be close to each other, and so even if you just do delta compression on the vertices, then you will have a better result. But the general purpose algorithms like the standard or Zilib or whatever, they don't do delta compression because they don't know your data structures. They just look at it as a set of bytes and try to find matches in bytes or try to build statistics around bytes. The triangle data, the index data gets has the crazy amount of sort of redundancy inherent in it, especially for optimized index buffers, and that none of these algorithms recognize very well. And so you will compress your mesh data with traditional algorithms. They will work. They will not give you as good of a compression rate. But also, some of these types of compression can be restrictive in ways that make it much faster to decompress. So the interesting, so the vertex compressor is like an interesting example. It's kind of counterintuitive, but here's the deal. So you can compress with Z standard, and it's going to be fine. And Z standard will decompress at around 1.5 gigabytes per second on my system, on my desktop system. Z standard decompresses around 1.5 gigabytes per second of mesh data per core. So if you have more cores, you have more. You can decompress more. If you have a worse CPU, so like on something like a Steam Deck, it's much less. My algorithms usually can compress the vertex data a little bit better than Z standard out of the box, but they will decompress 3 times faster. But the reason why they decompress 3 times faster is I can't replace Z standard. I don't know, maybe I could. The big reason why I don't even want to go and replace Z standard completely is so on consoles you have, I forget on some PlayStation models, they have hardware accelerated decompressor that is better than I think even the standard in terms of compression ratio, but it's in hardware, and so you can't compete with that. It's an impossible job. And so instead of competing with the standard in the sense of replicating what it does plus adding more things that it doesn't do, I do things that it doesn't do and don't do things that it doesn't do. What it means is that my compressed representation can be then compressed again, which is usually don't think is a bad property, right? If you have a zip file, you can't zip it again and reduce the size. That makes no sense. But with my data, you can take this data and then again de-standard it or zip it or whatever, and usually you get it to be smaller further, right? So when you use mesh optimizer compression, you kind of have options. You can say, oh, I'm just going to compress with mesh optimizer and it's small enough, I'm just going to ship it and it will decompress much faster. Or you would say, well, it's not small enough, so I will take the output, I will compress it again with Z standard. And then when I decompress, I have to decompress twice. Z standard decompresses and then mesh optimizer decompresses. But because the Z standard decompresses less data, because it decompresses into a compressed representation, if that makes sense, it runs faster. It's still 1.5 or whatever gigabytes per second, but it needs to output 3 times less data, and so it runs 3 times less time. And so the total output is still faster to decompress than just using the standard, and it's much smaller. So this is an interesting space because it's super difficult to navigate. Because you have all of these conflicting requirements, should the data be small enough, should the data be fast to decompress. How small is small enough? Compression has these horrible curves where people who do compression for like, you know, like Z standard type stuff, right? They would usually like kill for like a 1% extra compression ratio.
Oh shit.
And you could have a compressor that gets you like 5% more compression ratio, but takes like 10 times longer to decompress. And in some spaces in compression, this is like a welcome thing, and it's kind of a fundamental property of the space. Like at some point, you have to spend way too much extra time. I have this layering property, right? And also, I just don't want to compete with all of this. But the final thing I'll say is, one of the motivations why all of this like is valuable is just the disks are getting faster. So 10 years ago, it didn't matter as much. Probably more than 10 years, but 1 year ago. So when you have a hard drive and it reads like 100 megabytes per second in a good day, then it's like if your compression algorithm can decompress at a gigabyte per second, then you're already way faster than your hard drive. If your SSD can read 4 gigabytes per second, and modern SSDs can be in that ballpark or higher, if your decompression algorithm decompresses at 2 gigabytes per second, you could be better off just storing uncompressed data on disk. Like, yes, it will be larger on disk, but it will take less time to read, unless you can use multiple cores to decompress. But if you use multiple cores and you're streaming data, which usually are in modern games, then you're taking away CPU resources from the rest of the game. So there's like lots of trade-offs here, but because of this, basically, I saw this space of, I want to have compression algorithms that work really well for mesh data, that are not peak size, like they don't, it's not the minimum amount of bytes you can squeeze a mesh into, but given that I want to decode at like many gigabytes per second, right, on modern hardware, how small can I get it? And if you want more space savings, then you can use this standard. So yeah, so this is the one case where you basically have to use Mesh Optimizer at runtime, but you don't have to use, so again, Mesh Optimizer is like a collection of tools, right? If you don't like compression algorithms, like don't use them. If you like one of them but don't like the other one, then don't use it, it's fine. Some of the production games use them, some of the production games that use Mesh Optimizer don't. I'm judging a little bit, but I'm not judging too harshly.
I'm judging just a little, just next on the list is mesh simplification.
Alright, great.
We're going deep on this.
Are we? Oh my god. Okay, so I don't. This is a fun thing. Maybe it will give people a little bit of perspective. So this is probably one of my least favorite areas of the library, but also I have a love-hate relationship with this area of the library. Let me put it like this. So what does it do? I give you a mesh. So far we've discussed algorithms that either don't change the appearance of the mesh, or that change it in quantization case, but they change it in like a predictable way. Like, you know, I give you a vertex, you like throw away half of the bits of the position, okay, the vertex is gonna shift. Simplification, people call it decimation, people call it mesh reduction. It basically says, here's a new mesh that kind of looks approximately like the mesh that you gave me, doesn't look as nice, but has half as many triangles, right? And then you use it in two cases really. Usually you use it to just build level of detail data. So you take a mesh, you build a simplified version of the mesh that you swap in at some distance. You can simplify the original mesh. I think it's usually called like level of detail 0 simplification or something in some engines. But basically, if I gave you like a scan, like a 3D scan, or if I gave you a mesh that just has an insane resolution and you just imported it in an engine, you may never want to render it. It may just have too many triangles. So like, you know, maybe it's just not a good idea to do it. But that's the basic idea. It's very, very simple. You give me a mesh, I give you a mesh with fewer triangles. So this is a terrible problem because people like the way the meshes look, and it's so easy for a human eye to spot imperfections that are way less obvious for an algorithm. So much so, it's difficult to get. There are some metrics that measure like the deviation between the level of detail and the source, but even that is hard. That is hard, and so in images, in 2D images, there is like decades of research of metrics, of similarity metrics, right? Like, does a human think this image looks perceptually indistinguishable from another image? Even that is a hard problem. Meshes are like, harder problem because you could render a mesh from a given angle and you could compare the image, but what if the angle changes? What if the scale changes? What if differences in different attributes influence the appearance based on the shading that you use? Like the silhouette of the image looks fine, but the shading is all broken up because some normals don't look properly on the resulting mesh. So this is a difficult problem. I built an algorithm for this, like a first basic algorithm, like many years ago.
Die.
And then, so here's what happens with algorithms like this. You run an algorithm. So the first problem actually is actually more fundamental, I guess. So most of the research for this comes from the 90s. There is like a couple of papers. I think 1999 is the last super important paper, and in the last 26 years you could ignore. There are some papers. Some of them are like valuable, but you could ignore them and it could be fine. Which is an unfortunate property because clearly in the last 25 years things have changed in the rendering space in general, right? But the fundamental research hasn't really changed. The fundamental research that powers a lot of algorithms. And the fundamental research is very, it's great and not great at the same time. It forms a good, so there's a thing called quadrics, which is basically a way to approximate how a portion of the mesh surface looks like using like a small number of floats. And then you can use this to both measure the error, like, I built this functional approximation for like this mesh, and then I simplify the bunch, and then I compute this function again for a simplified subset. It gives you the error, and it also gives you information to reduce complexity in the mesh by basically just looking at areas of the mesh where this function tells you the error is low, and like simplifying them by removing triangles. There's like the foundational element of most of these algorithms is called edge collapse, where you just take an edge and then just fuse the two vertices together, which removes two triangles that were connected like to the mesh like this, right? So it removes two triangles, and if you remove two triangles at a time, eventually you'll get a mesh that's much smaller. The problem is, so it's very, very easy for a human to look at the result and say the result is obviously broken because this thing should be there and this thing should be there. And there is relatively few algorithms, and again, like not a lot new since like 1999, that have meaningfully different sort of. People write papers that are like, we tried this thing and it made the thing like better, and we shipped it. And this is true, but there's few like kind of foundationally new things in that space, and it's fundamentally difficult because you have this sort of thing. You have an appearance of the mesh that is judged by a human, and to get to this appearance, you run a bunch of shaders that you don't know what they do, and there's all sorts of like strange stuff that happens. So let's say you have a mesh, and the mesh has textures, which they usually do, and textures have gaps. So if any artist ever tried to like UV map a mesh, it's like so actually this is interesting. A thing that artists hate the most, as far as I can tell, is UV unwrapping. And the thing that's also really terrible for simplification is the presence of unwrapped UVs. So there is a lot of commonalities here. But so you have a UV unwrap. Let's say you have character's hand, and the character hand has fingers, and when these fingers are unwrapped on a flat texture, you have to like cut the sort of the mapping around some edges that are usually called UV seams. And usually what happens is inside the texture, you have like, for example, you have like the front side of the finger in like one place of the texture, and the back side of a finger in another place of the texture. And when the artist paints the texture, when some algorithms paints the textures, they like ensure the edges line up very neatly. And you know, a human looks at this and you can't see the difference. And then the simplification algorithm comes along and it's like, well, I don't like this edge. Let me like contract this edge. And something terrible happens in the texture. And so there's many different ways. And so the reason why it's difficult to work on these algorithms is you run the algorithm on a mesh. The output looks bad. You're like depressed because what are you going to do? So the algorithm makes certain decisions. Some of them are wrong. So you can improve the algorithm. Sometimes the algorithm makes decisions that are correct. As in the algorithm's mathematical model is perfectly implemented in the code. It just doesn't work very well and it's like not clear what to do about this, right? So it's fundamentally a thing that has so much subjective, like human intuition built into the judgment of the result. But also, all of the other things that I've already talked about layer on top of this. So I don't want a simplification algorithm that takes minutes to simplify a mesh. They exist. Sometimes they're better than what Mesh Optimizer does in. I'd say so. What Mesh Optimizer does in like everything else is basically better than. I haven't seen things that do it worse. Simplification is the area where I can't claim, oh, it's better than everything else you'll find there. Like it's not. Part of the reason is it does things differently in ways that are like important structurally, but so basically there's extra restrictions that I haven't talked about that I probably won't talk about that make it more difficult to do a good job. But also I just don't want the thing to be very slow, and so because I don't want the thing to be very slow, I'm limited in the things that the algorithm can consider, which makes the output be not as good. Or another example is I talked about the textures. If you have a texture mapped, at some point, ideally, if you are generating LODs, you have to switch to a different layout of the texture. So there are some commercial simplification tools that do this process called remeshing and then retexturing, I guess, where they take like a house. So a house is a great, terrible example. So you take a house. The only way to build a good level of detail of a house that's like much smaller is to build basically a new mesh that looks the same but doesn't use the original texture. Because you have to take the source texture, you have to like take some of the pixels out of it that did matter. But if you take a house and you're like replacing it with a box, the box should have like details of the windows and stuff like this. Some of them were modeled with geometry in the original mesh. Some of them were modeled in textures, but the parts of the textures where they are all over the place because the unwrapping kind of follow the geometric shape. And so you kind of have to rebuild like the whole thing. But so it's called Mesh Optimizer, it's not called Texture Optimizer. So it doesn't, in some cases it's painful to integrate something that needs new textures for new LEDs, and it's sometimes less efficient. And so Mesh Optimizer basically tries to solve a subset of this problem. I was very unhappy with the current state of this for like many years while I was not working on this, because so I worked on this code at some point, and then I looked at the results and I'm like, man, I kind of don't like the results, and then it's difficult to motivate yourself to improve it. So I've worked on this a bunch more in the last 2 years, and I think I'm now content with the algorithm, as in there are choices that it makes that are terrible, but it's like you could, even if you do terrible things. So I guess I'm at that stage.
High level, what have you changed? Like very high.
So there's a lot of stuff that goes really into the details of. So one interesting thing is So when you do these simplification decisions, you have to evaluate the error. And the original version that I built like a long time ago didn't really look closely at the attribute data. So it would just evaluate the error of positions, and it would ignore the attribute. So that's bad if you ever have like normals or whatever. And this is where there's a problem. So if you look at the research of the from 1999 of how to solve the problem, they tell you, well, you can build a functional approximation of the error that doesn't just look at positions, but also looks at attributes. And there's a way to like efficiently, compute this and stuff like this, but
I try not to pigeonhole
let's say you have let's say you have an edge collapse that changes the position and changes the attributes. I mean, they always do. But you have to figure out, is this edge collapse better than median in the sense that so if I change the attribute a little bit, but the change is over the entire triangle. So let's say I have a large triangle and I take one vertex of it and I just tweak the normal a little bit there. You could have a large perceptual change because the triangle area is so large that the shading changed a little bit. But because the area is so large, the human eye is like, oh wow, like this was a LOD change, right? Whereas if the triangle was very small, but the change was more abrupt in the attribute, sometimes it's more acceptable. But the other really difficult part in all of this is that the mechanism that I described, the edge collapses one edge. You need to collapse like lots of edges. And how the error accumulates during these collapses is very difficult to model precisely unless you have like too much time, unless you can take minutes to simplify mesh. It's difficult to model like the accumulated error well. And so so the research from 1999 kind of doesn't tell you to do the right thing.
Michelle, you're on the air.
And I haven't really seen anything published since that tells you how to do things differently. Plus, I had a bunch of like some bugs and some other stuff in the way the error is accumulated. And so basically, the state of this was years ago I wrote some code that takes attribute values into consideration, and it worked. And it looked similar to what I can see research from like 25 years ago. But it didn't look very good.
You know how they
so
say
I was
in
like,
Vegas,
I don't know what I do. So yeah, so since
happens
then
in Vegas
I figured out some things
stays
around the
in
math
Vegas.
there that were like
Yeah,
not
I always
right.
thought that was like,
I figured out
phrase
some
for
bugs.
acting wild and all that,
There are
but
some things that because my
these
algorithm
startups
is
seed money will be
prioritizing
staying in
the
Vegas.
performance of generating the output
Silicon Valley
result.
update number 5, of course.
To an extent. It's not the
I really
output
came out
priority,
to
but
Vegas
it's
this
a
weekend
priority.
to find
There's
myself,
again certain things that I
and I
have to do
mostly
differently, and that stuff
lost
is just not like you read any source code that's
myself.
not maximizer and it doesn't do things.
I don't know how to tell
And
investors, so I
because of
figured
this, it's also
public
difficult
announcements
to, like,
probably the
is it
easiest
a bug
way
here, is
to
it
rip
not a
off
bug?
the Band-Aid, but hey,
so I fixed a lot of
we're gonna
bugs.
persevere,
I came up with like a different way
we're about
to
innovation.
combine these errors
We're
between
about
attributes and
commitment.
positions.
We're about
And then
the values.
I came up with
Of
some
the
other
Silicon Valley.
modes that I can't
I
really
just didn't
explain
find them out here in
too
Vegas.
much in the weeds, but
So,
some of
you know
the
how they
internal
say in
basically of
Vegas,
how the algorithm decides
what
if it's
happens
safe
in Vegas.
to collapse an edge have changed to make some things
Those
like more
RTMP
permissible.
ingest
And
URLs
so
are the literal
the
type of the
aggregate of
stadium
all
cameras
these
for the
changes,
FIFA
right,
broadcast
means that it's
distribution
like
chain. Camera,
different
RTMP
now.
ingest, media time,
There is
broadcast
still many
partners, your
problems,
TV. If
or
an attacker
not
pushed a video
that
to one of
many.
those RTMP
I think like every
endpoints
time
with
I
the
look
stream
at
key,
this
which is
again,
right
I'm
there
like,
in the
okay,
URL,
there's
they would
fewer
replace the
problems
camera feed. The
and fewer
PGM
problems,
program
so like,
feed is the main
But
broadcast
there are
output.
still
Replace that,
cases
and
where,
every TV network receiving the FIFA
basically there's
feed
still
shows
sort of
whatever you
bugs
push. The
that
stream
are not
key is shared across all 5
clear
camera
how
angles
to
per
fix,
match. A
right?
single attacker
Even
could
debugging
hijack every
this stuff
camera
takes
simultaneously.
forever
Man,
because
how did they not?
you have a mesh and something
An attacker could
happens
have
during
rickrolled
the
an
whole
entire
sequence
FIFA
that
World
makes
Cup.
the
That's
mesh
like
look not very
1.5
good.
billion.
But you have to
That
look
would
at
have
how
been
we got
the
there.
greatest
There's usually
rickroll
one
of all
specific
time.
step
Those
in
RTMP
the algorithm
ingest
that causes the most
I gave
embarrassing
users access to my app this week,
But
and
going back
they
to what we
immediately
discussed
told me
earlier,
everything that was missing.
it may
The
be
idea
a
behind
well-intentioned
repertoire is
step.
simple.
Like
It's
the
your
algorithm
music
looks at the
library,
state that
organized
it's
by
at, and it's like, oh, this looks good, and it's not good. But to figure out why it's not good, you have to consider all of the past decisions that the algorithm has made, and it's like difficult to do. So yeah, I think it's just an inherently like frustrating problem in some sense, just because there's no optimum. It's difficult to measure the optimum. There's so much subjectivity, and there's so much variability in how you might use it, how you might not use it. Like, do you have different attributes? How does your shader work? What do you compare to?
If it ignores
Because,
something, it ignores other things from time to time. Yes, that's the point I'm making. I think I've kind of understood it at this point, which is if you want something to be successful, you start off with the change, which is what I'm building.
I think it's always been true when you look at the code written by developers. Good developers write good code, other developers write code that then breaks. And the same will be true for the people prompting the AI tool. People who know what they're doing, who understand systems, will be able to prompt tools to write good code.
Okay, I haven't figured that out. So I don't know about that. I'm still trying to figure out this whole prompting it to make it write better code business. Okay, I'm trying my hardest. All right, I have a lot of skill issues. Okay.
Yeah, we've got our own LOM. We're going to build our own systems. That's where we're at. We actually need more power. NVIDIA. We're going to get some computers for y'all.
There are a few fundamental. Your Spanish obsession is your with the abundance of agents. We now have people who don't really have any coding experience. Just being able to Spotify ships 4,500 production to.
And when I see people saying, "Hey, 99% of our code is written by AI," I literally get angry because those same people, I pretty much guarantee that 100% of their code is written by computers.
It's actually this right there is my this tweet. Can we just all Mark Andrees? I'm struggling. By the way, because you should.
Okay, how many projects that were on the cutting room floor got moved above the line because of the productivity gains? Because 25% of.
So everything that I told you about the simplification just now, and actually everything that I told you about all of the other areas of the mesh, they would usually work in, they would consider the mesh as a unit of operation, right? Sometimes maybe you have a mesh subset. Sometimes if you do simplification, you may want to simplify like a bunch of meshes even at once. But the usual approach is you take a mesh and then you do a bunch of operations to it and then you get a different mesh. Sometimes it's simpler. Sometimes it has like fewer triangles, right? Sometimes it has fewer vertices. Sometimes it has different orders so that it's more efficient to render. And then you can feed the result to GPU and the GPU will be happy. So with simplification specifically, one challenge is usually the way you would integrate this is you would build levels of detail, and it's what's usually called discrete levels of detail. So there's a level of detail 0, and then there's a level of detail 1, and then there's a level of detail 2. And there is thresholding in engines for when to switch between one and the other. The configuration of thresholding is a separate can of worms. Like there is like distance based and like screen area based, and all of this is pretty bad because it doesn't consider the deformation in the mesh. Mesh Optimizer has like an error metric for this, which works pretty well. But even then, there's at some point a decision that the engine makes at runtime to switch from mesh to mesh, from mesh LOD to mesh LOD, and this usually is causing pops. These days, most engines do temporal anti-aliasing of various ways, which has a hilarious side effect of kind of sometimes doing a crossfade between the level of detail like automatically, because like it looks at the previous object that you've rendered, it's roughly at the same depth, it's roughly at the same color, it's like, it's not good enough, I'm gonna like blend between them, and they can get hidden a little bit, but fundamentally you're changing the mesh that you render, right? So it's not visually pleasing. And then the other problem, so I've told you the mesh optimizer side of simplification, right? So you have an algorithm, it can like build a simpler version, stuff like this. In the industry, so you could do that. Some people do. You could use other commercial offerings. There's like Simplegon and some other stuff. They're usually artist-driven. They're usually so mesh optimizer thing is completely automatic, and the commercial ones are usually partially artist-driven, as in like an artist presses the button and it gives it in ULSD, and then they're like, yeah, I don't like this one. Sometimes there is ways to, for example, if you have a character, you could paint the weighting of the priority of the different areas of the character. Mesh Optimizer has library support for this, but it's not a tool, like it's not a plugin, right? And so some plugins that are proprietary, they give you ways to like control this, right? And so at some point the artist is like, this looks good enough, ship it. So there's a human in the loop. Sometimes the artists do the loads by hand. This still happens today. Especially, so Mesh Optimizer works reasonably well on a certain simplification range and certain geometric style. There's some geometric styles where it's very difficult, it doesn't do the right thing, but also there's some geometric styles where it's just like super hard, even with all of the techniques I mentioned that Mesh Optimizer doesn't do, like the remeshing with retexturing, you still get terrible results. Sometimes the only clean way to do this is to get a human and like have them do like, I don't know, not creative work at all, which is like, here's a mesh that has 1,000 triangles, it has to be 100 triangles. I don't care what you do, but it should look exactly like this from a given distance. And it's like, okay, great. What am I doing here? So on the flip side of this, there is workflows where you do 3D scans and you get a mesh with like millions of triangles. So Quixel works like this. Like you can go to Quixel, I think it's called Quixel site. They have like rock models that are 3D scanned and meshed. And so you download a 3D model, and then it's like, 4 million triangles for a single rock. And also, I should not bring up GenAI. Hopefully you're not using GenAI for meshing, but if you are, that geometry is terrible. So, this is a difficult space to work with, right? Because you have a human in the loop sometimes, and if you don't have a human in the loop sometimes, the results are not very good. Whenever a switch happens between LEDs, the switch is instantaneous for the whole mesh. I should say there is research from the 90s around continuous level of detail. But that research doesn't work today at all, because it has a very different hardware model in mind. A simplified explanation would be, there is research from the 90s called progressive meshes. You can use it today. It's bad for two reasons. One is the CPU has to do too much work. There's some research that avoids this, but to kind of simplify the mesh on the fly to smaller numbers of triangles. Two is the resulting mesh, even in methods that are optimized for the CPU, it's not vertex cache efficient. It turns out that if you have a mesh that's not vertex cache efficient, you could render a mesh with way more triangles for the same cost that would look nicer. And so these are kind of in tension, right? The goal is not to simplify at any cost. The goal is not to reduce the triangle count at any cost. The goal is minimal perceptual loss, but also hardware efficiency. And so it's hard to reconcile all of these. So, Epic released research in 2021, I think, or so, which is kind of industry defining because it gave the industry a new path that engines since then have started implementing. So you had folks from Ubisoft. I'm blanking on the name. Sorry.
Nicola Lopez.
Yeah. So I think they talked about sort of micropolygon rendering in their latest Assassin's Creed games. There's some other games that are starting to do this. But so there is this trend, which is basically Nanite, but Nanite is an Epic technology that is now just part of Unreal Engine. So what Nanite does is fundamentally a way to do continuous LOD, but it is based on a cluster hierarchy. So think about this way. You split the mesh into clusters, and then you take a bunch of clusters that are near each other. You take them out of the mesh, then you simplify the result. You simplify the resulting group of clusters. You get fewer triangles, and then you split the thing back into clusters. And then you put the resulting clusters back into the mesh, and then you repeat the process. But every time you do this, you remember all of the intermediate decisions and data that you have made. So your final output is not a simplified mesh. Your final output is every simplified cluster set that you have made during this process. And the reason why that's important is, and there's caveats around how to deal with boundaries with clusters, and there's caveats around hardware efficiency and all of this, because once you build this hierarchy, there's two hard problems here. First is you build the hierarchy, and then the second one is the runtime component that actually takes this hierarchy and then has a mesh that is in a given place in the view frustum and asks which clusters in this giant hierarchy should I pick such that the visual error that would be that would represent the switch from the original mesh to the set of clusters is minimized. But this is not discrete. It's similar to the thing I was talking about earlier around meshlet calling, where you make decisions on the meshlet level. Here you make decisions not quite at the meshlet level, but the simplified way to think about this is you take clusters that are too detailed for how far back they are in the brief frustum, and then you replace them with simplified clusters that you have prepared earlier. And you can do this at different depths, at different places in your mesh. Like maybe part of your mesh is closer to the frustum and part of the mesh is farther. So the part that's closer, you keep more high resolution clusters. Maybe some parts are so far away that you replace like hundreds of clusters with just one. It's complicated because you have to make sure you don't introduce gaps. If you just take a few clusters and then simplify them, you have to preserve the boundary. And how to preserve the boundary, but how to have an algorithm that builds this whole job in that context. Here you have what's potentially millions of meshlets in your original data, which is like hundreds of millions of triangles. How do you efficiently do this LOD selection per meshlet, basically, per meshlet group? And how do you produce this set of clusters is complicated. Plus, Nanite has extra runtime craziness because their triangles are so small, they target triangles that are under a pixel large. Because the notion then is this. So I told you how switching from LOD to LOD is perceptually obvious because you've just changed the whole mesh. So the Nanite idea is like this. What if every triangle was targeting around the size of the pixel on screen? Then, if you have a cluster that has triangles that are too dense on screen, you swap it out with at some point, like they become a little bit too small. So a mesh increases the distance from the camera. The triangles get smaller on screen. At some point, they go from being 1.1 pixel on average to being like 0.7 pixels on average. And you're like, okay, cool. I'm gonna like swap out a bunch of clusters with different clusters. But every error in every swap like this is pixel level. Because you took a bunch of triangles that were very tiny and you replaced them. And the idea is you will see a transition, but the temporal anti-aliasing will perfectly smooth out the transition because transition is under a pixel large, and literally the whole job of temporal anti-aliasing algorithms is to remove the shimmering and the aliasing that happens when it's under a pixel. So this is the idea, right? Because of this, they end up, by design, they want to render tiny triangles. And so they had to write like a software rasterizer to complement the hardware rasterizer to render triangles more efficiently and stuff like this. But the mesh optimizer part of this is less scary because it's asking this question, can you build a hierarchy of clusters? So it turns out mesh optimizer can build clusters for a mesh because mesh shading. Turns out mesh optimizer can simplify meshes. When you simplify meshes, you take the whole mesh and you simplify it, but you can tweak the algorithm in various ways to be able to take a subset and say, okay, I will preserve the boundary edges of the subset, I will like simplify the internals. The other important property of this pipeline is there's no human in the loop. There can't be a human in the loop because every transition is on a cluster level at different points in different parts of the mesh. You can have a human like bias heuristics. You can be like, oh, like this mesh should have twice as much detail on screen as the other meshes do, and it will like bias all of the transitions. But you can't be like, this cluster looks bad, let me remodel it, right? Like there's too many of them. When you decide when to switch from cluster A to cluster B, you need to have metrics that approximate visually. So like you have a number that says, I think the error on screen will be around the pixel between these two, apparent error, right? Turns out Mesh Optimizer kind of has to do this, right? So Mesh Optimizer landed in a funny spot where, unrelated to all of the Nanite stuff, enough of the components of this theoretical system kind of were 80% there, and so I kind of figured why not go 100%. But the thing about going 100%, so there is a component of Mesh Optimizer project, which is not a Mesh Optimizer library, which is called cluster.log.h, which is a header file. It's kind of an STB style header file, so it's like a single header. It's designed to just be copied in your project, like you include it in the source file and stuff. And what it does is it calls a bunch of different Mesh Optimizer functions, but so it has fairly little complicated logic by itself, because it's modeling the higher order algorithm of how to build this hierarchy of clusters and how to simplify them and stuff like this. So the thing about this is it's combining a bunch of Mesh Optimizer algorithms, but it does it in a somewhat specific way, and maybe you have a different way. Maybe you don't like half of this and you don't like the other half, right? Or maybe, so it uses specific simplifier from Mesh Optimizer, and it uses some specific clustering and partitioning algorithms that we haven't talked about and stuff like this. Maybe you want to use a different partitioning algorithm, but you still want to use this simplification code and this high-level loop. So this basically lives somewhere on the boundary between example code, but it's like 600 lines of code or whatever. So it's not example because it's too complicated to be an example, and you can take it and use it as is, but also some parts may not work well for your specific engine situation. Maybe some parts are underdeveloped. I don't know. This thing hasn't seen production usage yet. And so because of this, it's kind of a separate thing, right? That if you want to use it as a single header thing for just copying into your project and doing whatever with it, it's fine. If you don't like half of it, you can rewrite half of it. You can also just read it as these documentation, but in the code, in the sense that if you want to build your own thing that uses Mesh Optimizer, for example, but does different decisions, you still probably should read this flow to understand exactly how it works, so that you can then implement something like this, right? So it's kind of somewhere between example code and production library. You can take it as is, you can take it as is and change half of it, you can take it and then just read it and then, not use it, it's fine. So this is a separate part of the Mesh Optimizer, and because the runtime version of this is draw me the rest of the owl type of thing, where you have to do a bunch of shaders that do complicated stuff, it's less, even once you add the header to your engine and once you call the right functions, you get a bunch of data. What do you do with the data? There is a great NVIDIA project called VK Load Clusters. It's a Vulkan example that basically does the other half. So it uses Mesh Optimizer cluster load.h to generate the data. And then they have this whole pipeline of, because one thing I haven't talked about, for example, is streaming. If you start with meshes that are tens of millions of triangles, and you hundreds of millions of triangles, I don't know, and you can display them as just a few triangles on screen, if the mesh is far away, you kind of don't want to have the whole 100 million triangle monster in your memory, right? And so I think inherent in the notion of nanite is the fact that at runtime, you stream parts of the mesh, so parts of this. You can imagine this is like a giant tree of clusters, where the further you go into the tree, the more you replace simpler geometry with complex geometry, and at the very bottom of the tree, you have the original mesh subdivided into clusters. And so you have to do streaming, where you take this tree and sort of page in portions of that tree that you can then compose into a mesh on screen. And then there's all of the shaders that actually have to figure out what to draw and stream, and so runtime for this is complicated. I'm kind of, so nanite on one hand, nanite is super interesting as a new technology, and nanite style technologies, right? It's a new way to think about geometry rendering, which is very interesting. On the other hand, man, is it difficult to implement and integrate. Even Mesh Optimizer, it helps you. It does this cluster log stuff for you. but like the runtime itself is very complicated and compression is complicated, and with the rest of the mesh optimizer, it's so nice that you can have a very simple renderer that just renders meshes. And then you can go from like no mesh to mesh. With Nanite, it's like a lot of work to build the runtime. This is like an example of basically, and you think in computer graphics in fancy, they're not actually harder to get started with than vertex shaders. Like here you need to build Flag data a little bit differently. Mesh Optimizer does this for you. The runtime is very simple. Nanite is like the example where the runtime is very difficult to implement and to tune performance-wise and stuff like this. And even that is not the end, because if you look at the Unreal's like latest developments, they have this thing called Nanite for foliage now, where they can take this tree and replace parts of it with voxels. Mesh Optimizer doesn't have this yet, or doesn't have this period. I'm not sure if I'll ever get there. But basically, this whole they built really new, really cool technology that's also so complicated that I don't love the fact that it's so complicated, if that makes sense. I don't have like a great alternative other than to not do it and do things that way, but you know. There is, I should say, there are benefits and drawbacks to this technique, right? It is nice to be able to tell your artist just dump like hundreds of nodes of triangles into the asset pipeline and be done with it. But I don't know that it's globally optimal. Like basically, this is almost the reason why this thing exists. It's like saying, what if artists never had to care about complexity of the data that goes in? And on one hand, it's good because it sort of gives artists complete artistic freedom over what they want to do. But on the other hand, I have a renderer that I occasionally develop on streams that does like level of detail and occlusion culling and like mesh shading and all of this. It uses Mesh Optimizer. It does not have Nanite-like rendering, and I do not plan on doing this just because it's so much work, and I do most of that work on streams, and it would be like weeks of streaming, I feel like, to figure out all of the runtime bugs and to deal with the GPU crashes and to optimize stuff to just get to the thing that works. So I'm super happy that NVIDIA has a sample. So VK load clusters, it's very clean Vulkan code. It's Vulkan specific, but it's very, very clean. It's easy to read, and it uses Mesh Optimizer. So there's nothing not to like.
VK load clusters.
VK_load_clusters. Yeah, it's a GitHub project. You can just check it out. I know roughly everything that goes into it.
It's already.
And even then, I feel like it's at least a couple weeks to get components together, as in. But if you include optimizations and stuff, I don't know. It's like a month easily. I don't know, multiple weeks of work for sure. But I think if you include performance, it can easily be months. So people used to say this about temporal anti-aliasing, that it's like you need a full-time engineer. Not because it takes you like years of work to do this, but because you implement it and then something breaks, you discover an edge case and then you figure out how to fix this and then you discover an optimization and etc. So I think it's complicated sort of from this perspective, and not because the underlying techniques are well known and well studied, and so you can do them. But yeah, fully finishing this would take a long time in a production scenario. Just because you keep discovering things that break, and you keep discovering, you do streaming, but then you want to compress the data, and then you do some custom compression, and then you even there's difficult aspects. Here's the easiest way maybe to talk about this. So I told you that there's this tree, and so your job is to find, it's called the cut of this tree, and the cut because you can literally visually represent it as like a line that goes through the tree. that goes between different levels of the tree, right? So it's like, okay, we need this subtree and then this higher level of this subtree next to it and stuff. Okay. If I were to build the first version of the thing that takes the cut of the tree, it would take me like an hour or two. Why? There's a very, very easy way to do this. And the way to do this goes like this. For every cluster, you basically have a float that tells you the error of the cluster, and you can take this float to convert it to a binary decision, which is this cluster good enough or not? Cluster.h has like, it has this float, it has like comments that nicely tell you how to use this float to do stuff, etc. You can literally write a compute shader that goes over every cluster in your entire cluster tree, takes this float, asks, is the cluster going to be a cluster above it or below it or whatever, that eventually will tell you I'm good enough. So like the algorithm will be correct. However, your mesh has hundreds of millions of triangles, so it has millions of clusters. Let's say the mesh is far away. So you only want to render it using a few very coarse clusters. And so you want to select a total of like 15 clusters. But your tree has millions of them, so it's very inefficient. And you have to do this per object, it's the important thing. If the mesh is instanced like 100 times, every instance of the mesh may have a different cut through the tree that it renders at, right? If you have mesh that's close versus far, like it's a different set of clusters. So there is a very easy way to build this, which is you have a compute shader that goes through every cluster, asks this question, good enough or not, and then adds the cluster to the render queue or not. But it's going to be very slow. And so, how far do you want the efficient way to do this? There is an efficient way to do this that's documented in the so people who are interested in nanite, I feel sorry for the amount of time that you'll have to spend on this, but the reference, not documentation, like the talk is, there is a talk by Brian Harris who invented the technique, I think from SIGGRAPH 2021, I forget what it's called, like nanite something, and it talks about the runtime difficulties there. But so it talks about a way to do this selection of cuts efficiently on a GPU. A, it's quite complex. B, my recollection is that the way to do this optimally relies on undefined behavior in the GPU computing model. So there's this thing in compute shaders that's called forward progress guarantee. This poorly specified, and it's basically this. If you have a thread, so you can implement a spin lock in a compute shader, like, sometimes you need to. The spin lock could just be the traditional CPU-like spin lock, like you read the value is like 1, means somebody else has the log, you're like, oh no, I'll ask again, and then you spin until it becomes 0. Is the spin lock safe in the compute shader? And the answer is it's very complicated. And so my recollection is that the optimal way to do this nanite hierarchy classification may rely on some things that are not like fully specified in the same way that spin locks aren't fully specified. Because you are trying to map a very complex algorithm, not the one that I described. The one that I described that does a per cluster work is very simple. But what you want to do is somehow in parallel traverse this hierarchy across many different threads and somehow do little wasted work, but do this in a way that's safe to do in parallel. And so, doing that level of detail, right, could take you months. Now, do you need to go all the way down there to have a functioning render? No. But if your goal is to compete with Unreal on performance, then, the answer is like months for sure of runtime work. So, it's a very, very, very deep rabbit hole. But it's basically a replacement of the whole rendering pipeline sort of before the G-buffer. So it's like there's a lot that goes in it because there's like forms of culling and stuff like this. It's just it's just complicated. But yeah, the world was simpler before people do rendering, and now the world is more complicated.
GLTF ecosystem in Mesh Optimizer.
This is exactly what I'm looking for.
Can you tell me a bit about that?
Alright, so I mentioned in the very beginning that Mesh Optimizer is like 3 projects in the French code. We talked about 2 of them. And then the third one is GLTF back. And I guess there's also maybe it's 4. So there's GLTF back, and there's a related thing, which is you can take some of the mesh optimizer code and run it in JavaScript. So, okay, there's kind of 2 reasons why mesh optimizer even has a connection to GLTF. So one is I'm just interested in GLTF. I think it's a nice format. It has some downsides, some upsides, but I think it's the alternatives to GLTF I like much less. And so GLTF, for people who don't know, it's a Chronos specified format which you can use to store mesh and scene and animation and texture data. It's more than a mesh file. It's more like a scene file format. And you can store it in a reasonably compact way. GLTF is a JSON plus binary file. So JSON segment of the thing specifies like the higher level. I don't know. You have a node hierarchy in GLTF. And so this node hierarchy is represented in the JSON component of GLTF. But all of the binary stuff, like the vertex buffers, the index buffers, the animation data, all of that goes into the binary file. So it's reasonably efficient to load it. It's still not.
All 3 of them are method calls.
It's general, so I don't think it's always appropriate. I think usually I would not pick GLTF as a runtime engine storage format. It's very rare when this is appropriate. But this is not because GLTF is inefficient particularly. It's because it's general. We talked about the vertex formats, like, you may want to have a custom normal storage thing or whatever. GLTF doesn't support this, but also it forces you to support permutations of, it's like, positions could be that format, or could be this format. Texture coordinates may be there, or there may be 2 sets, or there may be 0 sets. Who knows? So you can write a renderer that natively supports GLTF. It's just if you wanted to write the most efficient renderer in the world, you'd want to have a lot of constraints that GLTF doesn't allow you to format the data this way, or forces you to deal with all of the other variations. But I think it's a nice format. If you want to work with that format, so there were kind of 2 problems for me. One is I was looking at GLTF, and I looked at the state of all of the efficiency things that I worry about, right? And I was like, well, all of this is not great because you get a random GLTF file. It has duplicate vertex data. It doesn't have vertex hash optimization, which you think it doesn't matter, but it does matter because you take a GLTF file, you load it in the browser in your renderer of choice. Well, whether or not this file has been optimized, has index data that has been optimized for vertex cache or not, directly affects the rendering performance on a desktop GPU, right? So GLTF didn't support quantization very well. It supported it a little bit, but mostly not. So I looked at this and I was like, okay, so one, I don't love the state of where GLTF files are, even from the perspective of the web ecosystem. So let's ignore the native stuff for a little bit. Let's assume in native world you have, even if you have GLTF files as an input, you have custom processing pipeline. In web world, people like to just render GLTF files. Well, it would be nice if the files that they were rendering were efficient. 2, so Mesh Optimizer is a library, right? One generally difficult thing to do is you can't develop a library in isolation. I don't know how people do this in other libraries. It depends on what you do. If you have something that's contained, if you have a PNG loader, you could develop a PNG loader with just a basic unit or like an integration test suite that just loads PNG files, right? But the Mesh Optimizer is like a toolbox. And one of the questions that I have about the toolbox is it easy to use? Is it sufficient to fully implement an engine, processing pipeline, etc.? You kind of want to have an engine built around this, not because I want to build an engine, but just because you want to fully stress all of the ways in which it can be used, right? And so GLTF seemed like a way to both have this end-to-end pipeline that uses Mesh Optimizer so that all of the algorithms can be exercised in that context. And also GLTF, could be better. So when I started going there, I realized, so because of this I built GLTF Pack. GLTF Pack is an application. You give it GLTF file, it outputs a GLTF file back. It runs all of the mesh-opt algorithms that we talked about. It does quantization for you based on what it considers to be okay, not good, in the sense that, as we discussed, like the perfect choices depend on the use case, right? So it's difficult to have kind of globally perfect idea of what to do, but it does some things. And it also does a bunch of scenery organization that is kind of outside of the bounds of Mesh Optimizer, but it's like things like you have a material, and the material has alpha blending enabled. But your textures attached to this material do not have an alpha channel. This means you are wasting CPU cycles enabling the blending unit, even though the pixels should not be blended. And also you sometimes are causing visual artifacts. And this type of problem is common in some GLTF files in the ecosystem. So there's this tool that exists, but when I started developing this tool, I was like, well, I want to do a bunch of things that GLTF doesn't want to let you do. For example, GLTF didn't have a way, so it had a way to, so colors, vertex colors, could be quantized in GLTF, and I think maybe texture coordinates, maybe not, but normals did not have a quantization format sort of in GLTF, which was strange. It was just an omission. I think when they specified the format, they forgot about this or whatever. They remembered for colors. So colors you could do 8-bit, normals you could not. So normals you were forced to use, and GLTF also has to support WebGL 1.0, or at least had to, as a baseline like expectation of what the GPU can do. And WebGL 1.0 does not do half precision floats. So GLTF didn't have half precision floats. So it didn't have quantization support, and so I was like, well, I want to fix this. So I ended up actually contributing 3 extensions now. So I contributed an extension to GLTF ecosystem, which allows use of quantized formats for the vertex data, which then allowed GLTF back to use this. But it's not GLTF back alone that does this. There is another tool called GLTF Transform that uses Mesh Optimizer for some stuff, but it's like a separate TypeScript-based application that does GLTF processing. It also does quantization. So I contributed this, and also I contributed an extension, so it's like 2 extensions now, for the compression that we talked about. So the compression that we talked about turns out to be a fairly reasonable fit for the Web 2. They have an alternative mesh compression from Google, and it's part of GLTF spec. But the problem with this is it's quite slow to decompress. So it goes into the problem that we talked about. It also, so when you run code on the web, you either run it in JavaScript or WebAssembly. The modern way to do this in WebAssembly. But even with WebAssembly, if you have complicated code that you want to run, it's a large binary that takes the browser a while to JIT on the first load. The process is cached usually, but the first loads are important in the web, because I give you a website, you go to the website, it has a bunch of 3D geometry.
I don't fucking care. I
fucking
don't care about vulnerabilities. I care about the fucking complexity. And then the domain happens to bundle a few decoders for compressed formats, because browsers don't support these things natively. And if these decoders are hundreds of kilobytes of WebAssembly, then these things take half a second or whatever to JIT. Is half a second a lot of time? Well, it's a lot of time to delay your first page load, complete page load for, right? So, and my decoder turned out to be fairly good for this purpose, because it's under 10 kilobyte of WebAssembly. It's very, very compact and it's very fast. But so my vertex decoder, decompressor, the reason why my decompressors are fast, the one that I'm working on right now is crazy in that regard, but even the vertex compressor, it's using SIMD fairly aggressively. And WebAssembly had SIMD support, or it had emerging SIMD support via a separate extension, but it didn't have a couple of instructions that I think were just generally really powerful, and every SIMD instruction set has instructions like about RISC-V, but so ARM has an instruction. The most important instruction in SIMD is called shuffle, and it's basically a thing where you give it a vector and you give it another vector that is determining indexes in the first vector that you should pull out. So it's like a table lookup that you do in every individual CMD lane in parallel, and it's super efficient. It's like one cycle, I don't know, it's like very, very fast. And you can express so many weird problems with like this single instruction, and they didn't have this. And I was like, well, if they don't have this, I'll just be sad because the CMD instruction set in WebAssembly is going to be worse. B, I will not be able to port my amazing vertex compression code to this without it running without CMD, which is much slower. So that's a problem. And so it's kind of funny, but as a byproduct of all of this, I ended up contributing so both to GLTF and to WebAssembly. So the instructions are now part of WebAssembly CMD. And then there are the couple extensions that are part of the GLTF spec. And I should mention it's kind of interesting because both GLTF and WebAssembly were quite friendly for like an unaffiliated contributor. Like, you know, usually, so if you look at the Vulkan specification process, to contribute to that, you basically have to work at a company that is like a graphics card company, because then you can like be in the right places and talk about the right things and try to force change. But if you are an external person, it's hard for you to contribute to Vulkan. And I expected that it would be hard to contribute to WebAssembly and GLTF, but actually it's like pretty, the experience is quite pleasant, I would say. So yeah, so that's why the kind of to go all the way back, you take GLTF back, it can produce a GLTF file, and that GLTF file can then use these extensions. So then you open this GLTF file in your web browser, and then if it's compressed, which is optional, but if it's compressed using Mesh Optimizer algorithms, then you load like an extra like 6 kilobyte file with like WebAssembly in it, which decompresses this on the fly for you and then puts it in like, you know, the actual vertex buffers in your WebGL context. So yeah, so this is kind of fun. I spend less time on this than I used to, just because I think it's mostly because you're constrained by what GLTF can and can't do. I've implemented like GLTF doesn't do mesh sets. It doesn't do it doesn't even have level of detail officially. There's like custom extensions, I guess, but in that sense, the format, the tool, GLTF pack tool is like more complete because the format is like more stable, and so it's easier to get to a point where you look and you're like, well, I don't know what else it's missing, right? It's kind of mostly there. But yeah, so because of this, I mentioned all of the various languages. Mesh Optimizer, so I don't maintain any of the bindings to any of the languages like other people have. Rust bindings and Zig bindings and Sharp bindings. The JavaScript ones, unfortunately, I maintain because they're kind of part of this whole like web system. But
I've seen that there are dye bindings.
Oh, nice.
Sorry, Slab, Mesh Optimizer there as well. All right then. After 3 hours of technical chat on this, I want to ask you a couple of questions that are a bit higher level regarding the library specifically. Mm-hmm. How the heck the library is open source with MIT license and free for everybody to use? Like, how did it happen that you chose this model? You chose this model for the development and like.
Oh my god.
How are you doing this? That you're working full time on it when this is like not a commercial library.
So there's two things to say. Yeah, so I mean, I think in general it's open source because I kind of believe in open source model more than I believe in closed source models. We are having this conversation. I'm running Linux right now. I did have to install Chromium because Firefox didn't work for the podcasting, but even Chromium is open source. Some parts of the stack are closed source, but the reason, so I think I in general tend to err on the open source side, not because of sort of ideological concerns, but more because of practical. So I use an editor, and I sometimes find bugs in my editor or things that annoy me.
being able to go look at the source code, find the bug, fix the bug, submit a pull request, and see it fixed, means that you're kind of more in control of your entire environment, right, than you would otherwise be. Some of these things are impractical, but I patched, so I use NVIDIA right now, which unfortunately does not have an open source driver, but while I use the AMD GPU, I ended up contributing a couple patches to the AMD open source driver. So being able to observe and occasionally fix the stack, I think in general super valuable to me. Because of this, I always liked open source, right? And Mesh Optimizer, so when I built Mesh Optimizer, I worked, I guess, at Roblox at the time, but the way that it got created was kind of like this. So I solved problems like this before in my professional career using some mostly existing libraries that I just didn't like. They were just not very good. And some proprietary stuff, I think, that just became obsolete. And then at some point, I find myself in this company, it's like, okay, I have to do a bunch of stuff. Some of this I know how to do. Some of this I had code for my pet projects from my engines, just it wasn't in the library form, it wasn't working very well, stuff like this. So then you have two options. You can write the code for the company that you work for. It's going to be proprietary, it's going to be owned by the company, because you're doing this on the company time and stuff. And then you quit the company, you join some other company, you have to solve the problem again. What the hell are you going to do? Nothing, I don't like solving the same problems multiple times.
Looking at right now?
So I think I was just thinking, well, I have this problem, I can't recommend an existing library. If I were asking myself, how do I solve this problem, can I use some other library? I was like, I don't know. There's nothing for me to recommend, so I guess I have to do this. But if I do this as closed, so if I just do this as part of my company's job, then it's going to be closed source. And
this is really.
And I think in general,
kind of cool, isn't it?
I think the more I work on all of these things, the less I like the company and product boundaries, and the more I like the sort of lifting all the boats type of work, where you can make a thing that gets integrated into a bunch of stuff, and that gets better as a side benefit, right? And it's just more interesting to me to do that kind of work compared to, it's like, oh, there's this specific thing that we need to solve for this specific product, and that product is going to launch, and then in 5 years this product is going to be dead, and the company is going to close, and I guess it's like nice memories, but nothing else, right? So this is how it started. Now, I've worked, so I think for the last year and a bit, it's not full time, but I work on Mesh Optimizer a lot. But Mesh Optimizer became useful and popular sort of before I started doing it full time, right? So the before this, I just did this in the evenings and stuff like this. And then it became big, and then I quit my job, and then I was like, I don't know what I should do. And then Valve reached out, and Valve is like, well, we'd like to sponsor Mesh Optimizer, I don't know, we don't know what your plans are, but, so right now Valve sponsors the development of Mesh Optimizer, and that kind of helps me justify not really having to do anything else, right? I do other, I guess, unpaid open source work too, but this is good in that sense. It allows me to focus way more on, we talked about the simplification stuff. The simplifier was in an okay shape before last year, I guess, but I think what really pushed it over the line was basically me saying, well, I want to solve this problem to the extent where I don't have to, feel guilty of the result. How do I do this? How do I make sure that it actually works? And a lot of stuff happened since a lot of improvements have went in since that kind of got it way closer. But yeah, so the project, this is not a recipe for success for open source, right? Because if Mesh Optimizer didn't exist, then nobody would use it. And if nobody used it, nobody would be happy to pay money for it, right? And then the other side is Valve is fairly unique in that. There's a few companies that do open source partnerships,
in ways that matter. There is companies that do like small open source grants, but small open source grants are basically impossible to use to kind of replace your full-time job with, right? Which is unfortunate because and then the other side is you can. So when you do open source, there's other open source projects that have like corporate sponsors, and it's fine. You had an interview with Omar on IMGUI. IMGUI has like a lot of corporate sponsors. One thing I never liked, and I continue to not like, and I try to spend zero amount of hours on it, is like the whole aspect of sales. So like
marketing.
Let's say even Mesh Optimizer was commercial, right? There's separate issues with commercial projects where I think it's just much easier to sell, quote unquote, to have an open source project integrated than it is to do a commercial one. Because commercial one, even if you're internally inside a company, integrating a library that's open source, as long as it's license compatible, you like add it, you're done. Sometimes you have token legal review that looks at the license, and the license says MIT, they're like, good to go. If you want to integrate a commercial project, even if you really like it, even if there's nothing like it on the market, etc., it's like, oh wow, budget reviews and legal reviews, and we need to draft contracts, and it's a lot. And then flip it, and then ask it from the perspective of the person who is trying to sell the project to a company. That's like super frustrating because there's tons of companies. Companies have demands. Companies want things. Some companies will tell you that they want a thing before they are going to agree on a license. You're going to go on, work on your own time, add a feature, and they're like, actually, we don't need it. Or they'll ask it for one more feature. So it's, and you are spending so much of your time kind of thinking about this, right? It's like, which companies should I talk to? How do I structure my offering in a way that makes sense, etc. So I'm fortunate to not have to do any of this, and part of why is kind of Mesh Optimizer started and got big and popular while I just had a job. And now that it's big, you can occasionally find these like great companies that can sponsor a project in a reasonable manner. And sort of the other important thing is there are some companies that do it right, but again, often in open source, even if you see funding, the funding is strings attached. It's like, so I think my understanding is SQLite works like this, where they have a tiny team that's worked on the library forever. It's super big, it's like super popular, right? It's like, I don't know, billions of installs. Every like Android phone has it, every iPhone has it, etc. My understanding of their model is there's things that SQLite doesn't have. A company goes to them and says, hey, we'd like SQLite to support the feature. And they're like, sure, and it's going to be like whatever, however much it's worth, and it's a transaction, right? That's a bad model for open source in general, I think. Now, like, works for SQLite, presumably, so that's great for them. But what about features that you don't need yet? What about maintenance that you don't consider important, but if you don't do this, the library ends up dead? One example is the mesh shader stuff that we talked about. When I added it, nobody was using it, which like sort of makes sense in some way. There is a new hardware feature. To use a new hardware feature, you need to have robust tooling support and robust hardware support. Robust tooling support didn't exist because nobody implemented it. Robust hardware support didn't exist because the feature was new.
See, like,
okay,
this is
so
cool.
Let's say hardware support did exist, but tooling didn't. How do you add a feature? Well, you need tooling support. Tooling support doesn't exist. It's a catch-22 problem, right? So the way I solve the catch-22 problem in Mesh Optimizer, I'm excited about the feature. I'm going to build support for it. I don't particularly care if people... I like care if it's useful, but I don't care that nobody is using it right now because I think people might find it useful in the future, right? So I built it, and then games started shipping with it at some point after, right? So it's like, and my argument is always that for companies
I think this is exactly
that
the
do
thing
open source sponsorship,
that I've been looking for,
that believe in open source, this is the
complexity.
good model that they should also be excited about, because for every feature that you don't need, that other people might, there is a feature that will help you if
you had it, but maybe it's not front of mind or something like this, right? And like maybe in a few months you will need a feature that other people have needed before you. And if this feature doesn't exist, your project might be at risk of being delayed because the implementation doesn't exist yet, it needs to be implemented, and it needs to be tested, and then maybe it doesn't work very well and stuff like this, right? So it's kind of counterintuitive, but I think but it's almost similar to the algorithms that we talked about, like, local optimum gets you so far, but if you think from the global perspective, it might be better for you to do something that's not optimal in the moment, because like it makes things better for everybody else. So. But yeah, I'm happy I can do this, but I don't know that this is a recipe for, there's other examples similar to this, I'm sure, but I think fundamentally it relies on you kind of somehow finding the time for building a large and successful open source project, and then suddenly finding yourself with the problem of, people want to use it and they actually care about it existing enough to pay money. And it's like, okay, interesting. I don't know how to replicate this. My other open source projects are not funded, so.
I'm assuming that because it's open source and also has like MIT license, you might not know about usages. Like you probably don't have like 100% idea like how often it's being used. But GitHub recently has added this feature of like uses. I don't know how it's being counted.
So this is.
But it has 172K usages. Which clones or like something. So can you tell me a bit more about the usages, adoption, popularity, and stuff?
Okay. Misleading. I love misleading numbers because they're great at impressing people for their own reasons. But okay. So many things to say here. So first of all, the thing that GitHub is computing is based on the JavaScript NPM ecosystem. So this is the reason why it's so high is because people use the JavaScript GLTF related stuff that I was talking about often, and then it propagates through. I think like there are some renderers that depend on Mesh Optimizer by default, which then propagates into all of the little side projects that people use and stuff like this, right? So I think that you can sort of ignore as a web ecosystem. It's kind of difficult to estimate. So in the gaming space, there is a few things to say. So one is, it is very widely used. My assumption, so it's not used in Unreal or Unity, even though I think both would benefit from it in some places, but it's like whatever. It is used by most proprietary engines, not all, most. I don't know. I don't have a count. It's difficult to know. So one reason why it's difficult to know is the way things are supposed to work in the open source world is a game uses a library uses MIT license, the library gets mentioned in the credits, in the giant credit screens that nobody reads, but I do. And everybody's happy. There is a couple things. One is there's a lot of uncredited usages of open source in game development. Just because people don't think about this, the license technically sort of, MIT license kind of asks for attribution, but it has never been legally challenged, so like nobody knows if you can sue a company for not mentioning an MIT library, in the credits. For Mesh Optimizer, the problem is like even more acute. Which is to say there's many libraries that ship in many open source games that aren't often credited. For Mesh Optimizer, the problem is more acute because it's usually used in the processing pipelines that you don't ship to your users. So there's no obligation to mention it in the license screen, so people don't. So because of this, I don't really know. My usual experience is I go to a conference, I have a chat with somebody, they work at a AAA studio with proprietary technology. They're like, thank you for Mesh Optimizer, we use it. I'm like, tell me more. First time I've ever heard about this. Mesh Optimizer is used in Zelda and Tears of the Kingdom, the second one, the most recent one. My understanding is they use the compression, and so because of this, they had to mention the library because they linked to it at runtime as part of their third-party notices. But their third-party notices aren't in the game; they're all on the website. So I basically learned about this because somebody pinged me, and they're like, "Oh, I at the Nintendo license notices for Zelda, and your library is in it, I'm like, why would you ever look? But thank you. These things bring me, when I learned that the library is useful, it's like super cool. But I don't have a perfect visibility for sure. But yeah, like there is some proprietary engines that probably don't use it, right? I'm sure. But a lot do. But a lot do in multiple ways, right? So again, it's a set of tools. So maybe you don't use some tools, but you use others. It depends on what's useful to you. But yeah, so it's quite widely used in the industry. It's just that I don't know how much. There are some companies that are very gracious and kind of disclose the usage, as in they put the library in the license screens. Baldur's Gate 3 uses Mesh Optimizer. They put it in the license. Alan Wake 2, as I mentioned. So like Zelda, like there is a bunch of games, but it's literally at this point I don't fully know, because I either have to talk to somebody, or sometimes the company publishes a conference talk, and they're like, there was a recent example where a company published a conference talk, and they're like, they described their meshlet processing pipeline, and I knew about the talk because I looked at the conference slides or whatever, like the talk summary. I'm like, these guys are using meshes. I wonder if they use Mesh Optimizer. So I watched the talk. They don't have it in the slides, but in the captions, the speaker is like, oh, for this we use Zeux's Mesh Optimizer. I'm like, yes, great. But this is you kind of learn about this by proxy, because the library is mostly kind of offline, right? I have another popular open source library that is more used at runtime for some reason, even though it shouldn't be. And for that, I have way more game like credits, just because I don't know, just because people link to it at runtime. So because of this, if you use Mesh Optimizer, A, you should add it to credits, of course, but B, you should use compression. A, because it's good for you, B, because it will force you to link Mesh Optimizer to your runtime code, and then it will force you to disclose the fact that you use Mesh Optimizer. So, again, it's like a win-win situation. But yeah, there is no other, and the other thing, of course, to note is that a lot of the open source engines use it, right? So for proprietary ones, you don't know. For open source, you do. Godot engine uses it. I don't really know. So like out of the big ones that I remember, there is Godot, and Godot uses. I don't actually know what the big open source. Oh, Bevy uses it through the Rust bindings. There is I'm sure others, but there's a lot of engines these days. So.
Since it's open source and already has a couple of contributors on his GitHub page, is Mesh Optimizer accepting contributions? And if so, how do you suggest people go about contributing?
So Mesh Optimizer is accepting contributions. However, the one thing I find is, so contributions to Mesh Optimizer tend to be difficult to do, because the problem space is kind of intense a little bit. So all of these problems are difficult to solve. There are some things that the library doesn't have, and sometimes it doesn't have them because I haven't gotten around to them. But sometimes it doesn't have them because it's difficult to engineer an algorithm that's generally useful and stuff like this, right? So there's some implicit if this feature doesn't exist, why not? And then in terms of the code, so it's written in C++, but it is a C++ without dependencies. There's no STL. I depend on the C library in the sense that I use memcopy. So memcopy is good. If you use memcopy, your code will be accepted. But there is no other dependencies, which means it's a little bit hostile in the sense that, so my whole paradigm here is, if I spend more time on engineering the library very well, then everybody who uses the library gets the benefits for free. But kind of by nature, this makes development of the library more complicated, right? No dependencies, the code has to be fairly optimal, not in the sense that there are some things that decoders that are very optimized. The rest of the library isn't micro-optimized to death, but it's like, it pays a lot of attention to performance, right? So I think this combination of this is a difficult space, there's a very high quality bar, and things that the library doesn't do yet, usually doesn't do them for a good reason, and things that the library does do, they're usually pretty good, then the combination makes it kind of difficult to contribute. So my preferred model is usually that if people have a thing that doesn't work or they think should work or whatever, then if it's a bug, they should start an issue about this, and if it's an idea for a feature, then they should start a discussion about this. GitHub has a separate issues per discussion thing, and then we can talk about this, because sometimes I sometimes get pull request for a feature that actually is supported already, but maybe the documentation wasn't clear enough, or maybe the person didn't read it carefully or whatever. And it happens. It's not a problem, but it's just that I think when you start with a pull request, I think in general, it's a bad dynamic, because then you're like, oh, I spent all this time working on this amazing contribution. Why do you not accept my amazing contribution? I'm like, well, we should have talked about this first, because it's complicated, right? So, which is all to say, so contributions are welcome, but I think most of the library code, vast majority of library code is written by me, and I don't have a problem with it, and it's just that, if people want to start, if people want to have something that the library is missing, they should open a discussion channel somehow, and then we'll see, right? Sometimes, maybe it's a thing that's already on my roadmap and I have a clear idea of how to do it, and I'd be happy with somebody else doing it, but sometimes it's just difficult, it depends, I would say. But yeah, I do get some amount of pull requests. I get more pull requests in GLCF-Pack than I get in Mesh Optimizer, because there it's friendlier to contribute, it's easier to write code in and stuff like this, so that's fine. And sometimes things are just hard. Somebody opened an issue actually around simplification a year ago, maybe or more, where they're like, okay, so this code can be tweaked in this way to make this better. And they're right, but I still haven't done this. This was not a pull request, but it's just an example. I still haven't done this because I tested it, and it makes it better on their thing, on their use case. But it also blocks a bunch of simplification code in ways that are very harmful in a bunch of other cases. And I don't have a way to reconcile these two things cleanly, right? This is, I think, in general difficulty in Mesh Optimizer. It has to be generally useful, and if there's a thing that's helpful for one case and harmful for another, I have to somehow reconcile that. Sometimes I end up having two algorithms, like we were talking about the clusterization. There's two algorithms because two use cases are different. But sometimes there's just not a clean way to figure out what to do here, right? So I think it's just naturally difficult to do some of this stuff, unfortunately. But it is what it is. If people want to improve documentation, that's always easy, but honestly, that's not, it's not super high profile. But yeah, I think from the perspective, Mesh Optimizer is not that friendly. When I started Mesh Optimizer, I wanted a very high density of code quality. I wanted to say complexity, but that's not quite the right word. But I wanted basically to focus on the internals being very tight and very good, and this means there is very little surface for code that's would be nice to have, but it's a little bit half-baked, but it's fine, we can figure it out later, and stuff like this, right? Which I think by nature makes it difficult for first-time contributors to any code base.
Oh, where is that shit?
For things that are not technically intense and require a lot of background and also a lot of coordination. So this is another thing with PRs. Always start a conversation with
identifier,
of the repository before sending an PR.
All that kind of stuff is here, and as you navigate through your program,
unpleasant surprises and bad feelings people.
I'm doing stuff I've got a screenshot. I've installed Photoshop recently, and I want to look at a screenshot of the game, so awesome. A problem or something. So I double click on the.
I initially had this idea.
But anyway, this is saying basically you reference the point of the sound player, and just by typing that, right?
It's 3 hours.
You turn off Go and
the Mesh Optimizer.
We did have an episode about just mesh optimizers, so you achieved half of your objectives. I think that's good.
Yeah, exactly. That's a good way to look at it. Can we do the shout out for your social media blog? Like, where can people follow your work?
Right. So the blog is at zoobs.io. So social media is complicated these days. I usually post on Mastodon, where I don't really know. Mastodon has this decentralized, but basically, I think if you go to zoobs.io, I think it has Mastodon and Blue Sky. But I am in theory on Mastodon, Blue Sky, and Twitter. I'm usually signed out of Twitter though, and I usually don't use Blue Sky much. So if you want to actually talk to me, basically go to Mastodon. But you could follow me on either of these three. And my blog is a good. I don't blog very often, but I try to blog like a few times a year with some sort of meaningful and I think interesting work that people would find fun to read about. For example, Buffalo.age. So there's a blog post on Zoobs.io that talks about some of the challenges in kind of building this higher level pipeline and making it fast and all that stuff. And there's some other stuff. I think I have a blog post about. I have a meta blog post I think from last year.
When was this posted?
Links to all of the mesh optimizer relevant articles on my blog post. If you just go to that, you should have a few hours worth of reading material for you.
I will also have as a resource to go through, so to understand, fill in the blanks regarding the GPU work every now and then.
Dude, what?
And then also, you have tremendous series on and you have a lot of other videos and streams, right? Do you actively want to do it, or like how's your relationship with streaming?
I occasionally stream. So so I started this series I think in 2018 or so. Basically when mesh shaders started. I think actually mesh shaders make a bit of motivation. As in like
this one right here actually.
Experiment with this. And if I did, I could blog about this, but there's this whole new medium of people writing code, and for some reason people like watching people writing code. So I'm like, this is interesting, I should explore this just for fun.
Well, thanks for inviting me.
And I ended up doing, I think it's like 30 streams or so by now. But the way this works is, so I have a small renderer project, and whenever there's a thing that's adjacent to Vulkan or rendering that I think could be useful for me to explore on stream, then I have another stream. But it's not regular, and it's not, we just talked about the process of writing a runtime for Nana.
Anyway, whatever, I mean,
it is what it is, right? I have a good balance between not knowing what I'm going to write and knowing how I'm going to write it. Like, exploring a completely new area on a stream is just going to be me being miserable for 2 hours that it takes to do a stream. And also I tend to think worse when I'm on stream. And that's just kind of, it means I take longer to solve problems, but also if I get stuck, I might not get unstuck, right? And maybe there's not a problem with it, but it just feels a little bit miserable to I know I can solve this, but I have to do the stream, oh my god. So it usually has to be a thing where I can explain and implement on a stream in a way that's reasonably accessible to people, and there were a number of topics like this, but they don't happen that often these days. So whenever there's some other thing that I decide would be good for a stream, I do it, but it's not like a routine, and it's not I don't plan to start doing that on a regular cadence or anything like this.
Okay. All right. Very well. Super cool, Asani. Thank you so much for walking me through all these algorithms. This is really nice.
Thanks for having me, and for bearing with long explanations of things that might be interesting to people.
Beware, Jonathan introducing me, Sinistar, video game icon. How are you? You can't answer me that, probably. But more important than Sinistar, we have Jonathan Blow on the show this week. That's huge for me. It's so exciting. I've been scared of you for, feels like most of my life. You're so smart. I'm gonna have to keep up with your smarts on the show. Can you say hi?
Thanks for the compliments, but I don't know if I'll be able to live up to that.
I know, I didn't mean to set you up. Sorry about that. Not good to set you up, but just so you know my opinion of you starting off, because we've never really talked.
You're not going to ask me math problems or something, are you? Can you ask me to prove Goldbach's conjecture or something like that?
I don't even know what that is. That's exactly what I'm talking about. Smart guy. I've always seen you as this really smart person who talks about video games, which is what I try to be. So you're very intimidating in that way. And if you ever say something I disagree with, I get all like, oh no, why did he say the wrong thing? He's the smart guy that's supposed to be perfect all the time. And I've slowly tried to see you as more of a human being. But as an icon, you have a huge influence on what people think about video games. How does that feel?
Well, I don't necessarily feel
this
that.
Was 720p.
Yeah, I know that some people are interested in what I think about video games, but if I go and read on the internet, I see way more people that hate things that I say than like. Go and read on the internet, I see way more people that hate things that I say than like things that I say. And that's probably, to a certain extent, the way the internet forums just gravitate toward things. Like, psychologically, it's just like, well, I don't know.
Yeah.
So, but, it also doesn't really matter. Like, the magic of the world is that different people have different opinions, and even people who are very smart and generally right about things will all disagree with each other, right?
Yeah,
that's just how it works, right? If like the weird thing, sometimes when I'll give a lecture where I voice a strong opinion, or I'll give an opinion in an interview, people in comments will feel like, who does he think he is telling everybody how to make video games and dictating how games should be made? And that's just not how it is, right? Like, if anyone on the planet Earth were to dictate how all video games should be made, right, that would be an absurd and horrible thing for the future development of games, no matter how good their ideas are, because what you need is a lot of different ideas and a lot of different ways of doing things. They kind of collide with each other and mix up, and then out comes the next milestone in the history of games, right? So, I think I don't know. At the same time,
you made me feel so great. That was so smart. This is exactly what I wanted from the show. This is great.
Okay.
Thank you so much.
We're done. Thank you, everybody, for attending.
Yeah, people want you to be their voice box. And if you say anything contrary to what they already think...
Why are we using fucking Plan?
And I've done this.
We were using Plan this entire time.
Because I was like, it's the smart guy that can say all the things that I wish I could say, but it's better at me. And then he'll say something I disagree with, and I'll immediately have this tinge of ridiculous disappointment, and only by using my frontal lobe, my intellectual part of my brain, can I see, wait a minute, I didn't even really fully think into this guy's opinion. I was so quick to be upset that I didn't think it through, and then upon further examination, I find you had some really smart things to say. Specifically, I'm talking about your recent thoughts about Japanese game development and how it's kind of overly tutorialized and leading people, but instead of letting them find the game themselves. That I like a lot of Japanese games a lot that don't do that, so that had like a knee-jerk reaction in me, like a defensiveness that was a little bit silly.
Yeah, well, so there's sort of two prongs to that, right? One is just that way, like, I certainly could. If my goal was to cultivate a public persona that the maximum number of people like, remember, if I wanted to maximize popularity, then I could become more like a politician and be very careful about everything that I say. And, just try to calculate statements that won't offend very many people and that
and I see how that can be done. I'm not interested in that. When I talk about games, I'm giving my full-on honest opinion about what I do, which I wish more people would do. There's a few people who do it, and a lot of people who don't, right? Like most game industry interviews, you can sort of tell that person is sort of hedging what they say, or they're worried about what their business partner is going to think if they say the wrong thing, or whatever, right? I don't like that. I don't do that.
Yeah, thank you for not doing that. That's part of the reason why I think people take you so seriously, is because you don't come across as though your comments are designed to win anyone over or make you more rich and famous or anything. It's some pretty genuine stuff you come out with, which seems to be kind of a running theme with what you're trying to do with your career. Would that be right?
A little bit, I think. I don't know what I'm trying to do with my career exactly, besides make really good games, but something like that. Like I definitely have visions of what I'm trying not to be, right? And cynical, business-oriented guy is one of those things that I'm definitely trying not to be. But the other half of it, when you talk about a specific subject, like Japanese games or something, right? The way that human beings work, and I'm still trying to figure out the best way to deal with this fact, right? The way that humans work is that we identify with things that we've spent a long time enjoying and found good things in, right? Because those good things that we found is sort of a reflection of the way we think, right? So if, let's say you were the biggest fan of all Japanese games ever, which is probably not really the case, that's not, but just for strawman purposes, right?
Sure.
If I come along and say anything that's not positive about Japanese games, anything that's negative at all, no matter how well-reasoned or true it is, the first reaction that any human being is going to have is like, whoa, my identity is being attacked, right? It's not a discussion, an objective discussion about certain genres of games or games from certain countries. It's one part of one person's identity interacting with another part of another person's identity, right? And that's true on my side, too. When I say, I don't like games, even forget the Japanese part, but I don't like games that are overly hand-holding and condescending, because many Western games are that way as well, actually. Why do I not like that, and why do some other people like that, right? There's deep reasons. Probably when I was a lot younger, I wanted to feel like I was smart and didn't want to feel like people were helping me understand things all the time in school or whatever. I don't know. This is a guess, right? But
sure.
It's always, and so any time that I enter into a discussion like that, I have to try to make sure that what I'm talking about is the actual subject, right, and not my identity, and hope that I can bring that out in the other person I'm talking with as well. People are complicated.
Yeah. Jeez.
Yeah.
Right.
Why don't we just simplify all that?
Yeah. How could we? Why can't people? My guess is people are having trouble getting over a lot of their baser instincts, kind of take over the thinking, and just kind of primitive ego protection. It's one of those things, because in order to be
that chick is fucking
male
cute.
in our case, that's gonna meet.
He's more of a story guy overall. So he'll be like head of story
and then get the beats.
That chick is fucking cute.
Well, no, but it's totally true. Like that is actually, a more complicated version of that is actually really what's going on, right? Like you look at forums, right? And people get into arguments all the time on forums about really small things, right? And they'll argue viciously over the tiniest, stupidest thing, right? And it's not because that argument matters, right? But it's because
okay.
From something or storyboarding and stuff.
Right?
That's fun. I miss storyboarding a lot. The doc asks, have you ever...
That's how dogs exercise and get healthy.
But I would say to, obviously draw and animate as much as you can. Get your work online.
And you can imagine that people, we have much more rational brains, right? So this kind of intellectual fighting, especially among males, is probably the human version of play fighting.
Wow. Yeah, brilliant. And playing video games is often that too.
Yeah,
it's
in a
play
different
fighting
way.
on.
Let's talk more about games, actually. I feel like we're kind of off games at this point.
Yeah, that happens sometimes. Just excited to talk to you. What do you think of video games that their primary purpose is not to necessarily engage with the player as to what was going on in the designer's mind and letting the player know what the designer is like, but games that are just a kind of an avenue for guys to beat each other up like that? A lot of people will say that those kinds of games, like Gears of War, for example, aren't necessarily art forms anymore and shouldn't be called art games. Whereas I think, I wouldn't be so quick to dismiss that, but I'm wondering what you think of that whole side of gaming.
What? Dude, this is insane. I'm sorry, this is insane that every time I search something on GitHub, it's already showing fucking some coding agent thing. Like, can we just take a second and also to realize that GitHub, the fucking Linux repository on GitHub has like what? It has 300,000, okay, 240k stars over the course of fucking like 10 years. What's the most starred repo GitHub, right? Okay. So like, just to give.
We get into all these arguments.
Oh my god.
What is art or is not art in video games and what art means, and I don't really like those arguments because I don't think they're productive. Because what you find is that.
All right, and then now let's look at this.
What the word art means rather than anything real about it, right? So if I would say Gears of War is not.
That was fucked up. Okay.
If I knew
anyways,
that, I would say that, actually.
look at like this shit, Hermes. It's all these AI things, dude. Hermes agent. This is a fucking like, I don't even know what you call it. These are agents. I guess you call these agents. It's like a fucking LLM.
Right? But somebody else might hear it as
CLI tool. Came out 5 months ago. And it already has the same amount of stars as the Linux kernel. So this did effectively like 20x, like 40x.
A lot of people put a tremendous amount of effort into working on that game, and it's really hard to make a game at that level.
I mean, this was what, over the course of 20 years?
Along many dimensions.
I don't know. Anyways, like, the point is, this is fucking ridiculous. This AI shit is fucking popping up fucking everywhere.
It just becomes a disaster very fast.
It's insane.
So I don't really talk about games that I'm doing now as art games. I don't think it's useful.
Yeah, I think it's the worst term because, like you said, this turned into a big thing between Jim Sterling and myself because he really likes the term art game for whatever reason. He thinks it really clearly communicates a specific type of game. And I haven't had that experience. Every time I use the term, someone will think, oh, it's a game that's all about the graphics and not about the gameplay, or, oh no, it's all about the gameplay and not about the graphics, or it's about what the developer intended it to mean, or someone else will think it's about finding your own meaning in it, and who cares what the developer meant. It's kind of a junk term that I think we should squash.
I would not complain if it got completely squashed. Even though back in grade days, that's sort of how I thought completely squashed. Even though back in grade days, that's sort of how I thought about grades. It was like, oh, this is an art game.
Alright,
When I was developing that game, it was like 2006, 2007, and it's many years after that.
That's
now,
not gonna work.
I think
For what we
the
want.
environment is different, and the way we think about games should probably evolve.
Yeah, I hope that it has. I think in 2007, Braid was a real anomaly, and it still is in many of the specifics about it. But thanks to you making Braid, a lot of people have gone on to try to make games in that field, and as such, it's not such a bizarre thing for there to be a game that's off that beaten path. It's kind of created its own path, I would say. But I'm not sure.
I mean, it's not just due to Braid though, right? Like the time like 2007 to 2009 was really a time when a number of independent developers, first of all, became successful at all in getting people to play their games. Right? before 2007, an indie hit was a game like Gish, which had won the IGF, and game developers kind of knew what it was, but it sold like 5,000 copies. That was a hit. It's not really enough to live on, unless you're very poor. That kind of work. And then somehow in 2008, mainly in 2009, I think it started coming 100,000, 500,000, which is huge. That's 100 times more, right? So something about the availability of people being able to get the games, on the internet, on Steam, on Xbox Live opened this avenue, and then when the avenue is open, you find that some people want to do things that are a little different than the mainstream, right? So, there were a bunch of games, like Castle Crashers and World of Goo, both happened about the same time as Raid, and that was even within a couple months of 2008, and all of them were just big hits, and they kind of set up this situation where
what is taking this so long?
That scale of game, I guess.
Absolutely. Yeah,
It's
prior to that, I
insane.
would say if you want a lower budgeted game, you would have to go to the DS or the Wii or something like that. But after PSN and XBLA and now Steam broke out, that's a scale that can be really profitable for people. But Braid, you probably know this already because you made it. But Braid's pretty different from Castle Crashers and World of Goo. At least to me it is. I love Castle Crashers and World of Goo as well, but in terms of what I felt the intent of the developer was, in this case that's you, Braid was ambitious on a level that I didn't feel that Castle Crashers and World of Goo was in terms of transmitting a real multifaceted, not necessarily fun message, which is what I think people think art game means, but
it's a certain kind of game, right? And a certain kind of art game, if we're going to use the word art game, but it's not probably the only kind, right?
Yeah.
Definitely that was the way I was thinking about Braid when I was making it. I wanted to make this complex, multi-dimensional thing that had a point to it, or actually several points kind of all mixed together. So that was definitely going on, but even then, there's still a number of developers doing that, right? So like that game company is doing this kind of thing. Going back to before Braid was released, right? Their Flash prototype was Flow was a web game, in like 2007 or something. And it's not really quite the same thing, but it sort of is. It's sort of similar if what we're going to talk about is just developers having objectives that are something besides creating fun, right?
Right.
And actually, if you're going to put it that way, you can go all the way back to like Chris Crawford's old game.
Oh God, that is insane.
Simulator in the 80s, or like Balance of Power and games like that, where the point of the game, it's supposed to be a good strategy game, but the point of the game is also to get you to kind of think about how complicated and messy world politics is and how hard these problems are to solve, right? So there's actually a long history of these kind of games, and if anything, we took sort of a hiatus maybe in the 90s when games got really hard to make, like when they started to be 3D and started to be expensive. I think maybe we started to drop out of that kind of popular shift for a while. But then, around 2007, 2008, they got easy to make again because technology is just better, computers are faster, tools are better, that you once again have individuals doing this kind of thing.
Right. Wow. Thanks so much. Thanks again. Just for being you, It's great. Really enjoyed all that. This is a good episode so far.
All right, well, let's do our best to ruin it. We've got 40 minutes to make it terrible.
Well, it actually goes for an hour and a half if you want. So
okay.
Well, for availability.
The last half hour is me insulting Japanese gaming exclusively. It'll be awesome. Me insulting Japanese gaming exclusively. It'll be awesome.
Now, do you think, to be the reason, not only because the term art, there's like I've got a bullet point list of why art games is a bad term. One of them is because art is such a subjective term, it means something different to everybody.
Why is there even
just confusing people when you use the term. But beyond that, it asks us to look at some games by one criteria and other games by another criteria, which I personally don't like. I want to play Gears of War and have my eyes open to what the developers might have meant by it. And I think that there are some meanings in that game. Whether they're expressed in a sophisticated or interesting way, that's more talking about whether it's a good game or not what type of game it is. So that's one of the reasons why I don't want the term to be around. But at the same time, you have to replace it with something.
Yeah, well, so there's definitely, there's nothing preventing any game from, I mean, I find it really hard to talk about this part of things, like, because people on the internet will say, oh, this game is about, sending a message or whatever, and I actually don't like that way of talking about art games, because I feel like it's not quite right, but there's something, there's a way in which a lot of these smaller games, like people making it obviously cared about what they were saying in the game, right? And there's nothing preventing big games from doing that technically, but there is like this business structure and this economic reality around the big games probably makes it a lot harder, because they do tend to be more designed by committees and stuff. Now, that doesn't necessarily matter though, right? So there's this whole idea called the death of the author, which sort of happened a few decades ago, which is where it started in literary criticism, right? And it's basically the idea that, hey, if you go read a novel, you should look at it only as the object of the novel and how you interface with it, like who wrote it and what they thought doesn't matter, right? And I think that's actually true. Like, that's the basic reality. Like, if you go play a game, you can think about what somebody meant by making that game, but you don't really know. And even if they tell you, they might be lying, right? Or they might, whatever, right? So, on the one hand, that's the basic reality. On the other hand, I think the whole death of the author stuff gets carried way too far, to the point of denying the fundamental reality from the author's standpoint, which is that when we make something, usually we do care about what we're saying, and we try very hard to say the right thing. We work very, very hard, right? And so there's this interesting balance between those two sides that needs to be struck in the mind of anyone who's really, really cares about it. But yeah, there's nothing like somebody can play Gears of War and have a really deep, meaningful experience, and that's real to them, right? It's not. I didn't get a really deep, meaningful experience out of it. I saw some very interesting game design. Actually, Gears of War 1, the original game, was kind of cutting edge in terms of game design for a game at that budget level. It doesn't probably get as much respect as it should for that, right?
But just in terms of the mechanics, you mean? And,
well, like all these shooters before that tried to do your gun jamming, for example, right? And it always is frustrating and sucky. Like they always were bad. And Gears of War did this active reload, right? Which, it's just a little mini game, but it's a little mini game at the right time, providing pacing during combat, so it gives your brain a little extra thing to do, besides just the aiming thing that's usually doing. So it refreshes the player a little bit that way, and it has consequences, right? If you miss on the active reload, your gun jam, it's your fault. So it's fair.
Right.
Which is the thing that other shooters have.
どこに行く？どこに行く？
家に帰るよ。
なるほど。
Which I think was, and there's a number of.
チーズケーキ食べたいな。
いいじゃん。
ない売ってない。
あったなかっ
スタ
た。
バに行ったらあるかな。
なるほど。なるほど。
わからないけど帰ります。
気をつけてね。
はーい。
自分も早めに寝るね。
Sure. Just the size expanded, but
今から寝るって帰るって言って書いてるな。今から寝るって書いてると思う。今から寝るって書いてると思った。
帰ります。
なるほど。気をつけて。気をつけて帰れるかな。ジェフもチーズケーキ食べたい。
There is such a thing as monkeying around.
あ、今、大阪ね。
And then trying to sell people something that isn't really what they wanted, right? So, I don't know. I don't do sequels right now.
じゃあまた後でね。バイバイ。
I don't have a lot of practice thinking about that exact problem, but it is an issue that people deal with.
Yeah, absolutely. And why is it that you don't want to do sequels, at least right now?
Well, for Braid, the reason is I just couldn't think of anything that would live up to the original game. Like, I could make something lame, like an expansion pack sequel, but all of my good ideas that I had for what to do in the game, I felt like I had done, and I could come up with some more, but they wouldn't be as good, so I was like, because some games are about exploring a big space. If it was like a Metroidvania game, you could make a sequel, and like you make a different space, and it's interesting, and has some new stuff. Braid was not that, right? It's about a very tight collection of very specific puzzles, where every puzzle has a point, and there's no repetition of ideas between the puzzles. Like every puzzle is its own point, and there's only so many points that you have to create.
Yeah.
So it would be a cash-in if I did a sequel, and I just no idea.
You wanted to avoid the cash.
Yeah, exactly. I wanted to dodge the cash. No, I do stuff like that. I mean, so like there's no Braid on iOS or Android, and people have tried to convince me. People were like, "Oh, we'll port it for you. We just give you the money. It'll be great." And it's like, no, like touch controls for that game would suck. I've never played a platformer on the iPad that I thought was good. I'm not going to do it, right?
Yeah.
Well, standing by that principle also involves saying no to a significant amount of money that might actually be useful now because we're really spending a lot of money developing the next game. So, very expensive.
Yeah. But at the same time, your principles have stood, which I think will help you in the long run. I think that, yeah.
For me, that's what being independent is about, right? Like, the reason large companies make the business decisions that large companies make is because they have to be very protective of their money, right? Often they're a public company, and their shareholders are at the top prices down, or even if they're a private company, when there's just a lot of money to make changes, $70 million, that's a big risk. What it has is the freedom to lose money for other purposes. And if we don't use that freedom, that's our main freedom, actually. It's our main strength. And if we don't use that strength, then we find ourselves acting just like Activision, somebody like that. So why are we indie at that point? At that point, we're just wannabe big developers with no budgets.
Right. There's so many people like that, though. I have a friend who makes music for games, so he gets to meet a lot of developers through that. And there's so many just like Bejeweled rip-offs and games about popping bubbles, and they ask the developers, why are you making that? They're like, oh, well, I thought it would make me some money. I'm like, but you have the opportunity to do whatever you want with this budget, and they fail to jump on that. It's a shame.
Yeah, it's especially on iOS right now. The scuttlebutt among indie developers is like, oh, it's really hard to make money. It all depends on getting placement from Apple. And, because you can't expect to make that much money, you should make a really little crappy game and just put it out there. And probably it won't make that much, but if you put 20 crappy games out there, one of them will be a hit.
Right.
That's
what Angry Birds is. Sure.
Yeah, and I don't know the story behind Angry Birds, but I've seen other indie developers talk like that and argue that that's the right way to develop for iOS, and I don't believe it, right? What's kind of clear to me is, if you put a bubble popping game on an iPhone, why should anybody buy that? There's like 100 other bubble popping, right?
Yeah,
like, what about that game is going to make people care enough to give you money, right? And I don't know. I don't have much respect for that development methodology. I want to make another thing that's like Tiny Wings, but my bird is going to be, I don't know, like...
Yeah, they're just hoping you've never heard of Tiny Wings, basically. Yeah.
It's not interesting. It's also not how we... I mean, I as a designer, I'm interested in pushing games kind of forward and discovering newer kinds of games and more interesting and better, right? I want games to get better over time.
Right.
If you're
living a bad life. I mean, they're not happy. Yeah, they're chasing a miserable dragon. It's almost like drug addiction. It's depressing. I'm getting depressed. What will make me happy though is talking about what you just touched about a little bit, moving games forward.
Yeah.
What are you thinking or hoping, or what are your general ideas about what the next milestone will be in terms of what games can be? Is that something you've been giving any thought? It's a big question.
Yeah,
I'd love to hear what you think, though.
I think about that kind of thing just in terms of my own stuff all the time, right?
Yeah.
What do I see as an opportunity for me to do something that's new and different and also really good, and that'll just show that this thing can be done, right? So that's sort of what I was doing with Raid. It's what I'm doing with my new game. But if you ask that question about all of games, it's just too big. It's what we really need is like hundreds of designers all asking themselves individually that question, and then they're all interested in different categories, right? So, like, somebody who really likes 200-hour JRPGs should be asking themselves that question and work really hard and come up with the next thing that you get when you evolve whatever a 200-hour JRPG is, and make the next breed of that, right? Somebody who loves racing games should do that, etc. Right? I couldn't make I kind of liked Project Gotham Racing and stuff, but I don't know if I would make a very good racing game. I like Burnout Paradise, but it's like I don't think of that as my wheelhouse of design.
Yeah.
Although now that I say that would be kind of cool. Like maybe I should make a racing game, because I bet it would be interesting. I bet it would be kind of different.
I think it would work for you. I've really only played Braid, and I've read a ton about The Witness, so I can't speak to be an expert on your style, but you're so focused on the minute-to-minute experiences people have in the design, and that's what racing is often about.
That's a good point, actually.
Yeah, I wonder what you would do with that. Can you just do that? Just make one.
Right away, as soon as I
don't know if you know any of them. Damien Sommer is one. I don't know if you've ever met Damien. I think you'd like him. He'll make a game in like 2 months. He's like just constantly pushing out a new game, and he's never totally happy with them, but he gets the idea out and then he's done. And as a result, he's got a kind of productivity which leads to some really interesting things, whereas you spend like years on every game.
Yeah.
That must be exhausting.
Well, I feel like what I'm doing right now is a little too long, so I want to cut it down. I want to get better at making games faster. I've actually, we've got a development studio now with like some people in it, which I didn't even have at the start of this game. So that may help, although it may hurt, right? I don't know. Agility does not necessarily get better when you have like one team.
Sure.
But there's also an interesting trade-off. I mean, there's a number of indie developers who do that, make games in a short period of time that are really interesting ideas. Like people like Cactus or Car, they make games that I think are really interesting ideas, but the problem that I think that happens is when you make something in it, like, it's not a mistake. Like back when we were talking about 2008 and all those indie kind of games that sort of broke mainstream, they all were long developments, and part of that is because they all had pretty high production values, right? And that's the thing, is that to make a game appealing to a wide enough audience to really, get a lot of people to want to play it, they kind of want to see a certain level of glossiness to it. But I don't just mean that like cynically. There's like games actually get better when you add more production value, right? So like imagine Gears of War, where all the characters weren't animated yet, and they weren't textured. So you had all these mannequins like in this default bind pose, like running around, and bullets flying. It would not be as good of a game, right? Or like with Raid, when when I first was making it, I just drew like one little sprite for the character. He didn't animate because that would have taken some time, and I wanted to go work on the game design a little bit. So I had this non-animating sprite, and one day I said, okay, or a day and a half, I said, okay, I'm just going to make this guy animate. He's still going to have lousy programmer art, but
I'm going to put in all these frames, and I'm going to do this logic. I'm going to have a walking animation, and a run animation, and a jump animation. It instantly made the game like twice as good. Even to me, who had been playing the crappy version and was very used to it for a long time, right? So these things matter, and the problem is that when you work for 2 months or 1 month, or sometimes you're done in a week or whatever, right?
Sure.
You can have a really brilliant idea at the core, but the production values is part of how you connect that idea to the player's mind, right? The job is to sort of bring the idea to other people, and the less grunt work has been put into a game, the harder it is for that to happen, and the more work needs to happen on the part of the player. The player needs to bring himself to the idea, rather than you bringing the idea to him. He has to work hard to appreciate it, and so a lot of people don't. A lot of people don't want to work that hard. And so part of what a long development is making it easier for people to appreciate the idea without working that hard. And then part of it is also refining the idea, because you can have a really smart idea, but it's still kind of rough. I totally know what that's like, is, I'm not totally happy with this, but it's really interesting. Sometimes if you just come back to that 2 months later, you know what to do with it, but you didn't know before. It's a long answer, I guess, but that's sort of why I take a long time doing things. But I would like to make it take less time. I'd like to make more games in less time.
But you'd want to be able to do that while maintaining the level of polish and not making the player work to have your ideas come across. And you'd want to have the best of both worlds, I imagine.
Yes.
Yeah.
That's what I hope to figure out. We'll see.
That's what, I don't know if you read comic books, the creator of Cerebus, Dave Sim, he's a terrible misogynist and a hateful person, but a smart guy all the same. He said, first you get good, then you get fast, then you get good and fast. And he didn't get good and fast until like his 50s, so I think we'll all get there. I hope so. Well, so far so good. Whoa, I hit myself. With the witness, that ties in. So far so good. Whoa, I hit myself. With the witness, that ties in perfectly to what I wanted to ask you about the witness. How is that to go into? It's not a sequel, but it's a sophomore effort, and you know that expectations are there. You know what people think of you now, or you have an idea of what they think of you and what players expect from you, and you could try to appease the player, just give them what they expect, or you could cash in on kind of the mind, not mindscape, it's a movie's kind of escape, but you're in people's minds and they're focused on you, and you can cash in on that and just do whatever you want. And so if I were you, I would be torn between thinking, am I just gonna kind of do what people think I'm good at? Put it out of its misery, stab it in his brain. Really blow their minds and do something. And then I can bleed it. Even after you kill it, of course, it would still be sort of. Kind of be damned about how that goes over. Is that how much of that kind of thinking is playing into how you're going about witness?
Yeah, well, so one basic thing about my personality is that I get depressed if I feel like I'm treading water or stagnating. Like, if I, so Braid was very critically acclaimed, right? I guess that's important, nice, or whatever. It's cool. I mean, I appreciate it, but at the same time, you can't, as someone who makes things, you can't count on critical opinion as the thing that you're aiming for. I guess. You have to have some internal compass that's guiding what you do. And so for me, that internal compass says that I could go make another game that's not even a sequel or a cash-in on Braid, but that's the same scale of thing. Maybe it's a 2D game. It's got some other completely different, cool gameplay mechanic that I do a really good job exploring and package in a really artful way and all these things. I could do all that, and it would be another critically acclaimed game, but it would, in some sense, be doing the same thing I already did, right? And so I'm not happy with that. So for me, a lot of what I'm doing now is about sort of pushing boundaries on what I know how to do, and understanding things about games deeper than I already did, right? And so it becomes difficult figuring out what is a good what is a good design to work on for years that will help me accomplish that. But I think this time I've managed it. It's definitely the most challenging game I've ever worked on. We'll see for next time. I don't know. I'm starting to think, what's the next game? Seriously. Because you have to. As a designer, you sort of have to know what the idea is, especially when you've got a studio with programmers and modelers who want to program things and model things. The game ships, and then the next week starts, and you're like, well, I have no idea what you guys should program or model. That's a rough spot.
Yeah.
So my hope... So independent studios go out of business a lot, right? And it's because money is hard to deal with sometimes, especially when the economics are weird, and you think your game should have been a hit and it isn't, or whatever. What I'm hoping, I'm taking a little bit of a risk this time, in that we probably need some people to buy this game, right? If 0 people bought this next game, the studio would have problems. But if it's at a level of success that Braid was, or better, right, then we're in a pretty comfortable spot where we can afford to keep making things without that much pressure. And as long as I don't grow the studio at that point to match income, then what that means is that that's what I want to do, is I want to be in a position where we can do things that are more risky and more different from what people usually do. And we're at a little bit of an inflection point at the release of this game to see whether we get there or not.
That makes me feel terrible.
I feel like I didn't even answer the original question.
Oh, no, you did. You did great. You always do great. But that just makes me want to make sure that you win 100%. I just want everyone to definitely buy your game immediately.
You haven't played the game, right? I mean, maybe it's terrible. Maybe it totally sucks and we shouldn't win. Right?
Maybe, but everything...
Because sometimes, haven't you ever played something, or this happens all the time in any kind of creative endeavor, when somebody makes something and it's really good, and then, let's talk about The Matrix, for example. Right?
Sure.
I mean, you make something and it's really good, and then they get a higher budget and more of a free reign, and the result is not necessarily...
If you were making Braid 2, honestly, I would worry about that. I would be, like The Matrix was Matrix 2. I was like, did they need to make a Matrix 2? Really? I mean, I'm curious about what will happen, but it was such a focused idea with the beginning, middle, and end all mapped out, and it was there for you. And then the second one just felt kind of aimless. Whereas The Witness, from what I've read, there's like a field of televisions that you have to arrange, and then you're wandering alone, and then suddenly you're in the woods. I'm so certain that you're going to deliver something that I have not yet experienced in a game before. That I'm confident that on that basis alone, it's going to be interesting enough to be worth my money and other people's money. So that's
that quote is totally going in our trailer video.
Yeah.
Starting with field of televisions that you have to arrange.
That's kind of fucking
so,
insane.
yeah, it's I've never seen anything like that.
I'm
real excited about it.
It's definitely not a game that most people would have made. Let's put it that way. And we'll see how it goes, right? It's definitely very risky. I think it's the best game that I've ever worked on, right? So we'll see if anybody agrees with me. It's certainly a lot bigger and more ambitious, and that's what, as we're sort of starting to hit the downhill stretch of development now. There's a lot of details in this game. There's a lot of meticulously arranged things that have to work with each other, and but it's going to feel good when we're done, I think.
That's awesome. I'm really excited for you. Well, I think that what you're doing, what it sounds like you're doing, is what... I think children are better than adults. Let me start off with that. Because children, they fail at something, and they immediately go, oh, I'll try again. Like I was showing a 5-year-old how to play Rhythm Heaven Fever, a really difficult, frustrating Wii rhythm game. And she lost on the first level like 50 times. And she just turns over to me and goes, I'm going to try again. Just like totally unfazed by it. And I was like, I want to be like that. If I applied that thinking to my life, I would succeed at so much more things. Because they're constantly seeing how far they can push their threshold for what they can do. And it sounds like you're willing to do that with game development. And I think that's what a lot of players wish their games would do for them too. they play a game and they don't want to just be handed what they know they can already do. They want to have their threshold be pushed to see what they can handle both mentally and technically and whatnot, which is why I'm hoping there is this kind of new place that games get to where we're not relying on the same old tropes as much. We kind of grasp that idea of pushing our thresholds a bit in general, but I'm not seeing a ton of that right now. Getting back from E3 was pretty depressing.
Yeah, I didn't go this year actually. It's the first year that I skipped E3.
Yeah? Why was that?
Because I knew what it was going to be like. Like, I sort of anticipated, because there's no new hardware being announced, right? And, you sort of know ahead of time, you hear rumors about what games are going to come out and stuff, and I just, yeah, but I didn't anticipate, so I anticipated being a little depressed in terms of like, okay, there's not going to be that many games doing new, surprising stuff, and that was true. I didn't anticipate like the fact that it would totally be hinged around ultra violence the whole time, which actually, I'm not one of these anti-violence in game crusader type of people, but I do think that we should look at what we're making and why. And I sort of feel like if the thing that keeps people interested in your game and makes them want to buy it is the fact that you can shoot a guy's face off point blank with a shotgun, doesn't that mean that without that your game wouldn't be interesting enough for people to buy? And why is that, right? Like, are they tired of playing, an Uncharted? Like, they played 3 Uncharted games, so maybe they don't want to play another one unless it's got some gimmick to get them to play, right? As a designer, that would be a big alarm bell to me, right? It would be a sign.
Yeah, it's like, to me, it's like they're asking their daughters to get breast implants to get a date. It's like, that's just depressing. Don't you think your daughter's worth anything? Oh, no, she doesn't wear skimpy enough outfits. Get her that mini dress, honey. It's like, it's a gross setting. And I was actually most impressed with Nintendo overall in that regard. They were relying on a lot of their tropes, but the fact that they had like Pikmin 3 be their marquee title, like no one is buying Pikmin these days. That's not what's hot on the streets. They were at least taking a risk there, but even they overall were relying really heavily on stuff that they knew would sell and that they know is like their version of breast implants, which is just Mario in a squirrel suit for the most part. Yeah, I know, man. Yeah, weird world we're in. So E3 to me said mainstream development is not where I'm going to get the next milestone in the development of what video games are, at least right now. I'm not really sure that the next console cycle is going to do it either, because the way I see it, it went, cartoon platformers focus on nice tight level design to like Metal Gear, showing that you can take aspects of cinematic storytelling and stuff like that into gaming.
End-to-Pen provides many code metrics and also
and now what's going to happen
the
next?
End-to-Pen dashboard shows several interesting metrics,
didn't seem
like the number of lines of code,
or haven't been any to be
the
found
percentage of
in a
comment,
while.
or the code coverage ratio by tests.
It'll be a big hit, and everybody
Note
will love
that the
it,
delta since the baseline is shown
that
for
is.
each metric.
By definition,
The
the new
technical
thing
debt
is the thing
metric
that you
is
can't
used to
predict.
estimate the cost to fix issues in code.
Do you have an idea
This
of what
important
you
metric
personally
tests
would
on
want
video.
it to be? Just selfishly.
Code metric values
You can
can
be
be plotted to obtain some trend
if video games were
When
going to be
you're
more
asked,
fun
you'll
for
find
you,
a dedicated
what would you want the next big game
Code
that
metrics
tries
can be used
Bro.
to detect some
model
code
the game?
smells,
Fucking
Yeah, well,
like constructors or methods.
the thing that I don't like, and it's related to the hand-holding
That's
issue
the
that we
baseline.
talked about, right? Generally, when I
Here,
sit
each
down
rectangle
and play a
represents a
game,
method.
Ooh, this
The
is some
rectangle
dirty code.
size is
mind if it
proportionate
was a
to
little
its
more like
metric.
Sinistar or
Here,
whatever,
the
in
number
that
of lines of
I
code.
want a game to ask something
And
of
the
me as a
rectangle
player,
color
right?
is
That thing that
defined
you were
by a
talking
second
about a
metric.
few minutes ago about like really
Here, the percentage coverage.
just putting an effort in and
With
doing
this
well
view,
and
you
having
can see
yourself
at a glance
tested and getting
which
better
part
at
of the code is
something,
covered
right?
by tests and which isn't.
Now,
The current mainstream
The namespace loader is almost
has,
entirely covered.
for many years, been on a trend away from that. There's still some games
While
that are
the
kind of
namespace
hard,
driver is
but for the
poorly
most part, they're not, right? They're sort of, I almost don't know what to say. Like press
Any
A to
metric
win
can be
is
chosen,
sort of the
like percentage comment.
sure way to say it. But a lot of games are
Here,
obviously
types in
like
red
that,
are
and then a lot of
poorly
games are
commented.
less obviously like that. So,
Or
take
complexity of
a game
methods.
like Call of Duty multiplayer,
Here,
right?
two
Which you would
complex
think is
methods
not
are
necessarily a
The
press A
search
to
by
win kind of
criteria
game because you're
panel, you can
playing
explore
against
code
other
through various
people, and
metrics,
how
like
good
type
they are
size,
sort
for
of
example.
determines what kind of time you have, right? But to me, that kind of a game where you get
and
killed and you
instability
just
component
respawn, and it kind of doesn't matter how well you do at any given moment because you just come right back.
Or complexity of methods.
Is really
Here, two complex methods are in red.
compared to the shooters that I like.
With
which
this
is something
option,
like
you can
Counter-Strike,
generate
right?
a code
It's
query
really
to list
kind of
the 50
soft and
most
not
complex
interesting. Like in
methods.
Counter-Strike,
Let's double-click.
it really matters what you do every second
I like
of that
this.
game. You know,
I want something
you
like
get
this.
shot in Counter-Strike and it's brutal and bad, and like shooters that make it out to the public now. That's a weird way of saying it. New shooters that have large budgets are not making that kind of design decision, right?
Yeah.
Even though, which is weird, even though Counter-Strike is still the most played online. Like you go on Steam, and if you add Counter-Strike Source to the original Counter-Strike, there's still more players than anything.
I didn't know that. Huh.
Yeah.
That's
still.
good news, actually.
On
That makes me feel good.
really, if you bust out original Counter-Strike, it's really old looking. Like, it's kind of amazing. And a lot of people still play it because it's a really interesting game that you can't get any other way. You know? So that's I'm way more of a Counter-Strike person than a Call of Duty person. If I play an RPG, I want it to be an RPG where it really matters what I do, not one where you just kind of level up and you'll make it through the game no matter what, which is what most of them are now. You know?
Sure.
So,
because it's the way to assure that the most people will stick with your game because you don't ask anything of them. I think
yeah. But here's the interesting thing. So as a designer, right, I've been a little bit out of this because I've been mostly making puzzle games for years. But I don't think that asking something of the player has to be the kind of difficulty that we're used to, like reflex difficulty or just like dodging things really well or whatever it is in all these games, right? I think you can come up with asking creativity of the player. Like, look, this RPG is really hard, and as it goes through the game, as you proceed from combat to combat, you get into more and more overwhelming odds, so you're going to have to figure out some way to turn the odds in your favor, and it's not some little, what was the name of it? Stranglehold-like thing where you shoot a certain thing in the environment and it falls on the guys, right? Like, games do that, but no, you really have to figure something out that the designer didn't think of to get an edge, right? Or else you'll lose that fight, and maybe losing that fight doesn't lose the game, but it's consequential, right? So I want to see that. I want to see things where I can, like in a shooter, like people make a shooter, and then all these esports people will go and do amazing things in the shooter that nobody would have ever expected, right? I mean, I don't know if you ever saw the Quake Done Quick videos, but those are sort of a canonical example of this, where somebody speedruns Quake in like 8 minutes, I don't know how long it is, by doing insane things and exploiting like weird physics and just jumping off of explosions all over the place and stuff. And have you ever heard of an RPG where people really do that? I mean, I guess there was a thing where you can sort of speedrun the original Wasteland in 2 minutes just by shortcutting to the end. But you don't think of RPGs, for example, as being that kind of place where skills can develop to that extreme range, the same way that they can in a shooter or a racing game or something, right? So that would be interesting. Like, what's the RPG version of that? I would like to see that.
There's some stuff in like Earthbound and Mother 3 where you can sequence break and be some weird. Just the developers work to make you feel like you found a mistake in their design, but they actually designed it, and that made me that made me feel. They're pretty neat.
Beware Fallout.
Yeah, then there's Fallout. Thanks, Sinistar. I've ignored the question.
Yeah, we should.
That made me feel. They're pretty neat.
Beware Fallout.
Yeah, then there's Fallout. Thanks, Sinistar. I've ignored the question.
Yeah, we should answer
for almost an hour. I feel like a real douche. I was just so excited to talk to you, and I think I talked okay. I think I did all right. I wish I'd done better, but I did. You did great. Let's see. Spamfish asks, are big publishers still scared of original games despite successive games like Braid, Minecraft, Journey, Meat Boy?
Yeah, so they're not scared. They're making a very rational business decision, right? So you think of a game like Braid, or I'm going to leave Minecraft out for a second. So the thing to understand about Minecraft is that even though all 4 of these games mentioned are successful, Minecraft is sold like 20 times more than those other 3 games probably put together. You know? It's in a different league. But just talking about like Braid, Journey, Super Meat Boy, that kind of game. Those games, you know, at their best make millions of dollars. That's a lot of money if you're a small team, right? If you're Activision, you don't really care about millions of dollars, right? You need to make billions of dollars to keep the company going, and how are you going to do that, right? You need to make 1,000 times more money than, you know, Super Meat Boy made on a game, right? And how are you going to do that? Not really in the same way, right? If games like Braid or Journey were making, you know, tens of millions, or $50 million or $100 million, you would see that attitude change. But that's not what happens, right? They do well for small teams to get by.
So it's not that they're scared; they're just kind of disinterested.
Yeah, but the reason that they're disinterested also is because that's sort of what people buy. People will buy Gears of War 2 before they will buy, you know, Jumping Time Rewind Guy franchise that they never heard of, right? That's just how it works. Now there's times in the console cycle when this changes, right? So like the first Xbox came out and Halo became a big game, and then Halo became a strong franchise, and second Xbox came out, Gears of War is big, right? There are times when people are more receptive to the new thing, and I think it's like when they're new to the environment. Like if you go to the iPad, you're going to sort of be like, oh, what games are on the iPad? I have no idea. You go check it out, right? But yeah, I don't know. Anyway, so I don't want to rat hole on that too much. But it's just that like they're only selling what they think people are going to buy, and they can be wrong about what people are going to buy, but usually they're not that wrong actually. Sometimes they do a bad job. Like I think Mirror's Edge could have been really good, but the game design was a little off, and they didn't market it well at all. Like sometimes the flip side of that is that publishers know how to market something that they've already sold very successfully. If they haven't sold something successfully, they don't know how to talk about it to people, and sometimes that can be the difference between success and failure. So
right, just their capacity to even know what they're selling. I've had some really weird conversations on the press side of PR people.
What the fuck?
I think Mirror's Edge could have been really big. But the game design was a little off, and they didn't market it well at all. Like sometimes, the flip side of that is that publishers know how to market something that they've already sold very successfully. If they haven't sold something successfully, they don't know how to talk about it to people, and sometimes that can be the difference between success and failure. So,
right, just their capacity to even know what they're selling. I've had some really weird conversations on the press side of PR people that are talking about a new IP and they honestly don't even know what it is. They only know how to talk about Dead Space 2 or whatever. Yeah, it's interesting. Speaking of what you were saying, on the Wii, sequels almost always did worse than new IP because I think the Wii was a place where people had it in their mindset like they are with iPad now. It's just, new game, something I haven't already had. Whereas the PS3, the Xbox 360 being sequels to their prior consoles, sequels always did great on those systems. So
I think that's part of it. I think the other ingredient, speaking as someone who doesn't play very many Wii games, although I was just playing one last night.
What were you playing last night? I'm curious.
Xenogears Chronicles. I was playing.
Oh, Xenoblade Chronicles?
Xenoblade Chronicles, sorry.
I know, there's so many Xenos. It's not
There's a lot of Xenos in the world, yes. Xenoblade Chronicles. But I think for most Wii games, so the Wii was this system that sold on this promise of being a wonderful future sci-fi age gadget, right? And I think, almost every game on the Wii has failed to live up to that promise. And so I think that's one reason why sequels might not do well, is people just think, well, that first game wasn't as good as I expected it to be, right? Whereas you play something like Gears of War, you don't necessarily have expectations, except that you're going to be some buff dude shooting aliens. And it lives up to or surpasses your expectation, and you're like, hell yeah, I'll buy the second game, right? So I think there were problems. I don't know. If the Wii had had a better controller, sequels might have sold better, is what I'm saying.
If people would have been satisfied. But even like Super Mario Galaxy, which people really liked, I think that's as well made of a Wii game as you can ask for. Even the second one.
Did Galaxy 2 not sell?
It sold well, but I think it did like 5 million, whereas the first one did 10
only
million.
5 million.
Yeah.
Yeah, no, I don't know, I actually didn't like the Super Mario Galaxy games, so I didn't play them very far.
Interesting.
But, I don't know.
Yeah, I'm not surprised.
We can conjecture all day about this.
That's true. What do we really know about sales and things?
I don't really know anything.
You know a bunch of stuff. Ninja Legend asks, whoa, I have a few linked art game questions.
Okay.
Strength? Yeah, oof. Is the strength
in Xenoblade Chronicles, you link attacks between players. So now I'm getting ready to link the questions and get a bonus question out of the linked questions.
Are you liking that game? I wouldn't imagine. See, when someone
I don't really like it that much, actually. But the setting, it drew me in at the beginning because the setting is so crazy and creative and weird. I'm like, wow, that's interesting. And then the game design is not. The game design has a lot of really cool ideas, but they're just kind of in there in a mishmash. Like it doesn't work for me. But I'm only 4 hours in, which for a JRPG is like it's like being on the title screen still.
Yeah.
So I don't really know.
Sure. You're still giving it a chance, though. That's good. Yeah. If I had your brain, I would probably get bored of games really fast that didn't give me a really compelling new idea right away.
So I'm humbled by the continual compliments, but I have to say though, I'm not, I'm just somebody who designs games, right? Like I'm not some super genius kind of person.
Oh yeah. Well, you wouldn't
I don't
know.
think so.
I don't. I read a study where most stupid people think that they're at least 15 IQ points higher than they are. And most geniuses, because they're smart enough to know how much they don't know. So they all think they're dumb. All the smartest people I know are always talking about how stupid they are. But anyway, yeah, that's...
Well, I think it's just, it's really, if you just think carefully about game design for a long time, you have interesting opinions, I think. That's all.
Yeah, that's all. That's all it is.
No, really.
Anyway, I know you feel that way, but I have to humbly disagree with you on that. I think you got a special brain. Ninja Legend asks, yeah, you want to have
and you have interesting opinions, I think. You know, that's all.
How much they don't know. So they all think they're dumb. All the smartest people I know are always talking about how stupid they are. But anyway, yeah, that's...
Well, I think it's just, you know, it's really, if you just think carefully about game design for a long time, you have interesting opinions, I think. You know, that's all.
Yeah, that's all. That's all it is.
No, really.
Anyway, I know you feel that way, but I have to humbly disagree with you on that. I think you got a special brain. Ninja Legend asks, yeah, he wants to know, is the strength of video game media to give players interactivity and control pulling the player into the experience? He always thought that was the strength of the media. That's why so many art games force feed the vision,
nice.
making the experience, if not the game so linear. I think he's saying that art games don't give players much control, which is another reason why I think the art game term is junk, because I know so many art games that are all about just giving the player free reign, almost like Zelda 1 style, just exploring wherever you want. And,
yeah, I mean, it's a weird question because I can certainly think of some art games that are linear, like Journey is pretty linear, or you know, even Flower before that's pretty linear. But I don't think of art games, even if we're going to allow ourselves to use the term art game, which we sort of said we would. I don't think those games as a class are any more linear than mainstream games. I mean, we have some big examples of mainstream games that are non-linear, like Skyrim or whatever, but, you know, I mean, we're just talking about Gears of War and Halo and all that stuff, and those games are very linear, right? They're very Uncharted, right? They very much know what experience they want you to have, and then they go about making sure that you have that experience, right? That's a big, in big AAA games, there's sort of this Hollywood-like experience that a lot of them are trying to do, right? So I think there's forces in both camps that push toward linearity. I think it's good when people try to move away from linearity, right? So with Braid, even though it's a puzzle platformer, I designed it so you can walk past almost all the puzzles if you just can't do them right now, and you can go back to them later, right? So even though it had a linear presentation, it was trying to be as loose as possible about what you would play and what you would solve. And so, in the game I'm working on now, it's even more nonlinear, right?
That's exciting.
But yeah, I think it's more a general problem in game design that when you want to make the best experience that you can for a player, he used the word control in the question, and that's interesting, right? Because the tendency is for the designer to try and control the experience. Like if you go, like for the Half-Life games, like in Half-Life 2, you can go play the Valve developer commentary that's built into the game, and you can see stuff about like, we did all these things to make sure that when you come over this hill, you see the explosion in the distance, and you understand the plot point that's happening and all that, right? There's this tendency to control very tightly, and control means linearity generally, right? So it's just people trying to be good designers, actually. But I think that we as designers have to be aware that we can be good designers by not having such a clenched fist, right? And to let things happen, right?
Sure,
you know, he brings the example of like exploration kind of game, like Metroidvania kinds of games. And I think that's interesting examples, and it would be cool if more people made those. Although, interestingly, a lot of those games are actually kind of linear, right? If you look at like Shadow Complex, yeah, it's very linear. It's disguised as non-linear, right? So I don't know.
Yeah, and when you find that it was a disguise all the time, it leaves you kind of hollow inside. That's why Metroid 1 is still one of my favorite games, because that's a truly, you can skip all the bosses if you sequence break right, and that game really makes you feel like it was up to you to decide exactly how you experienced what they put out for you. That's neat. I think I'm really excited about that game you're making. Now I'm just thinking about it.
Dude, you could arrange TVs.
Sounds so. I get the sense that you aren't going to make me feel like I know what to do, and that I'm going to feel so rewarded for being willing to think outside of whatever my box may be.
So that's
yeah.
The thing that I was going for, or am still going for, because the game's not done being designed. I don't know if you played Myst, right? Sure. I actually just started playing it again because Real Mist came out on the iPad, so you can play it in live 3D now.
Cool.
It's going back to that sort of first-person graphic adventure where you're in this place and you have no idea what's going on, and nobody's really going to tell you directly. Like, you can put together clues and figure it out, but it's really up to you. And you're an explorer, and you're a problem solver. And the place where I break from those games is I don't like the way graphic adventures went in terms of what kind of puzzles they have, right? I don't think the puzzles are very good usually. So I went a completely different route about what the actual game design is behind the puzzles. But it's about making this space where you can go where you want, figure things out, and put together a picture of everything. And I like that. I really think that's interesting.
I'm really freaking excited about it right now because there's so much. When I think about why I do anything, it's because in moment to moment, just watching Adventure Time or playing Resident Evil or something that people take for granted as maybe not all that meaningful. There's moment to moment experiences in there that make you reflect on yourself and what you did and why you did it, or why you thought what you thought about a character or a thing. You can find that anywhere, but a game like yours, which seems like its motive is to give me that reflective experience as often as possible. It sounds like 20 games worth of fun in one game for me, so that's why I'm so excited about it.
I hope so. We'll see what happens.
Yeah, sorry, I don't mean to build you up. Maybe it'll be terrible. You're right.
It'll be terrible. Worst game ever.
Axiom Verge, who made a really interesting Metroidvania type game, actually, thanks for joining me on the show, asks, how important do you think narrative is to games like Braid? And
so what game is it that he made?
He made a game called Axiom Verge, pretty much by himself. He's going to hopefully be on the show. Yeah, it's interesting. I know he wishes it was better than it was, but I think it's pretty good. Yeah, definitely check it out. So, do you think that the games like Braid Witness or games in general would still have as much value if there was a disable story mode? Just cut that side of it all out?
It depends on what you mean by as much value, right? So in Braid, the way the story was originally in my very first prototype, it just came up on a screen, and you press spacebar to go through scroll through the story, and then you would go play the world, right? And I wanted to make it more optional than that, because even if it's on a screen and you don't read it, and you're like, oh, this is stupid, right? You can skip it that way, but you're sort of fighting the game, right? It's like the game is giving you something to do, and you're not doing it. And I felt like at least if they're sort of on the screen, if you don't want to read the story stuff, and you run past it or something, and you just sort of skim it while you're going to the level selection doors or whatever, that feels better. It legitimizes the idea that you don't want to read the story, right? There sort of is disabled story mode in Braid, in as much as I wanted to do that. In The Witness, there's even more disabled story mode. Hello, cat.
Wow, what's he doing here? Sorry, he's rubbing my Willem Dafoe doll.
Yeah.
Oh, weird. Willem Dafoe. Anyway, I'm sorry. Even in The Witness, there's even Willem Dafoe doll.
Hello. In the sense that it's got this classic style, sort of like BioShock or whatever, where there's audio logs placed around, right? In The Witness, none of the audio logs contain information that you need in order to win the game, right? So they're all completely optional, and they're all just sitting there. You just, if you want to, you just don't ever click on it to get them. But what they're there for is to, and so the game should be able to stand up without that, right? So Braid should be able to stand only on game mechanics. Like if you didn't know English, or you were playing it in a language that you didn't know, you should just be able to play it and have a strong experience without that, right? Witness should be the same way. You maybe don't get as complete of an experience in a certain sense, where, I mean, if you only want a game mechanical experience, then that's complete and that's fine. And that's, I designed these games so that you can have that. If you want more of a story world kind of a thing, then that's there for players who want to take initiative and look for it, right? You can't just knock something down.
Destroyed my set. He wants to eat, I'm afraid. I'll have to see him later.
So if people don't like story, I'm cool with that. I'm actually not big on story in games. I don't know why I've made 2 games with story stuff in them.
I'd imagine you just are compelled to have a story in you that wants to come out. And
maybe, but this might be the last one actually.
Really?
Next game might be story free. We'll see.
Huh. Interesting. Well, I hope if you have a story that you put it in and make it an option for me to experience it, because I think you're doing people. I keep wanting to compliment you. I should stop it. It's got to be awkward for you, but it's such a great thing. This is what I want the next milestone of gaming to be, which is to give player that much agency that, like you said, you don't feel like you're fighting the designer who's forcing you to scroll through word balloons that you don't care about. To have the game be as simple or as complex as you choose to make it, and for the designer to respect the player's experience, but also their intelligence at the same time. I think that's where the conflict often is. The developer will respect your experience, but dumb down how smart they think you are to make things really easy, to make sure you have fun all the time. Or they'll think that you're really intelligent, but then make you work really hard, and then you feel kind of put off by all the text bubbles are thrown at you. So it allow for both of those is where I hope gaming goes from there.
And also that idea of having a variable level of engagement for different players is also, I think, a way of accommodating what we were talking about before, about being able to ask something of the player without demanding they be super hardcore and shutting the game off in their face if they can't solve some action challenge, right? So like I'm making a puzzle game, for example, and some of the puzzles aren't that hard. Some of them are pretty hard. Some of them are not. But you might sleepwalk through the game and sort of do them and not really understand what's going on that much. But if you choose to think about it a little more, like, wait, there's something funny about these. Let me look at this more. You might come to understand something deeper about those puzzles that somebody else sleepwalked through, and then take that understanding into other parts of the world and be able to use it, right? So, I very much believe that if the player wants to invest in playing your game with their time and attention, that the game should reward that investment, right? The game should, wow, I just got Google Plus something.
Oh, did it ask you if you were still awake?
Yes.
Yeah, it does that to me all the time.
Okay, but the game should provide things for people who want to discover things. I mean, I think that's one of the most beautiful experiences in gameplay, right? Is when you took initiative. You have some idea, like, what if, and then you go somewhere and you do something that wouldn't be necessarily expected by most players, and you find something there, right? And there's sort of hollow versions of that a lot, like, there's a little collectible hidden around this corner. That's like the small version. I shouldn't say hollow. It's not hollow. But like, I'm trying to design for that in a bigger sense, and we'll see what happens.
Yeah.
Let's get to some more questions, though.
Oh, okay. Sorry. That's just really fascinating. License to Bill asks, oh, wait, Damien Sommer. Sorry, I can't skip you, Damien. He designed a game called The Clown Who Wanted Everything? I'm blanking on the name all of a sudden. I was talking about him earlier. He's a neat guy. He says, hey, John, great is what got me back into making games. My question is, are you ever going to return to making Raspberry? I think it had a lot of potential! Exclamation point. What's Raspberry?
Yes, okay, so Raspberry is a prototype that I made that I actually posted for free on the internet, so you can download it and play it. I was talking with some friends over at one of their houses one day, game designer friends, and we were talking about how games try to create meaning with story all the time, right? And like I said, I'm kind of not that big on story in games, because I think other media do stories better. So I said, well, if I want to create an emotional experience, why not take a cue from another medium? Why not go to like music that doesn't have any lyrics, which we know can be very emotional, right? And why don't I try to use that as some kind of a template for gameplay and try to design gameplay like that? So the idea behind Raspberry was to make gameplay that kind of ebbs and flows, the way like a music might have call and response, and to sort of shift and blend things together. And it wasn't, music that has been evolving for thousands of years is a very high bar to set, and it didn't hit that bar, but it was interesting. And Oh, actually, I have worked on it a bunch since then. I've got a current version of it that's pretty different from what's posted on the internet. It's just my standards for what a game is have also gone up tremendously because I've been working on 2 games that I think are very good. Braid and The Witness, I think, are both. So the question is, what's the version of Raspberry that's that good? And I don't know yet.
But you haven't shut down the question. You're still.
No,
asking.
I haven't. And for a while, I was thinking I would go back to that after The Witness. Now I'm not sure. I need to play with it, but I don't have time to play with it.
Right. And you're still young. You've got time. That's exciting. Oh, yeah. You ever watch Porco Rosso?
No, but I've been interested to see that because that was a big influence for Jonathan Mack, also in the Jonathan Club on Everyday Shooter. That.
Oh yeah. I didn't know Porco Rosso was a big influence for him. So much of what you're talking about makes me think of Porco Rosso because I got a Japanese VHS of that from my Japanese teacher in college.
Yeah.
I'd watch it in Japanese, awesome. Watch it in English and know what they're talking about, ruined it. Can't even watch it in English. Yeah. Leaving the rest, just having the sounds of what they were saying express feeling, almost like, scat poetry that I didn't understand. Yeah. But leave the dialogue out made it so much more meaningful to me. I just thought I'd tell you that. License to Bill asked, how would you compare Braid and The Witness's storytelling? I guess you talked about that a lot. But
a little bit. I can say a little more directly to that.
Okay.
So the storytelling in Braid is it's a little bit almost fable-ish. Like it's very presentational. It's almost like once upon a time this happened and that happened and that happened, right?
Yeah.
The storytelling in The Witness is very different from that. In part because it's spoken and not read, right? And in part because rather than being fable-like, it is very plain speaking. Like my writing goal for The Witness is to have all these audio logs that you listen to, have the air of somebody speaking to you as directly and straightforwardly and simply as possible all the time. And that's actually very difficult because this history of games that we have that do these audio logs, it's all presentational, right? It's like I'm hiding the extra health packs in the safe and oh my god, the alien is chewing on my leg, get him off, right? Like that's a typical audio log. And it's very different from what I'm doing, right? I want a person speaking like honesty. I want honesty, and honesty is hard to get when you're putting on a show. So it's very challenging to write now, and I actually haven't written a lot of it. So we'll see how it goes.
That's exciting. As someone who writes, you catch yourself trying to sound funny and smart all the time, and your message will get lost. My goal would just be to say, in 3 words, make the reader and not have to work at all. Just in 3 words, tell them exactly what I thought. And that's what I aspire to be able to do. And it sounds like that's what you're trying to do with The Witness's storytelling as well. Yeah. Awesome.
So we'll see how it goes.
Yeah.
How it goes.
That is a very interesting trend. Do you guys see that?
They're on the show every week, and I've been listening to it every week. I'm sorry. Pio Con Analog.
Complexity increases with the size of the file. That's really interesting.
And success. Whoa, that would be hard. I'm sure you learned so much.
Really interesting.
Yeah, I mean, it's a lot. I mean, I'm a different game designer now than I was before I started making Braid, right? So, what can I even say about that? If I try to distill it down to a couple of things, the most important game design thing is just that game design is not about me being smart or something, right? Or it's not about me, let me put it differently, it's not about me having good ideas. I have good ideas as a designer, but what I've found fruitful in design is to use those ideas as a starting point and then explore what happens. Like, I actually gave a whole lecture on this at IndieCade last year with a guy named Mark Bosch, who's making this really good game called Miegakure. It's a 4-dimensional puzzle platformer. I don't know if you've seen it.
Oh, I haven't. Sounds interesting.
It's not out yet, but this lecture's on YouTube, if anyone wants to go look it up. And basically we talk about how to start with those initial design ideas, but then explore what exists like connected to those, and find something richer than what you started with. And that's sort of what I learned, is that there are things out there that are better than the ideas that I initially have, and my job is to go find them, put the nicest ones together, and then show them to people. That's my job.
And that you find that in the process of making your game.
Yes, you can't know what those things are before you start, right? You have to find them in the middle. So it's challenging, and it's maybe stressful, because you have to start something and not be sure if it's good. But you can, part of what makes this a good process is that the things that you find by messing with game design are, in a certain sense, truths of the universe, the same way that mathematical statements that you might find by proving them from other statements are truths of the universe, or that by doing physics experiment you might prove things that are true, like physical laws, right? Those same things also exist in game design. It's a little different, but it's kind of got the same flavor. And so I, as a designer, can have this feeling that I am, I'm not making entertainment products, but I'm building something that explores and expands the knowledge available to humanity, right? So
this is way too
that's what I do now, and I didn't have that picture very clearly. Before Braid, I sort of thought of my role as a game designer is to come up with innovative game designs and make them, and expand game design that way. But it's something different now.
Wow.
So
that's incredible, and you would have only been able to find that out through the experience of making something like Braid, where you ended up was not where you started in the end. That was a long process.
In a sense, I got lucky that the game had such rich subject matter, because it showed me how much there was to find, right? Like, if I had started making a game and there wasn't that much to find, maybe it would have been more about me putting good ideas in rather than getting good ideas out.
Right.
So who knows?
Yeah, it wasn't lucky. I mean, sure. I mean,
skill probably comes into play, right? Because you have to know how to respond when you see things, or how to put them together, or what the right way to pursue this idea that you see is, right? So there's definitely game design effort involved, right? But there is also luck, for sure.
Yeah, I'd have to. I wouldn't know because I haven't done it, but I just have to think a lot of it has to do with the brain that you happen to have. What brain you have? 5 minutes left till the show's over.
Are we trying to get all the questions? Is that
let's try to do it. Let's try to wrap them up quickly. Oh, there's so many though.
Okay, well, I can answer some of them. So one of them is asking, says that the music in Braid is nice, so thank you. And he's only sent half questions. Well, we'll try to get through as many questions as we can regardless. The Witness does not have music in it. It might have one music track, but for the most part it doesn't, because it's about being in a world. So what we're trying to do is build a really nice textured soundscape that reacts organically to where you are and always has new things to hear and gives you new feelings, but that doesn't have any music at all. We'll see how it goes. One piece of technology that currently doesn't exist or isn't tractable that would significantly change the way we play video games for the better, yes. The controller, the current motion controllers that we have are not necessarily very good. Future motion controllers may be better, but if you think in general about the idea of communicating with a game, the game spews all this information at you, right? Full screen graphics, like with rich color and all these sounds. If you actually quantify how much information that is, it's megabytes per second at least. I don't know how much, right? It's tens of megabytes per second, probably. The amount of information that goes the other way from you to the game is very, very tiny, right? It's like a little bit of analog stick, a couple of button presses once in a while. If you were to compare that to the image,
this is unbelievably slow. It's insane. Like, I don't even know what I'm waiting for.
At most. Right. So you've got a couple of pixels going one way,
this is fucking
and
ridiculous.
gigantic, 720p with audio and rumble and stuff coming
looking the other way. It's very imbalanced. So how do we get more information from the player into the game so that the game can react to you more, and so that you can have a better way? And I don't know that, like, full body control is probably good for some kinds of games and not good for others. Like, sometimes you just want lessons, right? But, like, if you can get a mind machine link or something, great, whatever. I think we have a lot to figure out there.
Yeah. No, you talk.
Sinistar.
I'm probably going to tell us we have 2 minutes left.
Coach, you speak English? English, yes. Bro, you look mad sus, bro. Yeah, nice to meet you.
Now that I've worked on big 2D and 3D games, I think I'm going to stick to one of those from now on. 2D is definitely easier to experiment with and make a game if you're an indie starting off and be successful. And 3D is really hard. Like, you have to do a lot of work that is not related to what you're trying to do. This game has 3D, which is why I did it in 3D. But now that I've got a company, you know, full of highly talented people who we're good at what they do. I mean, that's I guess. It may make sense to do 3D more. I don't know. I have a little bit of trepidation about it though. But these people are specialists in doing 3D, so it's like, well, what you can do. We'll see. But I don't encourage people to do 3D. It's really hard. It's a good way to fail.
What am I fucking waiting for? Like, seriously.
Yeah, it's scary.
Fucking continue.
Well, we can go a little over. Do you want to go a little over?
I'd like to answer people's questions.
Yeah, keep going if you don't mind.
Yeah. Okay, have you ever seen someone do something unexpected in your level or complete it with an unorthodox method? In Braid, I'm pretty sure there's a guy who did a speed run. It's on YouTube. That's really fast. I think he may have done 1 or 2 things that I didn't expect.
Honestly, I do not like open code.
It's such a minimalist game. There's just not very much in the world, right? So, you know, usually when you do a speed run or something crazy, it's because you used interactions of things in the game in a way that the designers didn't expect. And Braid isn't that kind of game, and The Witness isn't really that kind of game either. It actually has very minimal interactivity in it, in a certain sense. It's mostly about you walking around and seeing things, and then, you know, picking what you're gonna mess with. But there's not like physics in The Witness. Like, even Braid has platforming physics. So, but that said, I wouldn't be surprised if somebody finds something surprising. It's hard to say. We're so early. Like, the game isn't done yet. So, but I love it when players do that. Like, that's one of the great things about game design is that you're not just making something, but you're letting people loose in it and they surprise you. That's really nice.
Yeah, it must be like a collaboration at that point.
Sort of. I mean, you don't know what they're going to do, so it's an extremely loose collaboration, I guess.
Sure, but they're designing too at that point.
Yeah. Oh, absolutely. Yeah. You can't. If you try to take the player out of the experience as a game designer, what you make is going to suck, right? You always have to be thinking about the player. What's my opinion about Kickstarter projects? Since I'm involved in an indie fund, which is a fund put together by me and a number of other game developers. I actually think Kickstarter is great. Like, the more ways that people have to get money and fund their own projects, the better things are.
Bro, why are these all a fucking NPM package? It's actually insane. Fucking insane Python.
It'd be nice if we break even or make a little bit of money, but we're not making decisions based on what will make us the most money. We're more about trying to get creative games into the world and trying to help developers who want to make creative games get set up and be independent and have a good amount of money coming in, so that after that they continue to make more good games without our help, right? So our ideal is if somebody doesn't need us anymore as a developer after we fund their first game, which, if you are trying to extract the maximum amount of money out of the developer, which is usually the publisher-developer relationship, that doesn't happen. Yeah, from that standpoint, anyone else who funds games only helps, right? Because we're trying to shift that power balance, right? If publishers know that developers have other places to go for money, and developers know that too, then they know that the developer might just say screw you to a deal that is too onerous, right? That tries to lead the developer too hard. So you might see fewer developers going out of business or something like that. I don't know. We'll see. too early to tell.
Yeah, but that's the hope. That's the exciting hope.
Yeah,
to really disrupt.
Well,
it's such awesome disruption.
Yeah, I mean, a lot of people are making hundreds of thousands of dollars, or a few are making millions of dollars on Kickstarter, and that's pretty awesome. So I hope that continues and that we see a lot of that. Should we always seek to, it doesn't say who this is from. Still Holmes, yeah. I skipped over that. Should we always seek to fully explore the artistic capabilities specific to the medium before we attempt to replicate the experiences found in other mediums? Yes, I think that if you're going to make games that are really good and that really stand the test of time and that push the medium forward and really make special experiences, you should do stuff that is sort of in the wheelhouse of what games is good at, which involves interactivity and the player making choices and the player being involved, right? And if you look at what movies do well or what novels do well, it's not that at all, right? So if we go to those too much for model what we're making, then we're sort of missing what happens in games. So absolutely, I encourage designers always to try and ask, what is it that a game does? Focus on that and making that good.
And what they do too. There's so many designers who think, oh well, because movies are popular, I should think like someone who makes a movie, and they forget to notice how they think.
It happens all the time, and it doesn't work as well, you know. And it worked a little bit back when we were impressed by the very existence of a cutscene in a game or whatever, right? But that's not how it is anymore. Bruce Leaf asks, did you learn all the math and physics you know in school and college? No, I learned almost everything I know, including computer science and programming, after college. Although college was very helpful because it sort of got me started with how to learn and how to take these subjects seriously. But actually, the place I really learned math was after college, because it was 1995, 96, and I was trying to make a 3D game as a new company in that environment. This was before indie development was like a thing. We were just like a couple guys and like, oh, we can compete with those bigger teams of like 10 people, which is how big teams were back then. But it was also the time when games were starting to be 3D. There wasn't hardware accelerators for graphics, so you had to program every pixel on the screen yourself and still make the game 3D, which if you look into what that means is really involved. Especially to do a good job and to make it fast on a 486, which is what computers people had. Or I guess they were Pentiums probably most of the time. But yeah, so I started learning math there, and then I just found that I was really interested in certain kinds of math, so I kept with it. And so right now I'm in an online quantum computation class that I don't have to take, but it's pretty fun. So yeah, that's cool.
That's really hard. On top of just running a company and making a huge, risky game, you're just...
Yeah, it's only the first week, so I don't know how hard it is. We'll see. But it's actually good. It's good to have something to do in the off time when I'm not working on the game. I've gone through periods when I'm working very hardcore on this game, like every waking hour, probably. Or trying to work on it every waking hour, and then if I flake for an hour and like read an internet gaming news site or something, then I feel bad about myself. But you need breaks sometimes, or you just go crazy. So it's a good break. It's like I can be productive on something else that has nothing to do with my game and has no bearing on it, so there's no stress or pressure. Right. Some nerd asks, do you still believe in ethical or unethical game design? Yes, absolutely. Video games go out into the world and millions of people experience them. They're part of the modern environment, right? So anytime you put something into the environment, you should probably at least think about what that is doing, right? It's obvious in the case of like a substance, like a carcinogenic whatever, right? You probably shouldn't be pumping a lot of that into the water if you make cigarettes or something, right? But even for milder things, right? Like I don't think video games are going to make anyone die of cancer, but some of them make people stupider, you know? I think that's true. Some of them reinforce, you know, negative aspects that we don't necessarily like about ourselves. And as a game designer, I think you want to ask if 5 million people are going to play this, is that really good? Can I even change it 5% or 10% to just make it
have a little bit of a better impact on the world. I think that's a very useful thing for a game designer to be asking themselves all the time. And someone whose name I don't know how to ask.
I know, it's hard, isn't it? Hula, Texas.
I've played a demo of The Witness yesterday in Paris, and I wonder if the game will stay as austere in its presentation. It's not exactly a demo. It's sort of an early version of the game, limited to a very strict play area at the beginning. Will it be as austere in its presentation? In a certain sense, no, because we're really not done with the graphics. Most of what you see in that test demo is temporary. Some of it, like the castle walls, is probably a little further along.
How is this guy getting to just play your new game in Paris?
You don't get to really play the interesting part. You just get to play the... it's in a museum.
Any part is pretty interesting.
Yeah.
It's just in a museum? What is going on?
Which is going to change a lot. So I haven't really announced it or anything. It's just, it's...
So if I go to Paris right now, I can play The Witness somewhere?
I believe so. Yes.
That's a really interesting life you're having, isn't it?
I mean, somebody was putting, a friend of mine actually was part of a group putting together an exhibit about, which I think was originally partially about architecture, and we have architects working on the game, so that was kind of interesting. But I think it's more broadly now about just like good games or artful games. So there's a bunch of games there. That's the thing now. Museums have game shows sometimes. It brings the kids into the museum. It makes them interested in museums.
Wow, weird. Artful. So should we stick with artful games?
No, I don't want to use
experimental games.
No, I would prefer. So if we get to a point where enough people make games that are really interesting and heartfelt or intellectual or emotional in a non-13-year-old teenager way, which I've been a 13-year-old teenager, there's nothing wrong with that. I'm not dissing that.
Sure.
But there's more to life than that, right? Once we do enough of that, then maybe the medium gets more respect. Like the way I always explain it to people now, so you're going to go read a novel written by somebody, right? There's a range of novels, right? There's like trashy crime novel that you pick up at the airport that you don't really expect to be good, probably, right? And there's like great novel that somebody worked really hard on that you expect to really contribute to humanity somehow. That's all in the spectrum of novels, and you don't. If you put, The Great Gatsby on your table and you look at that, like that is not considered an art novel, right? It's just a novel.
Okay.
It's a book. It's just like
it's a good
right?
novel.
It's a good book, right? So hopefully we can get to that point where we don't feel the need to make that distinction with games, right? The fact that we need to say art game right now is just sort of weird, right? Once we don't need to say that anymore, then we're better off.
Yeah, absolutely. Absolutely. In the meantime, people will come up with a term, and whatever term sticks will be stuck with, I guess. But I hope we move to a point where the term isn't even necessary because it's just understood. Some games have a lot of thought and feeling put into them, and some don't. You can assess them individually instead of grouping them. It's almost, to me, when someone says art game, it just means good game. And that can be anything
that's exactly
from...
why these arguments happen, right? And
yeah.
I don't mean that when I say art game. There's certainly bad art games, but I would say that's an art game. Which is why I don't want to use the term anymore.
Yeah. I'm sorry I brought it up. But I'm glad we established a final message for the people. Is there anything else you want people to know before we sign off?
I don't know, man. Be excellent to each other and party on dudes or something.
That's a good one. There's so much more I wanted to ask you. I meant to ask you why you do everything you do.
We can do another thing after the game comes out. Maybe.
You want to do that? That would be so great for me.
Yeah, I mean, that'll be a while from now, but
It'll be 2012 or 13?
It's looking unlikely that it'll be 2012.
Yeah, all right. Well, 2013.
We'll the game next year sometime. I don't actually know when it's going to ship because it's a when it's done kind of situation. So when it's done. But it's getting there. So we'll see.
It's exciting. They can follow The Witness and you on Twitter, right? You have Twitters?
Yeah, there's a Twitter account, Witness Game. There's also, I have a personal account. There's also, if you just search for the Witness blog, there's a news blog where we post actual development updates and stuff. It's not like a PR kind of thing. It's like, here's what we're working on this week and stuff like that. We probably don't update that as often as we should, but once in a while. So yeah.
Awesome. Yeah, and you can follow me at TronNauts on Twitter. And you can watch the show on Detoid's Twitch TV channel and also get it on iTunes. We've got a whole bunch on iTunes now.
How many kids these days know who Don Knotts is?
Well, see, that was me being artful. I didn't care if it was going to have mainstream appeal. I just freaking love Don Knotts and Tron. So I couldn't help but put them together. Yeah.
Makes sense.
Yeah,
all right.
Awesome. Thanks so much, Jonathan.
Thanks for having me on. It's been fun. I like this kind of thing where you just hang out and talk and stuff, you know.
I had such a good time, I can't even tell you. Yikes, I feel weird
I had
about
a
it.
good time as well. Thank you, everybody out there who I can't see. Thank you, Sinistar.
Well, first Holmes was born, then he got that old and tired. Almost.
Okay.
Back when Braid came out, there certainly had been independent games that people were paying attention to before that. But sort of that year, 2008, saw a number of indie games that all came in the same year that were all kind of at the same level of seriousness. And by that I don't mean like serious work of a game, but like that these are no longer like tiny games that you just kind of like, oh, it's some kid doing something cute, right? It's like actually there's enough meat here to this game that you might care about this as much as you care about a AAA retail game, right? So games that came out that year, N+, Castle Crashers, you know, Braid, World of Goo, and that really changed the climate around what indie games are and how much they're worth paying attention to, you know, and so maybe now in 2012, you know, indie games come out and people really come to them with the expectation that they're worth paying attention to and will notice more about them. It's a common thing among game designers, especially these days, to get into discussions about fun, right? And they're difficult discussions to have because fun is a very amorphous word. Like what it means to you may not even be the same thing it means to me. An example that I bring up all the time, a much older game, right? I used to play Counter-Strike quite a lot. I might offhandedly say that's a really fun game and that's why I play it, but it is not a fun game. It's a grueling, punishing, brutal game. Yeah, I don't like to use the word fun too much to describe what I try to do. I appreciate it if players find a game that I make enjoyable, right? And hopefully it is often, but it's usually not the point. So like, you know, as you said, Braid is not really a fun game for many people, probably most people. And it's not designed to be fun. You know, it's designed to be interesting and designed to provide the player with difficult mental challenges. To me, that's the meat of that game and what makes it different. And you could call that fun in the same way that Counter-Strike might be called fun, but that leads to discussions that are hard to have, I think. You know, in movies, we have all these different genres of movie, and when you go to a different genre of movie, you have different emotional expectations, right? They are still sort of this commercial experience in that you feel like, I paid to go see a comedy, so this better be funny. But that is not an expectation you would have going to see a drama, or going to see a documentary, or whatever, right? In games, we don't seem to have that, right? Like, everybody expects this fun thing out of all games. And maybe we just, you know, right now our genres are more along mechanical lines rather than emotional lines, right? So, you know, we have an RTS versus a first-person shooter. And maybe we ought to have a different categorization. It's like fun game versus, you we would have to invent these category names, but like, I feel happy while I'm playing this, or I feel like I'm confronted with grueling choices while playing this, or I feel powerful while playing this versus I feel helpless and I'm always trying to scrabble along, right? Those are very different emotional places to play, and we're only just really getting started exploring those as game designers, and I think that there's a lot of interesting work to be done there in building these different things.
What the fuck is it?
How people feel when they play them. So I don't play very many Japanese games anymore, but the reason is because I've concluded that I don't like modern Japanese games. What I strive to do in my own games, which you can see pretty clearly in Raid and is carried over to the Witness, is to respect the player as an intelligent person who can figure things out and who wants to discover things or come to understand more things than they knew at the start of the game. I want to respect my player's time, so I don't want to give the player like a lot of filler just because I feel like gameplay ought to be 60 hours long, right? Most modern Japanese games that I play take the opposite stance completely, right? They take the stance that the player is afraid of your game, and if you're not very careful holding the player's hand through everything, then the player will run away or just won't be able to handle it. I don't think that that's an actual cultural difference, right? I think it's just, sometimes industries get an idea about the right way to make games and they sort of get the wrong idea. Like, there's lots of things that Western game designers, industrial scale game designers like EA or Activision or wherever, things about the way that they have concluded are the right way to design games that I think are totally wrong. And so this is like the Japanese version of that, right? They don't just give you a simple situation and let you work it out. They explicitly tell you what to do and then say, it's not hard. Don't be worried. Go ahead, you try now, And then you try and you do it, and halfway, when you're in the middle of doing it, it stops you and it says, now remember, during the next part, rotate the block to the right. Once you've done that, it eliminates the joy of discovery, which, as I've said, is something I really value. I really value that click that happens in your head between you see something and you don't quite understand it, and then suddenly you do understand it. And that is a fundamental part of human existence in the world, is that kind of mental growth, that kind of expanding my sphere of understanding the world around me. And when you build an entire game that's I tell you what to do and then you do it, okay, you're not going to lose the player, but you've prevented that player from having any joy of discovery at all. And I want to play games that are like that. So as I said during the Indie Game the Movie panel, though, right, not all Japanese games are like that. You could certainly find exceptions. There are some notable exceptions that came out recently. But when I think Japanese game, that's what I think. I feel like it's important to have these conversations. Like, if our cultures have value to each other, part of that value is in communicating about what we perceive in the other culture, right? And it's easy to be too afraid of that. I don't know that the controversy ought to be the focus. I think that there's actually an interesting design discussion to be had there, and I would like for that to be the focus.
Welcome to a Rice University WW.
I actually didn't do completely all of the programming. A friend helped me in the last 6 weeks of development, but yeah, basically.
Slaves to behavior-controlling parasites. Suddenly, these rogue ants no longer serve the colony. They're taking their orders from the parasite. Okay, let's back up. Now, how did this happen? It all begins when the ants in any town, USA, consume the slime of a passing snail. They divide it up and take it back to the colony. This is a blunder of epic proportions. Turns out, the slime is loaded with eggs of a body snatcher called the liver fluke, a type of flatworm. The liver fluke burrows into a part of the ant's brain, and for unknown reasons, it's almost like the fluke enslaves the ants and orders them to carry it to their next hosts. Any grazing mammal host with a nice warm liver will do, but in this case, a cow appears. The liver fluke worms can switch the ant's behavior on and off, causing the infected ants to place themselves in easy-to-eat positions at dusk when mammals are feeding. No cows in sight. Ants act normal. Cows appear. Ants are in essence ordered to take their positions in purple flowers and latch on. The cows ingest the vegetation, the ants, and the fluke larvae inside the ants all in one bite. Once inside the cow, the worms burrow out of the stomach and into the liver, where they develop into adults and dine on liver tissue. They lay eggs that are excreted from the liver into the bile duct and then defecated by the cows. They don't kill the cows, but the cows become weak and emaciated, devastating herds. And all because of parasitic mind control.
Think about that for a second, while I swap monitors. Think about that for a second, while I swap monitors. Okay. So, I have the good fortune to be both a game designer and a programmer, right? And that's pretty cool, because what I do from day to day in my working life is I decide what to do, and then I just like type it in and make it work somehow on a computer, right? This is different from what a lot of people in games do, where they have to like get an idea and get permission to implement that idea, or else, you know, they have to do someone else's idea that they think is kind of stupid, right? Because of this, I have a lot of freedom in terms of what I work on, and what I've been doing for the past several years at least is figuring out ways to make games that I think are, you know, deeper than current video games or more meaningful than a lot of video games. But those kind of phrases like deeper tend to set people on edge. They're like, oh, what's wrong with current video games? They're saying current video games aren't good. They're not deep. And so there's a phrase that I've sort of learned to adopt a little bit that helps discussions proceed without being argumentative, right? And it's this phrase, speaking to the human condition, right? This is a traditional thing that we say about art, right? When people talk about the good parts of films and novels and paintings and music and sculpture, and they talk about how these things can affect people deeply or change their lives or reveal truths to them, we'll say that these works speak to the human condition. But the magic of this phrase is that it's pretty vague, right? Nobody will agree, or even nobody knows exactly what it means. But that's actually part of what allows us to employ it usefully, right? To have discussions. It's a little bit of a paradox there. But I and many other game designers who are sort of in my school of thought, not my school of thought, but in a common school of thought, we feel like games so far don't do a very good job of speaking to the human condition, whatever that means for each individual person, each individual designer. And so we're working on that. We feel like games currently tend to be temporary diversions, right? Something I do for a little bit, but I don't really care about in the same level of magnitude as the things that are truly important in my life, right? And so the operative question for me is, can that ever be changed? Can games become a medium deeply important to people? Deeply important to more people than like a professional StarCraft player or something like that. So let me set some context for this discussion. I'm going to talk about a couple of really old games from the 1980s. This first game is Pac-Man. I think even today everybody knows this game, right? It's an arcade game. It's very simple. You run around this maze and you collect dots, and you try not to get killed by the ghosts, except sometimes you can turn around and eat the ghosts. It's a fun game. Even today, it's kind of fun to play. It had good game feel for the time, which is just the way the controls feel and the way the sound effects sync with the graphics and stuff. But most people I know would not say that Pac-Man really speaks to the human condition, right? This is not going to be a game that like you go, oh, it changed my life, right? It was really meaningful to me. No, it's a fun game, right? But it's just about running around a maze eating dots, right? Simple game. Here's another game. Most people probably don't know what this is. Does anyone know what this game is without reading the caption? No. It's a game called Impossible Mission. First platform it was released for was a Commodore 64, and it's a James Bond kind of game where you're infiltrating a evil genius's underground fortress to like stop a nuclear launch or something like that. This was pretty much the Halo of 1984 or something like that. In addition to being very ugly, though, by modern standards, it's also kind of unplayable by modern standards. You kind of take these elevators around, and you're trying to reach these obstacles on the level so you can like search them and find things, and you're trying to jump over these robots that shoot lightning out. So it's all this like pixel-perfect jumping and not falling into the gap and things like that. Which video games of today still use once in a while, but this game is like 100% pixel-perfect jumping, and you get fried, and you have to restart at the save point and do all this hard stuff over again. It's all these things that, since then, us video game designers have learned not to do, because when you make things really difficult, when you throw a bunch of challenge at the player, but they can see that the thing you're challenging them with is relatively meaningless, like jumping over these stupid robots, then they tend to just stop caring about it very quickly, right? Now, the reason people loved this game back then is because this was new. Like, wow, I'd never played a game where I, can pretend I'm James Bond and infiltrate this mountain fortress. But now we've played so many, I would say, better video games that nobody wants to go back and play this, right? So, in the couple of decades since then, game designers as a community have learned some best practices to help them make games that are either more playable and more enjoyable by a wider audience than something like Impossible Mission, or things that are larger and more intricate and deeper than Pac-Man, right? And if I were to write out the full list of what game designers have figured out, it would be many, many pages. I mean, I could probably write books on it. Not that I would ever want to, but I've sort of picked 4 of the major things that all of you guys are going to recognize, assuming you've ever played a video game, right? The first thing that we learn to do is put story in a game in a very concrete, progressing way, right? The story of Impossible Mission is like, hey, you're a secret agent and you're trying to infiltrate this fortress, but that story doesn't progress. There's no plot points or anything. It's just you're trying to do this, and then you eventually solve enough puzzles and win the game. Humans like to hear stories. Stories have a magnetism. We want to know what happens next. And what game designers have learned to do is take that desire to find out what happens next and help use it kind of as a rope to pull you along through a video game. Now, in addition to pulling you through the game, it has this secondary function, which is to justify what you're doing with a fictional excuse. If you play old school first-person shooters like Doom or games like that, really literally at the dawn of the first-person shooter, the way it would work is you're running around shooting a bunch of monsters, and you're trying to get to the end of the level, and you run into a door, and it's a red door. And you know that to get through the red door, you need to find the red card key, right? And so you go find that, and you go open the door, and you keep going, and eventually there's a blue door, and you know you need to find the blue card key, right? And that was literally the way these games were paced for a while after that, is just there's these relatively arbitrary game mechanical things preventing you from progressing. Now there's a green door, right? And you knew exactly what you had to do to get through the door, but there's no reason for it, right? Now we have games like, you know, Modern Warfare, where it's like, oh, we need to drive this tank to the next mission, but the tank's out of gas, and the guys are like infiltrating the fuel depot, so you need to like shoot a bunch of them and get in there and get some gas cans and bring it back to the tank and fill up the tank so our boys can drive on to the next mission. It's really the same thing as the red key and the red door, but now there's like this huge scaffolding around it to make it fictionally plausible and to try to make it engrossing, right? Another thing we've learned to do is add a bunch of eye candy and ear candy, like nice sound effects to games, because human beings like visual and oral stimulation, aural stimulation. And you know, often the more of that, the better, even if it's subtle, even if you're looking at a game that's just a beautiful vista or something. It doesn't have to be explosions and bright fireworks going off everywhere, although many games take that approach, right? The more of that we have and the better synced it is to the sound effects, the more compelling the game ends up being. The third thing is how we keep people playing, which is not only do they have a long-term goal that helps them make sense of what they're trying to do, but you break that up into little bite-sized goals. So it doesn't feel like I'm trying to do this epic thing that I don't ever know when I'm going to accomplish it because I have a nearer step, right? So maybe, I don't know, the tank mission isn't a very good one because first-person shooter missions aren't this long, but just imagine that it was an hour-long mission and getting the gas can was the half-hour point, but there was like a 5-minute point of like, your first waypoint is to get up on the tower and scout out where the enemies are. Then you've got to go find the key, and then you've got to get open the warehouse, right? So you add these goals where the player always knows what they can do next, and it's a relatively easy thing. It feels well within their reach. And this keeps people playing. It's like, you know, just one more level, or if I just do this next thing, I'll be in a good spot so that when I save and go to bed and wake up tomorrow, you know, I'll be in a totally good position to keep going. And then, of course, they do that one thing, and then there's just one more next thing just within their reach now. And so they keep going, and you pull them through the game that way. And the last thing I want to highlight here is this feeling of constant improvement that we've added to games, which comes in many guises. Probably the most familiar one is in role-playing games where your character has experience points and you get enough of those and his stats goes up, right? But that's actually, you know, a more Byzantine version of just score that we used to have in arcade games, right? Score provided a feeling of constant improvement because you could play again to get a better score, and usually that would work. But now instead of having it be a player skill thing, it's what we call an avatar skill thing.
What is taking this so long?
It's more of a fictional thing in the game. So you're not improving your own skills, you're improving the fictional skills of something in the game world. You're learning new spells, you know, you're getting more gold pieces, you're getting awesome magic items that like glow with fire, lots of eye candy when you run around with them, right? So hopefully all of that makes sense to everybody and there's no surprises there. Now, to segue into the next part of the talk, I think it's important to say that this kind of collection and hoarding mechanism, which we see in RPGs originally, but it's starting to spread into a lot of different game types, especially casual games, is the way those rewards are scheduled. We tend to do it with things, if they're not exactly a Skinner box, they very closely resemble a Skinner box. And in case you don't know what a Skinner box is, it's something like this. It's an experimental setup where you have a mouse living in a box and he can't get out. And every once in a while, some kind of stimulus plays, like a light goes off or a sound happens or whatever. And during those periods, if the mouse hits a lever, then a food pellet will come out, which, whether it's delicious or whether he's just really hungry, I don't know. But then he learns that, right? And it's a way of training the mouse to perform this activity of hitting the lever when a stimulus occurs. And the interesting thing about Skinner boxes is if you give somebody a predictable reward, then the behavior is less well trained than if you give them a randomized reward, right? So if every time the light goes on and the mouse hits the pellet once, or hits the lever once and the food pellet comes out, you know, that kind of works. You can train the mouse to hit the lever, but if he has to hit the lever an unknown amount of times, like a random number between 1 and 10, you're going to really train that mouse to compulsively press this lever when a stimulus happens, right? And probably most of you, oh, and in case you want to like shock the mouse or something, there's like an electric floor. I guess that's if you're really pissed off that he's not learning to press the lever. You can do a bunch of different experiments with this kind of setup. Anyway, you're probably more familiar with Skinner boxes in this kind of context where they don't have electric shock floors. But a slot machine is almost exactly a Skinner box in that it has a randomized reward schedule that's optimized to get you to put as many coins as possible into the slot machine. Or you might be more familiar with them in this context, which is a dungeon crawler type of RPG, where every time you open a barrel or a crate, there's an unknown quantity of treasure inside. It might be completely empty. It might just have a couple of gold pieces, and you're like, but it might have like 10 gold pieces, and you're like, awesome. I'm really on my way to buying that next level of sword. So anyway, this game design best practices set here is going to be so useful to refer back to that I'm going to put it in a toolbox so I can carry it with us through the rest of the talk. But just remember what this stands for. This is all the good stuff that game designers have learned to do to make games compelling to play and more appealing to more people than the old-style games used to be. So how did we arrive? How do we know these are best practices, right? How did we learn these? There are two ways. One of the ways is very natural, and it's just this process of evolving inspiration that happens in the game designer community. Most people who want to design games are doing it because they like video games, right? So they have some particular game that they really liked a lot, and they're like, oh, that game was cool, but you know what, it would be even cooler, like if the gun was bigger or something, right? I mean, that's not a very, actually a real one is it would be really cool if you not only shot people, but you could shoot people with the gun, and you would like stake them to the wall so they're hanging on the wall afterward, right? Does anyone know that game? Yes. I don't know. Someone say something else. It was Painkiller, the original. Maybe somebody did it before Painkiller, but I don't know what game it is if they did that. So there's this process of taking something you thought was cool or interesting or neat and making it better, right? And that's a very, I'm going to say, innocent kind of motivation, right? It's a joyful kind of thing to take something that was there done by your predecessors and kind of stand on the shoulders of giants and make something even better. But over time, as game budgets got bigger and we became more professional, I put that in quotes because it's a word I really don't trust, we learned how to monitor players in a little bit of a better way. Because what was happening in the earlier days, even into the 90s, is we'd think that our game was great, we did a really good job polishing it, it's better, clearly better than the previous game, and then you sit someone down and they try to play it, and it's like totally unplayable. They can't get used to the controls that we got really good at because we're the developers and we've been using the controls for like years. They don't understand where they're supposed to go and what they're supposed to be doing when we thought we made all that stuff clear. So the method that we've come up with for dealing with this is to just silently watch players, right? You sit them down, they start playing your game, and usually they're going to start to have problems. And typically, the way that you deal with that or the instinct for dealing with that is to help them out. Like, no, oh, sorry, we didn't make the HUD for this clear enough, do this thing or press this button. But you don't do any of that. You don't help them at all. You just sit there and watch them, right? And it's very painful to sit there and watch them, but you do it, and every time there's a little glitch or they get confused, you write it down, and that gives you your to-do list for when you go and work on your game later, right? This is a sort of I will say, a little more scientific way of designing games than the first way, than just what I think would be cool, right? Because it involves empirical observation and then responding to those observations. I have to find where I am in my notes because I haven't been using them. All right. Okay, so imagine I've done all this and I'm making some modern game and it's a dungeon crawler game. And it employs a bunch of those things from that best practices toolbox, right? So it's got a treadmill of player stats that just go up and up and up, and equipment stats. You can get better and better swords and armor, and many different categories of equipment, right? And the equipment prices go up, and maybe you need gems for some of them, and maybe you need gems to like instill capabilities in different weapons, and then you kind of want to reclaim those gems, right? So it's kind of an intricate ecology of these improving stats on many different kinds of objects in the game, right? Then, like I said, we'll have a loot skinner box where you kill a monster and a random reward pops out of the monster, or you open a chest and a random reward pops out. We have all these cool explosion effects and weapon trails and lightning strikes and stuff like that. And we have all these little 5-minute quest milestones, so you always have a very tangible next thing to do. We have this epic story about how there's this evil guy, the Foozle, who you have to go kill in the end, and you're the only person who can do it, right? So we do all those things. And we have a very compelling game. We know that. We can almost manufacture these off an assembly line now. But now do a certain thought experiment where you take that big list of things that I just said and take the same game but strip all those items out of that game, right? So no big story about the Foozle, right? And no 5-minute quest milestones. They can be functionally there, but just don't put them in a player-leading kind of way, right? You take out the loot skinner box and replace it with typical game balance. You take out all the non-necessary special effects. You make it something like chess, right? So chess is an abstract game. It doesn't particularly have eye candy or special effects. It certainly doesn't have an epic story, but it's considered to be a very compelling game, right? There's a core of chess that doesn't need anything from that toolbox that has fascinated people for many, many years, right? So imagine the dungeon crawl version of chess, right? What would that game be? And I don't mean game mechanically, right? I mean stripped down. Here's a graph. In these games, I mentioned the word treadmill a couple slides ago. The way these are very intentionally designed is we want the player to feel more and more powerful and like he's, having progress. So he gets experience points and he gets better equipment and all that. But, if the monsters didn't get harder too, then the game would become trivially easy after like 15 minutes because we really pump stats through the ceiling, right? So what you do is you have them encounter harder and harder monsters over time, and the two go up roughly in parity, right? So what happens is if you graph the difficulty of the game over time, it's probably something like this, assuming the designer was reasonably skilled, where it starts out kind of easy, and then it ramps up after a sort of tutorial phase, and then it kind of oscillates for a bit. This line, this dotted line across the middle, is sort of what we think of as the difficulty of the game on average. And note that we actually don't make the difficulty lock to that line and go horizontally. And the reason is because that doesn't feel that good. Instead we set up a bit of an oscillation around this, so you have periods of intensity and then periods of relaxation and periods of intensity and periods of relaxation. This provides for a sense of drama in the gameplay, as well as actually allowing the player to feel powerful, right? Because if monsters are always perfectly matched to you, you never get to feel like this awesome sword that you got or the fact that you're level 17 matters, right? But if you feel more powerful for a little bit, and then that gradually wears away, people won't notice. So in some sense, this curve is about creating drama, and in some sense, it's about fooling the player into feeling like the treadmill is more real than it is. Anyway, so while you're doing all this stripping down of this game, you might as well downgrade the graphics, because that's all eye candy, right? It's not really necessary. So you probably get something that looks like an indie game, but it's all functional. You can make the same game out of all that. So after you've done this, go take a poll, right? Game companies love to ask people what they want. You go take a poll of how many people want to play this game versus how many people want to play the awesome-looking AAA game that you started with. And what you find is very few people want to play this stripped-down game. Some people might. Very, very hardcore gamers might do it, but you lose most of your audience, right? That's all I'm going to say about that at the moment. Now, this is RPGs are a very complicated genre of game, right? Like I said, they have all these intertwining things that we've learned how to weave together to create player motivation. So you can run this exercise again with a much simpler thing, and this might help convince you that what I'm saying makes sense, or it might help make the model make more sense, right? So think about slot machines again. Imagine doing the same stripping down process to a slot machine, right? So you get rid of all the flashing lights and ringing bells and sounds and stuff. And you know, you also get rid of the Skinner box, right? So you get rid of that reward schedule I was talking about. So you don't actually ever win any money from this slot machine. And just to make it fair, you don't put any coins in either. And it's actually better because now you don't lose money ever, whereas with a real slot machine, you're guaranteed to lose money over time. So this is a 100% improvement over the traditional slot machine, functionally, right? So all that happens now, we've gotten rid of all these things, so it's a relatively plain-looking box with still the dials in there with different shapes on it, and you pull the lever and the shapes spin, and either they match and the slot machine says, hey, you won, or they don't match and the slot machine says, oh, you didn't win, right? But whether you win or didn't win, you don't win anything, and you don't lose anything. So how many people would play that slot machine, right? You might play with it for a second as a novelty, but it's not something that people are going to be mobbing into casinos to play, right? And more to the point, it's not going to be something that, you know, state and national governments feel threatened enough by socially that they have to regulate it or outlaw it, right? Because it's become, by the time you take away the reward schedule, it's become a totally different device, even though mechanically it's the same device, right? So all those designer best practices that I was talking about can take something that's inherently boring and pointless, like a box where you pull a lever and don't really win anything, right? And turn it into something that's compulsive, right? Compelling. And the thing is, we can do this with video games as well, and you know, not just slot machines, right? In a sense, we figured out a way to engineer our way around boredom, right? And take a relatively pointless game that's just about like clicking on things and not doing anything real, and adding production values to it, and turning it into something that a lot of people want to play, right? And this is key, right? It's about, we've engineered our way around boredom to a certain point. And I'm focusing on boredom right now, but we've engineered our way around some other things. Like, we've engineered our way around frustration by just learning how to tune games really well and doing that player watching stuff that we saw before. Every time someone gets frustrated, like, oh, I can't beat this monster, you just make that level easier, right? So you iron out all these bumps, and eventually you get a very smooth play experience that a lot of people want to participate in. And we keep doing this in video games, just keep getting better and better and more fun, and we all live happily ever after the end, right? Probably not. I certainly have issues with this, and I know there are people who do as well. I said that we're engineering our way around boredom. What does that mean, really? I mean, there's a very obvious surface meaning to it, but like, what effect does that have? What does it really do? And to answer that, you have to know, like, well, what is boredom, right? People don't like boredom. They don't like thinking about boredom. They don't like being bored. But boredom is actually a healthy response to unproductive situations, right? Human beings have boredom as a response because of evolution, right? Boredom has survival value. What it's for is you get into a situation that's unproductive, right? Your senses aren't being stimulated. You're not learning anything about your new environment. You're just being surrounded by the same old stuff. And you get bored, and you start getting jumpy and agitated, and that causes you to want to go do something new or go do something different, right? It causes you to go outside of your normal behavior patterns. So hopefully a lot of us are computer scientists in here. So if you're familiar with the hill climbing process, what happens in hill climbing is you'll often start going up a hill and then you get stuck at a local maximum, right? And you can think of boredom for human beings, to vastly oversimplify the situation, as being something like adding a simulated annealing step into your hill climbing process to allow you to get unstuck, right? You're in a place that's pretty good, you're not in any imminent danger or whatever, but you're bored, you start doing different stuff, and it jumps you around this graph to different places, and eventually one of the places you jump may allow you to climb higher, right? So here's the point. Imagine that for some reason, we're playing that stripped-down version of the RPG that has none of the graphics and none of the player stats or anything, right? And in fact, it's so stripped down that looking at this graph, like when you kill a monster, you know, normally in an RPG you get loot and maybe some items and some experience points, which are all different progression things. Those are really just different ways of bumping you slightly along this drama curve toward the end of the game. They just do it in a way such that they camouflage that that's what's happening. Well, let's get rid of all that stuff, right? Just every time you kill a monster, it just disappears without even a sound effect because you know it disappeared. You don't see it anymore. Along this drama curve a little bit, right? So you do all that, and for some reason you found someone who's still playing this game. All the production value to create something that's compelling, right? So it's not just the fact that we've engineered our way around boredom, but we've taken this evolutionary mechanism that was a defense for human beings, right? That was a thing that they used to increase their survival value, to improve their quality of life, and we're redirecting it, right? So instead of improving the things about their own quality of life, they're now improving imaginary things in an imaginary world, right? But they're still exerting, time and effort, right? It's just the effort is going somewhere different now. Now, in the process of going somewhere different, what happens to it? Well, a lot of it just is in this imaginary world, but some of it goes into the game designer's and game publisher's wallet, right, in the form of, whatever, maybe a micropayment, maybe the price of the game, and whatnot, right? So if you think about this objectively, right, engineering your way through a human defense and then profiting by that is a parasitic form of behavior. But, I'm a game designer, right, and I don't necessarily want to think of myself as a parasite. And a lot of game designers, if you were to say this to them, they would say, well, hey, we're not parasites because people genuinely enjoy our games, and they pay us for what we do, voluntarily. But, maybe those ants, the subjects of parasitic mind control at the beginning of the video, maybe they're really enjoying themselves while they hang from that purple flower and get eaten, right? The fact of whether they're enjoying themselves or not is almost immaterial to whether something devious is going on. But taking a measured view toward this, right, and not just trying to flog it for controversy, I do find that, even if you believe this argument that what we're doing is circumventing human defenses, it's not necessarily a bad thing, right? We circumvent human defenses for good purposes all the time, right? So say, for whatever reason, your liver's failing and you need to get a transplant, you go to the doctor, he'll operate on you, and what does he do? Well, he circumvents his way through your pain defense, right, by giving you some anesthetics. He cuts you open with a scalpel. He jiggers around in there, right, and then hopefully you're better at the end of that process, and you give him some money, right? He takes that money and puts it in his wallet. But you can think of a parallel situation, or parallel in many ways, where you're just in a bar and you're trying to get home at night, and there's a mugger there, and at first he gets around your social defenses, maybe just by hiding or by appearing to be unthreatening until you get close. And then he gets through your physical defenses, and he cuts you open with a knife and takes some money of yours and puts it in his wallet, right? They're very similar situations. But the ultimate difference really is whether this process of circumventing the defenses and getting the money in response was of benefit to the person being circumvented or was harmful to the person being circumvented, right? Now you might also, my first thought when I was thinking about this was, well, maybe it doesn't really have to do with benefit and harm. Maybe it's just about whether it's voluntary or not, right? Like you hopefully voluntarily went to the doctor, and you hopefully didn't voluntarily get mugged. But we can do another thought experiment to prove that that's not the case, right? So imagine there's some confidence man. You don't know he's a confidence man. You just meet him out on the street, and he's like, oh, my wife's sick, and I've got to go get on a plane, to go take care of her, but I lost my wallet, and it had my plane ticket and all my credit cards in it. But I need money to go see her right now, and I've got this really nice watch, right? It's a gold watch. Surely at a pawn shop, you could get $200 for it. So why don't you give me $100 right now, and then I can go get on the plane, and you'll make a profit, and everybody's happy. And he's very convincing. He has a great personality, so you believe him. You give him $100, he gives you the watch, and 5 minutes later, you're down the street at the pawn shop. By the way, he's jumped in a cab, and he's gone ostensibly to the airport. And at the pawn shop, you find out the watch is fake, right? And you got ripped off. But you voluntarily entered into that business transaction, right? But it's still a crime, right? It's still fraud. You still did something that was a crime, right? So let's extend this thought experiment. Let's think of another confidence man. He's a little better than the earlier guy, right? And he plays for higher stakes. He works on Wall Street, and he offers to invest your money for 5 years and give you great returns at the end of that 5 years. And you're like, sounds great. I've got this money in the bank. Didn't know what to do with it. Now I know. So you give him $100,000, and he goes, gets in a cab, and goes away. And unbeknownst to you, he gets on a plane and flies to Thailand to live off your money for the rest of his life. But he has an assistant who every month for the 5 years mails you a statement with an imaginary number in it that's getting higher and higher, showing that, yes, your money is creating profit, and you're going to be really happy at the end of these 5 years. And so you're happy over the intervening time. And of course, the 5 years expires, and the guy's nowhere to be seen, and you realize that all your money has been stolen, and then you're very unhappy at the end of that period, right? So now there's a crime, but you didn't know it was a crime for a long time, but it's still pretty bad, right? $100,000, I don't want that stolen. But again, you voluntarily entered into that, and you didn't have a problem with it for a while, right? But it's still a crime. So while I'm still in the midst of this whole foray here, just to remind of the point that I'm trying to make is that I'm saying that, at least in the context of game design, what I want to think about is benefit versus harm, and not voluntary versus involuntary. So the third case, he's maybe the best confidence man of all, right? And he makes a deal with you. You enter into some kind of nebulous business arrangement with him. And there's never anything clearly wrong. He's just so good at taking things from you in a very, very subtle way that you never notice, just little droplets of money at a time, that you never figure out that anything's happened for 5 years, 10 years, 20 years, your whole life, right? You live to be 75, 85, 95, whatever is a good old age when you're old, right? And you die happy. But the fact is that you actually die kind of poor, and you actually could have been much richer if this guy hadn't been stealing money from you for your whole life. But he was so good at it that you never even imagined that anything was wrong. You never imagined that you could have had more money and lived a more healthy, fulfilled life with that money if you know how to spend money properly. So it's not even the realization that you were wrong that makes it a crime, right? There's something about people mistreating people that makes something a crime, or that makes it unethical, or however you want to think about that. So, to start to lead into where that's going, the way I feel about games is there's a sort of a spectrum, right? There are many spectra, but the one I want to talk about has on the left here games that have some kind of core to them that are intrinsically meaningful, like chess. You can strip away all those designer best practices, and chess is still a very compelling, interesting game, right? And then all the way on the right side of the spectrum are games where if you stripped away all that stuff, they're basically completely meaningless. Nobody in their right mind would really want to play them, right? And obviously there are lots of points in between that games can occupy. To pick another example, right, besides chess, we'll go to Go, which is even more minimalistic than chess. It has even simpler rules. It uses absolutely none of the best practices from that toolbox, and yet many people will tell you it's the greatest game ever made, right? So obviously these best practices are not about making an inherently good game, right? They're about something else. They're orthogonal to whether the game is good. They're about convincing people to pay attention to your game and want to play it, and about giving them feelings of compulsion regarding your game, or not, right? And when I put things on the spectrum, I don't even think this is an absolute property of games, that some of them are inherently, that everybody should evaluate these games the same on the spectrum, right? Because part of a game's value to you is whether it brings you a new experience, whether it makes you think about something in a new way. And the first time you play a certain kind of game, it probably does bring you a new experience. So even something like Farmville is probably cool to play for like 5 or 10 minutes, right? But for most people, most of the time, I would say that it lands about as far toward the right side of the spectrum as you can get, although, history keeps marching on, and we'll see what game developers come up with, 10 years from now. So my point with the spectrum is, even though even though everybody's different and everybody has different opinions about what's valuable in a game or what they liked about a game or what's cool about it, it still is possible to generally classify things and generally make judgments about things, not only as an audience, but as a game designer. I can look at a spectrum and say, I really want my work to be over here. I don't want my work to land over here, right? So just because people have different opinions doesn't make that impossible. Now, there's a reason I bring up Farmville, and it's because it's really bugging me lately. A few years ago, I gave a talk about World of Warcraft and how I thought that was pretty much a bad idea. But Farmville is way worse, actually. Not only because it has a bigger audience of more mainstream people, but because of the way it operates, intentionally, the way Farmville is designed to operate is much more dastardly than the way World of Warcraft is designed to operate. And to explain this, I'm going to read a quote from Ian Bogost, who's a professor at Georgia Tech, and he made a game called Cow Clicker, which is a parody of these kind of Farmville games, which we'll look at in a second. But the way he explains it is, many of today's, he starts by talking about traditional
this is really
console
complicated.
games, right? Many of today's console games exert a time crush. They demand tens or even hundreds of hours of attention to complete, some or most of which often feels empty. In that respect, one could argue that many games seem to destroy time. But social games do something even more violent. They also destroy the time we spend away from them through obligation, worry, and dread over missed opportunities. Now, if you haven't played these games, you might not know how they do it. Hopefully, some of you in this room have not played these games. This is Frontierville, which is a new version of Farmville that was launched recently. And just like a dungeon crawler RPG has a lot of different things woven into it to get you to behave in certain ways, so also does this game. And it's insidious in a few different ways. It's got this, it's got that little energy bar up at the top with the lightning bolt. That's how many moves you have, right? And you can spend all those moves probably in 1 or 2 minutes, but it's not enough to really accomplish everything you wanted to do when you sat down to work on your farm. So you've got to wait for the moves to refill, but they don't refill very fast, right? It takes probably, I don't know exactly how long, but it's probably 3 or 4 hours for that bar to fill all the way up, right? So you want to spend those moves before the bar fills up, but the problem is if you go to sleep or you go watch a movie or something like that, you're going to start wasting moves because the bar is going to fill up at 14 here in this picture, and then you just won't get any more turns after that. So it's like you want to check in with Frontierville every 3 hours and spend your moves, because otherwise your farm is just not getting as good as it would get otherwise, right? The other thing it does that's pretty evil is that crops wither in this game, right? So you plant crops. The way it works is you buy a crop for a certain amount of money, you go plant it, you come back later and harvest it, and you get more money. It's a very simple loop. But the crop withers after a certain amount of time if you don't come harvest it, right? So that suddenly makes you very worried to come check in at the game, like, I was going to play tonight, but I'm running late in traffic, so I'm going to whip out my, my iPhone and play Farmville on there so I can get my crops so they don't wither, right? These things are designed to make you worry about the game even when you're not playing the game. So Cow Clicker, which I've got a screenshot here, is... I only realized this today for some reason, but when I was talking about that strip down a game exercise, that's exactly what Cow Clicker is. It takes this genre of games and boils them down to the absolute essential. There's a cow, your cow that's in the middle of the screen, and you can click it. But instead of having a bunch of moves, you get one click. That's all you get, and then a 6-hour timer starts, and 6 hours later you get another click, right? If you buy the in-game currency, which is Mooney, right, then you can spend that to get other clicks faster. Right, so then you can click on your cow. And then if you invite friends into your pasture, you can all earn Mooney, right? So it's got all this, the same, attempted virality that all of these games have. And of course, to amplify that virality, every once in a while, you click the cow and it says, hey, you clicked your cow. Do you want to share the fact that you clicked your cow with your friends? And you do that, and then it goes into your friend feed like that. Hey, I'm clicking a cow. Okay, it's funny, but the reason that it's funny is because that's exactly what these games are, right? So you play Frontierville, and, well, this is an email pestering, but it pesters you to sign up for emails. And then you're in there and like, I'm going to clean up my garden, so I'm going to clobber this fox that's keeping me from doing anything. And then it's like, you clobbered a fox, nice going, do you want to share that with your friends? And it does this all the time. Like if you haven't played this game, in the middle of those 14 moves, you probably get like 3 nag screens like this. Not an exaggeration. So you can barely even do what you're trying to do. So anyway, that alone would be dangerous enough, right? The fact that game designers have now maybe crossed some ethical line where they're explicitly designing games for you to be worried, right? Explicitly designing them to decrease the quality of your life when you're not playing them. That's what they do. Okay, so I didn't finish making my point, which is just that as not good of a game design, I didn't finish making my point, which is just that as not good of a game design as I think World of Warcraft is, it's at least made in some way that's more innocent than that, right? Like the guys who make World of Warcraft like running around killing monsters with swords and stuff, right? And they envision some kind of audience that is like them, who would also like that kind of game. And even though it's a giant endeavor that's, at some point no longer about pure joy when you're toiling to make a game, that's kind of what they're doing. They're making games for people who kind of like the same kind of thing that they do. Okay, I don't want to single out Farmville and Frontierville, but at any of the companies who make these games in a high-stakes kind of way, nobody there thinks this is a good game, right? They're not trying to make games for people to enjoy. They're simply trying to maximize either the amount of money they get in from a user or the amount of virality they get from that user to contact other users, or both. That's all they care about. And that's obvious by looking at the game design, right? If they wanted Frontierville to be more fun, there's a bunch of things they could do. They could give you more moves. They could even move to a system where your number of moves isn't limited, so you can just kind of tend your farm however you want, right? But that would make it less addictive. And their goal isn't enjoyability, it's addictiveness, right? They could nag you less. They could, like this screen pops up right in the middle of whatever you're doing. Like you're going to run over and grab a piece of pie, and it's like, hey, share this with your friends, right? They could stop nagging you while you're in the middle of something and save the window for later. But they know that if they do that, you're like less in the moment and are less likely to respond or to assent to this kind of virality. Okay, so that would be evil enough, right? But we have new technology that makes it even easier, right? In the old days, making video games was like you worked for a while on something and you finish it and then you deliver it to somebody's door and you're like, here's my video game, do you like it? And a lot of the time they'd say no, but hopefully you sell enough of them, right? Now it's not like that because now we have games on the internet, and games on the internet do this thing called A/B split testing to maximize profit. Web guys love this. Who knows what this is in the audience? Okay, small percentage, so I'll explain it. This is basically another kind of hill climbing algorithm, right? Where instead of delivering one product to everybody, you split your audience into, let's say, 2 random samples, right? Completely random. You give half of them version A of the game and half of them version B of the game, right? Just like any scientist running a control in an experiment and then an experimental group. And what kind of things might you change between version A and version B? Well, maybe it's like the background color, right? To see how that affects people's psychology. Maybe it's the style of the main character, to see what kinds of characters people identify with. Maybe it's like, how much gold do I get for punching a fox? And maybe it even varies by region. Maybe like Americans like the game more if you get this much gold for punching a fox, but Europeans like it more if they get this much gold for punching a fox. And actually I just said like it more, but that's not even what they measure. What they measure is how many new players get attached to the system and how much new money they get from you buying, micropayment kind of things, right? That's what they're measuring with this A/B testing. And so what you do is you put out 2 versions, you see which one works better, and you throw the other one away, and then you start again. You put out 2 more versions and 2 more versions, and you keep going down this like infinitely branching tree, and you're constantly optimizing your game all the time. Now, A/B testing by itself is not that new of a thing. If you worked for a candy company in the 80s and you wanted to make a new candy bar, that's kind of an expensive endeavor to like ship that out to everybody in the USA. So what you do is you maybe make 2 versions of the candy bar and you put them in test markets, right? Like one of them is like Burlington, Vermont, and the other one is like, Fresno, California or something, right? And you see how those do in various markets, and then if one of them is successful enough, you like start selling that nationally, you scale it up. That takes a long time to do. Compared to today, when you have web stuff, any company who has the user base the size of one of these very popular games like Farmville or whatever can run a very meaningful A/B test in a day or in 6 hours or even in 1 hour, right? So the iteration time isn't actually bounded by the time it takes to actually run the test now. It's more bounded by like, infrastructure issues at the company, like how quickly can they put the test together to make sure they're not breaking everybody's thing? How quickly can they decide even what they want to test, right? So remember back before that I was saying we used to design games just by doing what we thought was cool. Imagine that's a weapon like a bow and arrow or something. And then we got a little more scientific about it, we decided to watch people in a more empirical and observant way without trying to influence them, right? And imagine that's a weapon like a flintlock rifle. What you've got now on the web is something like this, where it's just firing all the time, right? And that, at some point, the difference between this and this is not just a difference in quantity of projectiles, right? At some point, a quantitative difference becomes qualitative, right? At some point, you can just do totally different things with this new weapon than you could have done with the old weapon, right? And what kind of things can you do? Well, maybe you're not firing actual bullets, but you're doing psychological experimenty things and profiting off them. So there's another interesting thing that I think that's interesting about game design is that game design is kind of a game by itself, right? I've made a bunch of puzzle games, and I found that like looking at a situation and saying, how do I make an interesting puzzle out of this, is itself a really interesting puzzle, right? So there's this huge irony going on that the companies that are making these social games that basically have no gameplay value in them, right, are actually themselves playing a much more interesting game than the game that they're making for you to play, right? The game they're playing is this huge multi-dimensional optimization problem where you're like trying to gather data and make the best decision and all that, and the game they're making for you to play is like clicking on a cow a bunch of times and you get some gold, right? So that's, very, very strangely humorous. And as I visualize that happening, right, somebody at one of these companies, they're doing their A/B testing, they're kind of tweaking something for Europe and tweaking something for America and tweaking something for Canada, and then going over here and like, oh, this A/B test is done, let's look at the graphs of the results and let's write a report on that and stuff. It's a little bit like planting trees and rearranging a garden and like minding livestock and all that, right? So you could say that the people making Farmville are not only playing a game, but they're playing some kind of like Farmville that is way more interesting, right? And so the sad fact of what this all comes to is you've got these people, Farmville has a wide demographic, it's not just computer nerds who play it apparently anymore. So you've got all these people who think that they're playing this cool game, where they mind their cows and their pigs and they're feeling like the boss and they're getting all this gold and they're getting richer and their farm is looking nicer. There's all these ways that they feel like they're progressing, but what's actually happening is that someone is farming them, right? So, there's all these imaginary farms out there where you gain imaginary money, but then there's a real farm with real money that pulls, it pulls money from you over the internet. And you don't ever see it because that's all like behind your head while you're like typing in the computer. So now I put all this up, some of the weapon analogy is a little heavy-handed, but I honestly couldn't come up with anything better in the time available, which was like 1 day. But I actually don't think, like looking at this situation this way, like somebody is farming the players of Farmville, I don't think that this is hyperbole. I don't think it's any kind of distortion of reality. This is what is actually happening in San Jose or wherever their office is now, right now. Are they in San Francisco? All over the Bay Area it's happening. There's tons of these companies. Anyway, so you talk to game designers about anything. I mean, anytime that I question current paradigms in game design, because I go to a lot of game conferences and talk to these people, game designers have a defense, which is just like, look, man, we're just giving people what they want. They want to play our game. They're having fun, right? That is true. I cannot exactly argue with that. People report that they're having fun, and certainly they pay money to play the game. But the fact is that, as we know from other areas of life, right, sometimes people want things that are not good, either not good for them or not good for people around them, right? Sometimes it's not good in a mild way, and sometimes it's not good in an extreme way, like they're ODing on heroin and they're barfing all over the floor all the time, right? So as a game designer, you can make your own decision about whether you care that what they want is not good for them, right? Or about whether you want to exploit their susceptibility device and profit from it. My personal gut feeling is that all this Farmville stuff is just evil. It's not even mildly evil. It's like if you go and look at the discussions that happen day to day at those companies among the designers, they are very evil, right? They are about stuff like, how do we get people thinking about our games all day, every day, right? How do we get them to buy the maximum number of things that have the minimum amount of utility for them in their real life? Because if they get a lot of utility out of it, they get seized, right? It's like, this is totally off the cuff, right? But it's like Coca-Cola, right? Coca-Cola and soft drinks like that get marketed as refreshing, but the ingredients in them actually do not refresh you in any way. They actually make your body a little bit thirstier, right? So that you'll want to drink more. That's how soft drinks work. And Farmville and all those games are like that. Now, people, another thing designers say is like, hey man, it's just games, right? It's just an entertaining pastime, don't get so serious about it. But I have to take this very seriously because quantity matters and video games are becoming very, very popular, right? Going back to drinks, if you drink some alcohol once in a while, it's cool, it's totally fine. It's a nice beverage that gets you a little tipsy. If you get stinking drunk like 4 or 5 days a week, then you're going to be seeing that doctor that we talked about earlier because your liver is going to be dead, right? Everybody knows that, right? That's not controversial. Quantity matters in that case, right? In a similar way, if one person wastes a little bit of time, with some stupid game that doesn't do anything for them, that's no big deal, right? But when you have a nation of people who spend a large amount of time on something that's not just a waste of time, but that actively kind of makes them a little dumber, poorer, sheep-like, and infantilized, that becomes a much more serious issue. And as huge and popular as video games are right now, they're only going to get more popular, right? I don't see them declining anytime soon. And so I think as game designers, we have a responsibility, and I'm speaking of me and my friends and anyone in the audience who thinks they might be a game designer someday, we have a responsibility proportional to the number of people that we will affect with our products, right? And I want to talk about something closely related, because I feel like people are a little bit deadened to this kind of issue, because we face it in simpler and more obvious to see ways all the time, like psychological manipulation, right? You go out to buy things and like everything is priced in something that ends in 99 cents or 95 cents, right? Why is that? It's because if you sell something for $9.99, you make way more money than if you sell it for $10 because more people will buy it, because obviously $9.99 is a lot cheaper than $10, right? Well, no, I mean, obviously it's not. As thinking, intelligent, rational creatures, right, we know this is stupid. This is kind of insulting because I know what $10 is, right? And I know what $9.99 is. There's just not really a difference. But despite the fact that we believe that on an intellectual level, this gets to us at a lower level, right? It affects at least enough people to make this the only real strategy for selling something, right? But beyond that, it affects people who think that they're immune to it. Like, oh, I'm a smart guy. Advertising doesn't work on me, and like everybody thinks that kind of thing. But it's not true, right? So another example from the field of video games, Microsoft points, which you buy things with on the Xbox 360, are intentionally, they're engineered so that the conversion ratio between Microsoft points and US dollars is like, is it $800 to $10? Yeah, that's what it is. It's something that doesn't evenly divide, so that you can't easily do the math in your head about how much something really costs, right? If you're really used to the system, you might know that an 800-point game costs $10, but something like 1,200, it takes you a little longer to think about how much that is, so you don't really think about it as much, or at least that's the hope, right? This is intentional. $9.99 is intentional, and the problem is that we walk around every day with these like insults in our face, right? $9.99 says, I'm going to manipulate you at the level of human responses that you don't have control over. I'm not going to treat you as an intelligent human being because I know I'll make more money off you that way, right? That's what these things are. Now, of course, if you want to buy my last game, Braid, you can buy it for $9.99 on Steam or 800 Microsoft points. I am at least a counter or I'm at least complicit in this, right? I don't exactly have control over setting pricing on any of these channels, but by participating in that, I support it, right? And there's this thing where as a game designer, you just have to pick your battles. You can't fight every fight all the time. So the best I could do with something like Braid is to try and make a wall, right, and insulate it so that outside the game, all this kind of horrible stuff happens. And inside the game is kind of a garden where I respect the player and I treat them as an intelligent person who I would like to know and talk to. And unfortunately, I wasn't even able to do that because of achievements, but I cut that from the talk. So if you want me to rant about achievements, ask me a question later. But, you know, I wanted to bring this thing up, and the fact that I engaged in it to make a very clear point that my goal in this talk isn't to convince you, you know, not to treat people like machines or resources, and that Farmville's evil because it farms people, because it treats them like resources. That's not exactly it. Because we're biological creatures, and certainly, like all of biology, all of the history of evolution has been about creatures treating other creatures as resources, right? That's what biologists learn when they come to college, if they didn't know it already. You know, when you have some hamburger for dinner, you're treating a cow as a resource. And people dealing with people is often not any different, though hopefully not food-wise. I know. So, you know, my goal among all this, you know, storm of conflicting ideas is to try to respect the player and avoid manipulating them, right? Because manipulation is not a sign of respect. It's like, I'm going to, you know, not only am I going to treat you like a resource, but I'm going to do it in such a way that I don't really care that you're mistreated, and I'm going to profit off it. The problem that I have is that these good game design things that I talked about, the best practices at the beginning of this talk, are all, to one degree or another, in either subtle ways or obvious ways, manipulative tactics. And that's why abstract games like chess or Go don't have them, because there's like nobody there. There's not enough content in those games to actively manipulate you. But video game designers actively manipulate their players all the time. And I have a problem with this because I don't want to manipulate my players, right? But if I'm going to be a competent game designer, right, if I'm going to make games that people want to play that are video games, right, then they probably have to incorporate some of these items. So just like pricing something at $9.99, if I want to like actually have enough money to make my next game, I probably have to use at least some of these practices if I'm going to make a game that enough people want to play, that I can make, that I'm allowed to make my next game. And so trying to design a good game according to good game design practices today, while respecting the player, is a very difficult thing to do, that you have to be kind of a contortionist to try to like squeeze through all the gaps. And, you know, I kind of think you almost can't completely successfully do it. You know, your contortionist is going to like at least crush his finger on the way through there. Now, this is enough of a problem, but there's kind of a meta problem, which is I feel like both people who enjoy video games and game designers, but I've been talking about game designers the whole time, so I'll switch now to people who enjoy video games, don't like it when people bring up this kind of suggestion, right, and talk about it. And the reason is because they identify with video games. They really enjoy video games. Never mind that video games were designed so that they would really enjoy them, right? They really enjoy video games. And when you suggest that this thing that they so closely identify with may have negative aspects to it, they don't want to think about it, right? It's a self-defense mechanism that's common to all of humanity. It's common to lots of subjects and not just video games, right? But people go into defense mode. What interests me is that, again, going back to the subject of interventions in human psychology, right? This kind of defense mode, if you value critical thinking and value understanding the truth, you can learn to recognize it in yourself and learn to circumvent it, right? And be a little more rational about your opinions and about what you think about things like this, and try to see things more objectively. Whether you can succeed or not is more difficult. But again, it's a case of circumventing human psychology in order to do something beneficial. So anyway, if you remember that spectrum that I put up before, I'm not going to flip back to it. There's some line on that spectrum I mean, it's a projection into 1D of all these games, so it's inherently going to be messy and a little bit inaccurate. But there's some line that divides games that are beneficial from games that are harmful. And it's not really my business to draw that line today. I don't want to try and convince you exactly what's beneficial and what's harmful, because again, that is up to the opinion of every designer and in fact the opinion of every player. But what I would like is for people to have an opinion about it, right? When people design a game, to think about what that game is doing, and when people play a game, to think about what that game is doing. And people don't right now. They think about how it has cool graphics and like a lot of levels, and like they love the story about killing the bad guy, which is not a very it's not a very self-aware place to be standing when you're consuming something that affects your life for so many hours and therefore affects your mind for so many hours. And that bothers me. And that makes me feel bad about being a game designer and programmer in those game designs. But what I have to do as somebody who makes games is decide for myself then how do I know what's beneficial and what's malicious, so I can make my own personal decision about where on the spectrum I want to land and what games I make. And even that, not trying to prescribe globally, but just locally for myself, even that is a very, very difficult problem. But I can tell you how I try to solve it. The first thing that I do, at least for the past few games, is I always try to be in a mindset where I'm respecting the player, right? I think of the player as a very intelligent person, or a person with a rich life whose time that I want to make the game worthy of. I don't want to waste their time. I don't want to degrade their quality of life outside or inside the game, right? But while doing those things, keeping in mind that the idea of respecting the player is itself a very tricky and thorny concept full of contradictions, and that would be a whole separate lecture. But I'll just say that if you really think you understand what it means to respect somebody while you're making something for them to consume that you profit from, you probably haven't looked closely enough and don't really understand. But despite the fact that I don't really understand it yet, I'm always trying to understand it more and trying to use that notion of respect to guide my design decisions. Right? And one thing that this results in, which is surprising to many people when I tell them about it, actually no. I'll save that for the next paragraph. But one more natural result of this direct respect for the player is that I try to minimize the use of these manipulative tactics of what is considered good game design. So this is, again, a paradox. Like, as I'm trying to be a good game designer, I try to minimize the number of traditionally acknowledged good game design tools that I use because they're all manipulative. And when I do use them, which is almost unavoidable, I try to have a very light hand in using them the minimum amount possible. That's not even true. Minimum is not the right word, as you'll see in a moment. But the results of all this, and this is the thing that people get surprised when they hear, is that when I sit down to make a video game, I'm actually not trying to make a game that's the most fun or like the best game, or certainly not the game that'll make the most money, right? Which most people think like, oh, that's what a game designer does. He's like someone trying to make the most fun game. But I realized, and I would have said, 2 years ago, I'm trying to make the most interesting game. But I realize now, again, that that's not even exactly true. Because I'm not trying to optimize the player's experience anymore. Because in order to optimize, you need to treat the player in this kind of scientific way, where you're using them as an experiment or as an instrument that you're measuring constantly, right? And that leads to disrespect almost automatically. So instead of trying to make the most fun game, there's some other things that you can try to do that are, to my mind, loftier goals, right? You can decide to make an intensely personal game, right? This is a game that is about me and what I feel, and hopefully somebody will connect with that, right? You can decide to make a game on a subject, like an intellectual subject, that interests me very much right now. It's not really trying to be that emotional, but it's like cool how like the Russian space program did all these things. Or I could be making like the game that'll impact players' lives in the way that I want, while still making a reasonable amount of money. This is like a more pragmatist view of what kinds of games to make. These are all totally respectable goals, totally reasonable goals that can be done from a mindset of respecting the player. Now, I want to come at this in a different way because I think that there's a certain viewpoint that we have in modern Western society that makes it a little hard for us to think about this kind of thing in a totally like open and heartfelt way. And that's science, right? You guys are at a modern university. We're all members of a Western society that has benefited tremendously from science, right? And what science has shown us through the development of technology and reason and all these things is it shows us the value of being serious about the objective world. Let's skip slides. Right? Science is about measuring empirical things. It's not about your opinion. So what you do in science is you kind of take the world apart and you understand how it works. And you don't necessarily believe explanations that are given to you by human authority figures or things that would make you comfortable. You do the measurements, and then you try to explain the measurements, right? And then you try to figure out what's going to happen in the future, and then you test it. And because of all this benefit of science, right, that's why I was able to fly here today to give you guys a talk on a computer. It's probably why some of you are even alive today rather than dying in childbirth, right? Or young, from some disease. But it feels like in the Western world today, because we've gotten so much benefit from science, we've kind of like are a little bit overdosed on the objective view of the universe. And what I do as a game designer is actually look sort of at a subjective view of the universe and value that, right? And what I'm here just to baldly assert today, because I'm almost at the end of the talk, is that the subjective viewpoint of experience is also valid, just like the objective one, right? It's also true. And by subjectivity, again, just like speaking to the human condition, I'm going to leave that a little bit vague and not exactly define it, but it's something like your consciousness as an aware individual human being, right? That has some kind of essence that's worth paying attention to and worth considering important, right? And this is obvious because it's what makes all of us feel like there's a point to being alive at all, right? And it's obvious to game designers who want to make something fun because what's the point of a non-sentient, unaware group of atoms having fun? Like, that phrase doesn't make sense to us. Unless we get into this really technical mode, and then we're not even really thinking about each other as human beings anymore, right? So, as a game designer, what I do is value the subjective. It's sort of become the area that I like to explore, and I feel like there's a lot of value that the game design community, that the field of games can bring to human understanding of subjective consciousness. It's one thing that games do better than anything else because games are interactive, right? So this game that I made, was an interesting puzzle game, but you don't actually do that much in it. There's not that many objects that you manipulate or whatever. The interesting parts of this game, the little discoveries and aha moments that you have, all happen inside the player's head. Also the frustrating parts, but that's part of the game, man. The new game that I'm working on is about epiphany, right? It's about something's right in front of you and you didn't see it and now you see it, right? Or you didn't understand something, but you failed to understand it not because it was too complicated, but because it was too simple. And now you understand it and everything seems different, right? And that's purely a subjective experience. You can't, there are people who do, never mind, I won't even go off on that tangent. Now, again, I'm not here to be a hippie, right, and say that science mechanizes people and you should I'll have a group hug or something. Because both things are true, right? As a game designer, I have to constantly deal with the fact that the people I am making this game for are products of evolution. And if I want to be successful in designing games, I have to manipulate them as a little bit as products of evolution because that is what they want me to do. That is what they enjoy, right? At the same time, I have to realize that leads into a very slippery slope that very quickly leads to treating people like a science experiment or like a resource. And then you're in a whole different business than what I want to be in, right? Then you're in the farm bill business. To be competent, a competent game designer in terms of skills and a respectable game designer from my point of view in terms of what I'm doing in the world, I have to keep both of those sides of that axis in mind at all times. And that's why I said I don't try to make the most fun game, right, or the most money or anything, because that's about maximizing, right? Maximizing is about hill climbing. It's about a scientific process. And as soon as we focus all of our attention on the objective aspects of a scientific process, we're focusing our attention away from the subjective stuff that's over here, and it's not healthy for game design. And so the last thing that players tend to say whenever I get all serious like this is something like this. They say, well, hey, the lecture's over an hour, they get sleepy, they're not really listening anymore, and they're just like, they don't want to believe what I say because it's potentially negative. Now, it's healthy for game design. And they're just like, they don't want to believe what I say because it's potentially negative for games, and so they go just like, hey man, games should just be fun, what's the big deal? I'm having fun with games. And I'm not going to answer that. Well, yes I am. I'll start answering it by saying fun is a confusing word. It's again a very vague word, but we can say something about it to go one step beyond this argument or this assertion, which is just that, earlier in the talk I described, boredom as having an evolutionary purpose and frustration having an evolutionary purpose. Well, fun probably also has an evolutionary purpose, right? And so what is that purpose, right? And is the fun you're having with a particular game fulfilling that purpose, or is it not? And if it's not fulfilling that purpose, what does that mean in terms of the fitness function in evolution, or whatever you want to think about, right? And the second thing to ask is, you say you're having fun, but is it really fun? I used to play a lot of Counter-Strike. I used to be ranked in Counter-Strike and in a very serious clan and stuff, and I really would play that game a whole lot. It was a very interesting game. I'm glad I spent a lot of time playing it. It absolutely was not fun. Very serious, very hardcore game. But most people will report, if you ask them if it's a fun game, oh yeah, Counter-Strike's really fun. But look up some synonyms for fun, and you find words like joyous, or, I don't know, things like that. When you're playing one of these hardcore first-person shooters, ask yourself a different synonym of fun. Is this a joyous experience that I'm having, right? You'll find very quickly that it isn't. And so what we see is that the word fun is being used as a linguistic catch-all for a number of other different things that are very complicated, right? And so starting to introspect into that, into what exactly is this fun that I'm having, what's the nature of it, and how does it affect my life, is sort of the road to understanding these things better. And the rest of the answer to this is what I'm not going to answer. I'm going to let Alan Moore answer it. This is from a documentary called The Mindscape of Alan Moore. And he says, writers and people who had command of words were respected and feared as people who manipulated magic. In latter times, I think that artists and writers have allowed themselves to be sold down the river. They have accepted the prevailing belief that art and writing are merely forms of entertainment. They're not seen as transformative forces that can change a human being, that can change society. They're seen as simple entertainment, things with which we can fill 20 minutes, half an hour, while we're waiting to die. It is not the job of artists to give the audience what the audience wants. If the audience knew what they needed, then they wouldn't be the audience, they would be the artists. It is the job of the artists to give the audience what they need. Thanks for your time, thank you for listening, and I will take questions if anyone wants to say after.
Okay, so we have microphones. If you'd like to ask a question, make sure you wave your hands vigorously in the air and we'll get a microphone to you.
There's a guy up there waving his hands.
Okay, well, sorry for preempting you, guy up there. But you mentioned that you felt compelled to engage in these manipulative practices in order to be successful. And
compelled is not the right word, but yeah. It's something I'd better pay attention to be a competent game designer in the modern age. Now that we're not making 80s style games anymore.
Right.
Yeah.
And I'm wondering, if I view that in terms of art, I can hear similar things from artists I know saying that they have to work to make their art accessible. And if you view this in terms of products that you're designing for people, maybe this is affordability and ease of use. And where is the line between making something accessible and affordable and easy to use, and making something that is manipulative, which is perhaps similar but different?
No, it is absolutely a little bit similar, but it's something that you kind of have to answer for yourself while you're making something, I think. I'm not going to say to anybody, here's the line where this is manipulative, but this is merely helpful, right? That's part of what having a strong opinion about what you're making is, right? And that's part of where the work comes from when you're doing it. I definitely, when I'm making something, have strong feelings about whether something is too far in that direction. And I absolutely cut things back. There's sort of a tutorial in Braid, but it's wordless, and you walk in and it just puts icons to the buttons on the screen. And that assumes a certain level of video game literacy, right, if you're playing the game. But I was okay with that, because it's a video game literate kind of game. And I didn't want to handhold people. First of all, because it would spoil the mood. Excessive handholding is not really what the game is about. But also because of that respect thing, because Braid was about, so there's two things that are active, right? There's my opinion as a designer, and then there's what the game is about. And both of those agreed on the same decision. Because Braid is about discovering stuff. It's about the game sitting back, and you have to figure it out, and you have to come to the conclusions. It's not going to tell you. So an overbearing tutorial actually would not fit that to me. But I think that even something like an overly, a lot of Japanese games have tutorials, modern Japanese games have tutorials that are very, very hand-holding. You have to click through tons and tons of text, and I don't feel respected by those at all. I feel like they think I'm 6 years old, and I would never make that kind of thing. But there's a middle ground that's totally reasonable.
So you mentioned earlier that we humans have evolved, and I think the game designers have evolved, as you pointed out, to adapt to what generates more money. So if you follow this line of thought, the logical conclusion is that people like you will be dying species because you would not be making enough money, so people would not be adopting your style. So that concerns me because that means in the future we will be getting more and more games like Farmville, Mafia.
No, I don't actually think that's exactly the conclusion. I mean, I agree to you that that's a concern.
People would not be adopting your style. So that concerns me because that means in the future we will be getting more and more games like Farmville and Mafia.
No, I don't actually think that's exactly the conclusion. I mean, I agree to you that that's a concern. But to go back to evolution, I don't want to beat the evolution thing into the ground because it's not meant as a precise metaphor here, and you can use evolution to explain anything you want, including things that are clearly wrong, right? But in ecosystems, things find niches that are quite profitable for them. They're able to live nice lives and whatever, and they're not dominating the ecosystem, but they don't have to, right? I already don't dominate the ecosystem, right? A game made by Electronic Arts that's very successful will sell probably 20 times what a game that I make will sell. But I don't need to be Electronic Arts because they have this giant, elephant body, and I have a tiny ant body, right? So I think it's okay. It's okay to not try to maximize because you don't need everybody to buy your game. You don't need some nebulous demographic the size of the United States or of the world to all like what you make. You only need a small number of people to like what you make very much, enough that they'll go out of their way to hear about it and get it and play it. And that's how it worked for my last game, and I hope that continues to be viable in the future. Certainly the internet makes that much more viable now than it was any time in the past, because in the past distribution was tightly controlled through retail stores, and it was very hard to get into a retail store. Now that's not true. So if you have people who are interested enough in what you're doing, they can get what you're doing. They can get your thing, your product. Who's first?
I have it right here.
Yeah.
What you talked about a lot was single-player challenge games. I'm right here. Where you're playing against a machine or people that you don't see. Where do you see social games fitting into your perspective or your one-dimensional line?
Okay, so I don't exactly like the name social game because the games that are social, like on Facebook and stuff right now, are not actually very social. You don't interact with people, right? It's a very passive thing. So I'm assuming that you mean not games that have social elements, but that exact genre of game.
I'm talking about games like the Wii structured games where they're trying to get people together and use.
So like same room multiplayer kind of thing.
Yeah.
And what do I think about that?
Well, because they're not necessarily, they're used more as a social tool to get people together and do things. So it seems like it's a different direction than single-player challenge games.
Sure, it definitely is. The games that I talked about today, a lot of them are single player, but I would more say that they tend to be games with a very heavy design hand. And one reason that there's a lot of single player stuff there is because single player games have a lot of content, because that's what you do is you chew through the content. And something like Wii Sports, you're like playing tennis a bunch of times or whatever, and it's not the same content heavy experience. And so the designers don't necessarily do this big giant infrastructure of manipulative work in those games. That said, I find Nintendo's aesthetic for that kind of game kind of schmaltzy, and it is a little bit manipulative and insulting, I think. But not nearly in the same way as like something like, Farmville. Totally different magnitude of thing. But as for those games, yeah, it's a totally cool direction to go in game design. There's lots of different ways to go, and I certainly can't talk about them all.
I have two questions about Braid.
Sure.
Well, the game starts with a background of a village burning down. So what's going on?
I think that if you are playing the game and you're standing there and you're watching that opening screen, then you see exactly what's going on in the opening screen.
Well, I finished the game.
Yeah.
Already.
So you know.
And also,
I'm not even trying to not spoil it. I'm just saying that that's like the reason. Okay, the reason that I make video games, like I used to when I was early in college. I wrote a little bit of science fiction and got some stuff published. It's under a pseudonym, so you can't look it up. Did I know you back then when I was writing that stuff? You probably didn't see it.
I never saw it.
Yeah. The reason that I make games is because at some point I found myself wanting to get at ideas that are pretty grand and they don't lend themselves very well to linguistic explanations. Because language is very serializing, right? And if you want to get at something that's extremely multidimensional and extremely nebulous and yet extremely important to people, if you're doing it through this process where you have to unserialize all this language and then somehow rebuild it into this thing, it's a very difficult and error-prone process. It doesn't exactly work. Video games, like film, for example, is different because it gives you this higher bandwidth experience, and you can do stuff visually in ways that you can't exactly do in other media. And video games have, because they have interactivity, they allow you to explore a space. And because they allow you to explore the space, because they allow a player to explore the space, they allow the designer to communicate the shape of that space more implicitly than you can with language, because it is found as opposed to told. And that's important. That's part of why the medium is respectable as its own thing, and it's not just like film with interactivity or whatever, right? So when I do something like that opening scene, that first level in Braid, if you load up the level editor and you see how many objects are there, it's way more complicated than any other level in the game, and it's just to do these certain effects and have the camera pan in a certain way and all this stuff. And it's because we cared a lot about what was happening there, but as far as I'm concerned, the entirety of the communication of what is happening there is contained in the game, and that's all that needs to happen. And that's why I make video games. So that's why I don't want to tell you. What was the other question? I don't know. Okay. Too many questions.
Something that's becoming more prevalent with online distribution is downloadable content. Do you feel that it's just another way for companies to make more money by offering additional content to players, or is it a way for companies who weren't quite able to get the content created during development, a way to get extra stuff out there for the players to enjoy?
It's not B, and the reason why is because it takes a long time to download or to develop and debug downloadable content, and studies have shown that the optimum window to release your DLC, there's been a few studies and they conflict a little bit, but they all have the same general conclusion, which is that the optimal time to release your DLC is right when the game releases, because that's when the most people are paying attention to your game. Games are a very hit-driven thing, where it's like movies, where everybody wants to go see the new movie, and then they're not interested. Even if it's a good movie, they probably won't watch it if it's 5 years old. Right? So you kind of have to develop the DLC for the most part while you're developing the game, if you want to hit that. And some studies say, well, there's like a 3-month window or something. You know, whatever it is, it's very close to the release of the game. And for games that take years, like a couple of months doesn't matter. What it is, it's also not necessarily to make money, because the fact is that the cost of a DLC, like the price of a DLC, times the number of units that you will sell, is how many people buy the DLC? Well, it's certainly a subset of the people who bought the game. Divide by what? 5, 10, 20, right? So you're talking about a small amount of money. Now, for big hits, it makes sense, right? For big hits that have a lot of mind share, and especially if they're open world kind of games, you might have a higher percentage of people buying the DLC, right? And for a longer lifespan. And so, and because it's just such a huge revenue number, that a small percentage of that is still a large number and you want to do it. But the real reason, to get to the end of this long-winded explanation, is that DLC is about prolonging your interest in the game so that you don't sell it to GameStop as a used game. That's basically the main thing. Because game publishers really, they don't make any money when that happens, and they're upset about that. And they're like, how do we get people to either not want a used game or not sell their game back as used? And this is one of the many ways that they do that. I need to start giving shorter answers because there are a lot of questions. So I'm going to go broader instead of deep on these.
These 4, and then that's it.
Yeah, after that I can answer questions like privately and stuff. Or, you know, feel free to walk out and all that. Who's up next? Yeah.
I was just curious. I watched the video of Soulja Boy playing Braid. I was wondering, as someone who tries to involve gamers on a deeper level, how do you deal with people who simply view Braid as a form of entertainment and only look to the eye candy and, I guess, the classic elements of a good game?
Sure. Well, you know, there's always going to be those people, and you can't control that. So you don't, I mean, if you make something and somebody doesn't like it, right, you can't really get mad at them. I mean, that might be your instinctual reaction. Or if they don't understand my brilliant thing, right? That's just going to happen. That's just the world. And so you kind of just have to focus in the other way and say, this game is for the people who are really going to find it interesting and enjoy it and like it. And hopefully I find enough of those people. And so you just do like a positive, negative space thing and you look at the other space. Because, yeah, there's a lot of people out there who won't respect your work or pay attention to it or whatever.
Okay. First, really quickly, I thought you might be pleased to know that I came to this talk neither as an ambitious game designer nor as a passionate gamer, but closer to an ex-addict back from when A Link to the Past was the latest Zelda game. But I wanted to know, with the Alan Moore quote right at the end, it kind of brought this conflict that you were talking about outside of just gaming into at least literature and who knows what else. And I was curious, are you familiar with the work of David Foster Wallace at all?
I have only read a little bit of his stuff, but I do plan to read more, actually.
Okay.
Yeah.
Because I know tons about him, like unreasonable amounts, borderline obsessed. But I was noticing a few parallels with what you were talking about, and as you were developing the lecture, it seemed to get to be an almost eerie parallel, how you guys were exploring a lot of the same conflicts in totally different contexts. Even where you were kind of dissatisfied with exploring grand ideas in language because it's inherently linear, he kind of felt frustrated by the linear nature of novels and how it didn't really reflect the way he felt like he had to construct reality from thousands of discrete data he received every day to the nature of boredom and does it have value, and how a lot of postmodern tricks in literature really serve to either entertain the reader without doing a whole lot or serve the darker purpose of telling the reader, look how smart an author I am. And a whole ton of other things.
Yeah, I mean, I'm not surprised. I mean, certainly, because he was a writer, he was trying to do pretty different things. But there is always that, like, I feel like if you're good at the medium you're working in, you see its limitations, right? I see a lot of limitations of game design, and we're still figuring out what those are, obviously, but at least I feel like it's early in the game. Like, games are going to evolve a lot more, right? So I can't get frustrated with the limitations of game design yet, because maybe we just haven't figured out how to do certain things. So, but yeah, I mean, I actually know a guy who was a friend of David Foster Wallace's, and he's told me some stories, and he sounds like a guy I would respect a lot, and that's why I want to read more of his stuff.
So, on the part when you mentioned the video game as a form of, as a medium of communication, like there's this equivalent genre, like the whole movie industry, and my question is like, when the movies like Avatar or like Inceptions were released, there's just so many people talking about it. Just people just like have like their opinions and like their academic, like some sort of analysis and stuff. But when they they think the games with similar capitals like spent, like when they were released, is like they're like barely discussed. I mean, so my question is like, what do you think about the cultural reception or the cultural significance that video games are holding right now, and what it can hold in the future?
Yeah. I'm going to answer this one not in too much depth, and the reason for that is because people talk about it all the time, not just me. And you can find answers on the internet, but the short answer is that for genres like film and books and music and all that, there are pre-existing examples of, and this isn't the only answer to your question, but this is the one that works best for me as a model. There are pre-existing examples of things that were really important books, or really important films, or films that were really meaningful to people. So you can have films that are obviously just entertainment films, which almost every film made, certainly from Hollywood, is just an entertainment film. It's not trying to be deep or important, right? And yet, because you have those examples, the medium of film or the medium of novel still has cultural validity, right? Even though, even the fact that the Da Vinci Code got published and was massively popular doesn't besmirch the potential for novels to be deep and meaningful, right? And people understand that, and that's why people pay attention to that stuff, right? The other part is also, okay, and it's just that video games don't have that yet. Will we ever have it? I don't know. Game designers kind of have to step up their game, right, and make things that are more meaningful to people before they will get cultural acceptance. Because if the most we can ever do is like, I'm bloodily running around and killing creatures with knives and stuff, if that's our deepest thing, we shouldn't have cultural legitimacy. Like, we just shouldn't. It's not that interesting. So, yeah. And then there's also the nerd factor, right? I mean, even regardless of who it is, right? You could have the, really, great-looking, public speaker. I don't know, like an infomercial kind of guy who, I guess those guys don't look that good. One or two of them do. Like some guy who's like your socially stereotypical, good-looking guy, right? And you sit him down in front of Fallout 3 or something, and it becomes a very creepy scene, even though he's like a model. Like, it becomes this thing where he's going into the kind of doesn't have, I don't know what I'm trying to say. It's something about how what it looks like for somebody to play a video game is so uninviting and so a little bit creepy because you disappear into that people are icked out by it. And it doesn't, to some sense, so when I say nerd factor, I don't just mean nerdly guys, which is why I was going for the socially good-looking guy. It's the act of playing video games is a little bit socially hostile most of the time. Now, if we start making games that are less socially hostile, like Wii games and other stuff, that'll change. But as long as we're talking about 60-hour single-player epics, that is also going to be unappealing to everybody who doesn't play video games, right?
Yeah. So I think more than almost any other medium, video games kind of suffer from the sequelitis disease. In fact, before I came to this speech, I checked GameSpot real quick, and the top 10 most popular games, 8 of them are sequels. And I think there's kind of like this pattern you see where, X developer that's, has made very few games before will come up with something,
new, interesting, deep. Probably the prime example of the last 4 or 5 years or so is probably BioShock. But then eventually gets picked up and turned into a franchise, in fact.
Well, I mean, BioShock is a sequel, right? It's basically System Shock
BioShock
3,
was System Shock 3, but
they didn't have the trademark or whatever, right? So it's BioShock. So
Yeah.
that's not even that great, but it did make a creative break with the earlier thing.
Yeah,
It became its own thing.
I was speaking more from the...
Yeah.
But anyway, I think I even forgot his name, but an EA executive was quoted saying, "We don't make games, we develop franchises."
Sure.
And I just want to know what you think, like, is there a position for the blockbuster art game in the industry as it is without it becoming, this evil we're trying to fight up with, just manipulative,
Well, I mean,
hollow
what do you mean by
production?
blockbuster? Like my game, so, Braid, my last game, sold very well. It didn't sell as much as an EA game, but it sold so well that I don't, I'm covered for the duration of working on this game. I don't have to make money, right?
I guess what I'm trying to say is, like, a game with the same motivation of, like, conveying a specific, like, thought or idea or being, beneficial to the player as opposed to being harmful or manipulative, but still having the backing of a large studio.
I think that, predicting the future is a very dicey proposition, right? Almost never is it done accurately, but my gut instinct is not anytime soon is the answer to that. And if you just look at something like films or like popular books or whatever, the most popular things are generally not the deeper things, right? For something to become respected and to be widely spread as a deep thing, as like a great novel, it doesn't happen right after it comes out. It's like it kind of gestates for a while, and then people realize, oh yeah, that was a great novel 50 years ago or 100 years ago or whatever. Certainly with film, most films that are made are kind of vacuous, and in fact, Hollywood films that have high budgets are very heavily manipulative, right? The scoring, the way the shots are set up, and all that, it's emotion jerking a lot of the time. It varies by director. It varies by the whole cast or crew, really. But because that is the case, right? Just because popular things are kind of bad usually doesn't mean that once in a while you can't have a very good thing that everybody likes, right? I'm not going to try and pick an example right now because you can get into arguments over whether that thing is really good, but it happens once in a while. And even when it doesn't happen, the fact that those things exist, they're just really good for society, right? I mean, if 1% of, I don't know, like 1% of the people in America is a huge number, right? 0.1% of the people in America play your game. That's 300,000 people. That's huge. That's a lot of people that you can influence, and you don't need to be mass market to have influence, I guess, and to be meaningful to a very large number of people, right? That's the weird thing about video games right now, is even though there's these giant blockbusters with like 200-person teams, an individual person or a team of 2 or 3 people can make a game that 600,000 to 1 million people will buy. That's like a huge fan out. That's a huge multiplier on your ability to affect the world. So I think that focusing on trying to get everybody to buy the game is maybe a little bit of a false prize, because the small amount of good you can do with a moderate number of people buying the game is tremendous. It's in the modern internet age. Are we done?
All right, I thank you all very much for coming. Thank you, John, for a great talk.
Thank you, everybody, for listening.
This program is protected by a copyright and may not be redistributed in whole or in part without the express written consent of Rice Digital Media Services.
Hey, so I like to know who I'm talking to, so let me figure that out. who out here plays video games? Go ahead and raise your hand. Pretty much everybody. Who out here makes video games in some capacity? All right, less than half, but significant number of people. Who makes traditional video games, i.e. not social or casual games? All right, and who makes sort of some of the newer social, casual, Facebook, iOS kind of games? All right, so really a minority. Good. So not too many people are going to want to lynch me by the end of this talk, but there still may be a couple. Let me go to my presentation. So, I've been a video game designer for a while now. I work in that field. It's my field of expertise. And that's why I wanted to kick off this talk, obviously, by talking about a subject like television. And not just television, but a specific subgenre of television, the hour-long drama. And I have drama in sarcasm quotes for a pretty good reason, as we will see. And I don't even just want to talk about television shows like this one, which I enjoyed tremendously, or this one, which received tremendous critical acclaim, or even this one, which is enthralling a lot of people right now. But also I want to turn the clock back to sometime like the 70s or the 80s when the things on TV were not like those. Instead, they were shows like this one, or this one, or this fabulous gem of a show that we just saw before the talk. And it's important to understand, okay, who out here is old enough that maybe you're approximately my age and saw this on TV when it came out? Not that many people, but some of you are going to know where I'm coming from. I was not scraping the bottom of the barrel to come up with this clip. Okay, this was a big, big TV show. The $6 Million Man in the mid-70s was a top 10 Nielsen-rated show multiple years in a row. This is what Americans watched on television. And this particular clip was from a two-part episode called The Secret of Bigfoot. I guess the secret of Bigfoot is that he's a robot controlled by the Lemurians or something, but this was a huge, big promoted event. It was like, it was must-see TV of the time. But you see the quality level, right? I mean, but what's interesting to understand now, I mean, to look back with our modern perspective, and to realize people watched that non-ironically, right? In the 70s, they would go home and they would turn on a show because they want to watch TV, and that's what would be on. And then you'd go to school the next day or go to work the next day and talk to your friends about how cool Bigfoot was, right, on that show. And something changed, right? These shows on the top are markedly different from these shows on the bottom, certainly in quality level, but also in terms of structure. It's not an accident that we have better TV today than we had in the 70s and 80s, because there was a structural change. Now, the making of TV shows is a complex and sprawling endeavor, and there's no way that I can do it justice, so I'm going to tremendously oversimplify and not look at most of it, but I'm just going to talk about two major structural things that affected those shows back then. And help make them what they were, right? One of them was the need to have commercial breaks all through a show, and the other one was the need for syndication. And what these did is change the basic content of the show, right? If you're making a show like The $6 Million Man, and you know there's going to be commercial breaks, you can't just sort of pretend like you're making a 44-minute movie and then cut it up at the right points, because at the very least, where those commercials land is going to be disruptive to the flow of your narrative, right? But actually, it's much worse than that, because people didn't come to watch commercials, they came to watch your show. And there's lots of other stuff on TV, and anytime a commercial comes up, there's a strong incentive for someone to flip the channel. So what this means is that you start designing your narrative, and editing the show and all kinds of things to try and keep people there through the commercials. Like, that's when it becomes one of your main priorities as a creator of one of these shows. So you might do things like, well, how do we make people maximally interested right before the commercial and and make them really care about what's going to happen so that they stick through it, or at least come back if they flip to another channel for a few seconds. Well, we'll put a cliffhanger like right before the commercial break, so you don't know what's going to happen, and you really want to know. There were 2 of those in the clip that we saw, right? The first time Steve Austin sees a Sasquatch and stares at him in a manly fashion, that's supposed to be a dramatic moment, and you want to know how this is going to go down. And then at the end there, when he was mind controlled, or I don't know what that was, you know, you feel like he's in trouble. And this is a standard structural thing that these shows would do all the time, right? So that's thing number 1. Thing number 2 is the need for syndication. So the idea was, well, you want to make as much money off these shows as you can. There are substantial investments. So after the first run, you want to be able to sell the show to a local station. And you know, that local station can play the show, and the belief for quite a long time was that you want to prevent people from being confused when they see a show that's in syndication. So, you know, if you see Star Trek in the morning before you go to work on one channel, and then you come home after work and you see Star Trek on another channel, and they're showing even a totally different season, the thought was that you don't want people to be confused about what's happening. You don't want those to be incompatible. And so what syndication ended up doing was putting a constraint on the works that the world can't really change. You know, nothing huge could really happen. You have to sort of reset the universe at the end of every show so that the episodes are interchangeable. It doesn't matter what order you watch them in. And you get what's almost like a fast food experience. Like if you're going to go to McDonald's, you know what you're going to get before you get there. It's not like walking into a restaurant you've never been to. That's what syndication's for. Now, the important thing to realize, or one of the many important things to realize, is that both of these constraints take the making of a TV show away from being some kind of you know, exercise of artistic expression, and take it more and more into being an engineering problem, right? When you sit down to make a TV show, you're figuring out how to engineer a narrative and a displaying of that narrative that'll keep people through commercials and that'll be interchangeable with other instances of the same thing. And by the time you meet those constraints, those really strongly determine what you can create. And there's actually not that much room left over to do anything really interesting. Now, in addition to being structurally invasive, the slightly subtler thing is that these change your bearing toward the audience. They change your relationship with the audience. If you're going to make a movie, at least in some naive and oversimplified picture of movie making, once people pay for the movie and walk in the theater, you've kind of gotten what you want from them, right? And now it's you as the creator, the onus is on you to fulfill your end of the contract and give people a great experience that they feel is worth their money, right? But there's something pure about that, right? Like, your job is just to entertain people as best you can. Well, and the way that this changes, of course, with something like television is that you stop treating the audience like your friends so much, right? You start, because you want something from them during the proceeding, right? You want them to stay there, so you're kind of like manipulating them a little more. Now, the thing that this does to the genre of one-hour dramas, and the reason I have sarcasm quotes around dramas, is, you know, think about what's a drama. A drama is something that happens when there's a lot of risk. Something's on the line, like some characters stand to gain something, or some characters stand to lose something, or the world could change in some way that's irreversible. Something important is going to happen, right? But in this kind of syndicated show model, that's impossible. There can't be any stakes, there can't be any permanent change in the world because the episodes have to be interchangeable. And so you end up with something that's not a real drama, it's a fake drama. And this again changes the attitude that the author has toward the audience, right? In a real drama, you're trying to create something that's beautiful or dramatic or sad or something that you know, has some kind of truth to it. And in a fake drama, you want people to believe they're seeing something that's beautiful or sad, but there's really no skin in the game, there's nothing on the line, so you're kind of deceiving people, more so than you do even in regular storytelling. So you can have a show like this where, you know, you as the writer are like, oh no, audience, the Starship Enterprise is really in trouble this time. You've got to believe us, right? But anyone who's seen the show isn't really going to believe that because they know Wesley has to save the Enterprise by the end of the show, because otherwise it just wouldn't be Star Trek. Like, that's just not what Star Trek is. Unless it's a two-part episode, in which case you save the Enterprise at the end of the second part. So this changed when some major players, HBO probably most prominently, decided to change this model of what it meant to make these shows, right? And it's not an accident that HBO did this successfully, because they were not subject to these same constraints that things like network television were subject to, right? The selling point of HBO is there's no commercials. That's what you're paying them for when you subscribe. And, you know, they had this history of being the place that you go to see movies that you could have seen somewhere better, like in the theater. And at some point they said, well, we want to compete better than that in the marketplace. We want to have things that people can't see anywhere else. So we're going to produce our own shows. And when they did that, they even doubled down and said, hey, since we're not subject to the same regulatory frameworks as all these network channels, we're going to be more gritty, you know, we're going to be more violent, we're going to have more overt sexuality. They did all this stuff, you know, with shows like Oz and The Sopranos, and you eventually end up at today, where you have shows like Game of Thrones, where the reason people love these shows is because the world has so much on the line. Like, the world can change. Important things can happen in this show, right? It's sort of the antithesis of what people in the 70s and 80s thought was a good idea. So, you know, you end up in a place where this scene can, who knows what scene this is? Probably a lot of people. This scene defines this show in the minds of many people now. It would have been completely impossible to do in the 70s or 80s along many axes, right? Because of consequence in the world, because of being disturbing, just all kinds of things. Okay, so really to summarize that whole section, these constraints were invasive to the work, right? And that changed the work that could be produced. And it's not even like if you were a good author or a good director, you could go and make a TV show that's just as good as a movie, because they're different things, right? It took television to change before you could make higher quality stuff, and that change was structural. It wasn't just that people got better at making TV. That probably happened too. There were probably some really smart people doing good work, but it was the structural change that was important. Now, there's some side effects to this. One is that, you know, the audience of television and the audience of cinema became different, right? The audience for television is like, well, kids who are home after school and are just goofing off, or, you know, someone who comes home from work and they're tired and they just want to flip through channels. They're being entertained. They're getting this for free, and so they don't have high expectations. They're just sort of wasting time, right? That's how you get shows like The $6 Million Man. Cinema is totally different, right? You paid your $7 to $10 a person, $5 to $10, depending on what year it was. You maybe got a babysitter, you drove all the way to the theater, it was raining, it was a big hassle to get there. You got to get there early to get front seats. Your expectations are high, right? And again, that puts an onus on the creator to live up to your expectations that doesn't exist in the case of TV, at least in the 70s and 80s, right? So that then leads to a different culture of quality within the creators of the medium, right? You watch that clip of The $6 Million Man, and there's so many things about it that are astonishingly bad, right? Like, just the editing and pacing is terrible. The sound effects, like, when he throws him and there's some kind of like missile bomb sound effect because he threw him 3 feet, it's like, what is that, right? And maybe some of that is structural too, like the pacing at least, because when you have to stretch things out between commercials, you sort of have to work with what you've got. But you know, that the real reason you had that was because people could get away with it. And again, I want to reemphasize, that was a top show. That was not the bottom of the barrel. I mean, there were shows that we would see today as being indisputably better, right? Like MASH was on contemporarily with this, and that was a much better show probably. But, well, we'll talk about that more later. So, enough about television. Let's talk about games for a little bit. a point now where we've got a fair bit of history of games behind us. And we've seen this trajectory of games happen technologically. And the thing that I want to focus on here is how the container of what a game was has changed over time. And again, how that affected the design, right? So back when games first started to be commercially exploited in a big way, you would tend to play them in arcade cabinets like this one on the left. Then at some point, you tended to have home machines where you could play games in the comfort of your own home without going anywhere. And that lasted for quite a while until just a few years ago. And I'm making a break point in a differentiation between then and now. The home machines still exist, but now we have these very powerful computing devices that pretty much everyone has and carries with them everywhere. And they're not specifically made for games, but they do a pretty good job at playing certain kinds of games. And so this has created a big explosion in the market for what games are and in the perception of what games are in the public. So let's talk about arcade cabinets for a second. How did these affect the design of games at the time? Well, through very basic financial constraints again, right? An arcade cabinet was expensive to build. If you were an arcade operator, you had to make back that money before you could start making any money, right? So as an arcade operator, you wanted games where you knew people were going to just be plunking a lot of quarters in, right? So the design of these games very deliberately at the time was, we expect to get a quarter out of you every 90 seconds to 3 minutes. Like that was the short time frame. And so what that leads to in terms of game design is that these games all tend to be action challenges where, you're worried about getting killed or something, and after you get killed a certain number of times, it's time to put a new quarter in. That's pretty much what video games were during this time. Once we started having home systems of various sorts, let me just say, actually, so here's an example of a commercial constraint dictating the form of what gets created, and that's something that pretty much always happens. This one, I would claim, is a little bit unpleasant, just like the commercial breaks and syndication were with television. This sort of tends to be at least a mildly invasive constraint that seriously affects what you're able to do in the medium, and that would have been pretty bad, and it probably was a little bit bad for a while. But what happened is that this era, when we got home machines, came pretty quickly after that. And what happened with home machines is, there's no longer an arcade operator who has to make his money back. You want to justify the fun that you got. You want to have enough fun to justify the money you spent on this home machine, but that's a little bit of an easier, more casual problem to solve. The machine exists for years. You can buy games for it over the course of years. And what happened is we got longer form games that weren't trying to kill you in a couple minutes, and we got some maturation of the medium to some extent, where you started to see more interesting subjects being approached. Even early in this cycle, you saw things that would have been blatantly impossible in a video arcade, right? You had flight simulators where you take off from a runway and you're in the air for 2 hours of real time, and then you land, and not very much happens, except your gauges twiddle a little bit, and the interest in that game is all about the verisimilitude of your flight instruments and the flight model of the vehicle, right? That was a whole genre. You had text adventure games where it describes to you what's happening in text, and you type what you want to do, and it says, okay, well this happened and that happened, right? Those things just can't exist in the arcade because the container of the arcade is very different from that. So, that went on for a while, and I think we're all at least a little bit familiar with that. And then we get to sort of lately, all that stuff still exists. It's not going away. And actually, so
this is Ken Nelson, co-founder and CEO of SciTools, the maker of Understand. I'm going to do a quick Make You Dangerous video of how to use Understand using the Get Ahead C++ sample project. Now, Get Ahead is something near and dear to my heart. It is an open source project created entirely within SciTools and given back to the community. And it is our best view of how you can use Git with a GUI in a way that helps you understand what's going on with your Git history. In other words, it's the same philosophy we got with source code. And that understand is in maintenance.
Optimizing the program is literally just
programming.
programming.
To help you understand your code better. And really, you should only change code. If not, you're just playing fire. So this video is a quick rundown of Understand on the GitHub project. GitHub was developed entirely using Understand, with some caveats, for instance, Xcode on a Mac, GDB and Emacs on Linux, and so forth. Each engineer that works with us has their choice of what they use day to day. All of them use, by their own choice, Understand to understand the source code that they wrote long ago, but it's run too large for them to really understand, or that they didn't write at all. So let's go over the theme of Understand. The theme is information that helps you understand the code. Almost every pixel that we can is devoted to giving you information. Now that has some UI impacts in that we put a lot of things in right-click menus. Because if we had a button for all these things, it creates investigatory paths that you can walk down and up, and things are changing as I touch. That's sync. You notice all these views have sync buttons checked. What's happening is, as you browse, sync events are created, and the information in there updates to what you just did the textual way, and it just follows you as you go, showing you the implementation of the definition of where you are clicking. Over to the right is the metrics browser. All entities have metrics, and if you touch an entity, then the metrics browser shows you everything we have measured about that. And it's all exportable and other things are configurable, again, behind right-click menus or icons in the component view. The upper right is probably most users' favorite components, the information browser. Everything we know, or 95% of everything we know about an entity that you touch or visit or want to know about is in this view. It's fairly condensed, but it's optimized for exploring. So here I can see the parameters go down, and I can see who this function, which is a live SSH2 packet receiver, who it's built from in the call tree. I can explore down to their call tree, and so forth. If I want to open all of it, I can just right-click and choose Open All, or Expand All. There they are. Same with who depends on this function, the call by. Again, we can just explore all the way down, and then visit each use. So, left, on the right, it's certainly dirt. And if you have questions, hit or.
All right, thank you for look at code check, which is the traditional static code analysis in Understand. The file to a subset of the files that you have on your project. Well, how does Understand help? So, this function, where does it fit in terms of the control flow? With an index was allocated. Let's remove. So the comparison project is, so it actually shows me that this function has changed, and I can actually see the difference here. Right? It shows me the difference. So this function has changed. And look, there's even this arrow here, which is green. And green means that it has been added. Right? So, block.
Welcome to Under you all, and we're back at the plugin manager here. Clicking the customize option will create a copy of the plug editing. Alternatively, plugin map includes advanced cycling git about the system. It's a great way to move from here's the structure to here's how this system actually evolves. And lastly, we'll talk about graphs and charts. Graph plugins give you new ways to explore relationships in your code. Custom control flow graphs, data flow visualizations, even critical path comparisons. These are especially useful when onboarding new developers or analyzing high-risk areas before major changes. Keep in mind that plugins are context-dependent, so they will be accessible from different places depending on the entity that the plugin is meant to target. So, for example, let's say we want a graph plugin that targets only architectures. So we'll filter by architectures, and we actually want to look at this architecture tree plugin. So we'll make sure it's enabled on the left. We'll close. You'll notice that because its target is an architecture, it's not going to show up if we right-click any other entity. It will show up if we right-click an architecture here in the architecture browser. We go to graphical views, and we pull up the architecture tree plugin. Any project-level plugins will be accessible from the Project Interactive Reports submenu. As you can probably tell, the real value of the plugin manager isn't just convenience, it's control. You get faster access to powerful analysis features, less setup and maintenance overhead, and the ability to adapt Understand to your workflow, not a generic one. Whether you're maintaining a legacy system, enforcing standards across a large team, or just trying to understand a complex code base more deeply, the Plugin Manager in Understand 7.0 and beyond gives you the flexibility to do that efficiently. If you haven't explored it yet, open up the Plugin Manager, try out a few plugins, and see how much more insight you can get from the same codebase. Thanks for watching and happy analyzing. To learn more about the Plugin Manager or anything else in Understand, visit support.sitools.com.
Appreciate you.
Welcome to
During this
one more tune for us.
Yeah, I'll do you one here that I know that you like, called Saturday Night Shuffle.
Alrighty, go right ahead. Mighty fine picking there, Len. Lone Pine Jr. Now, I think we better get one more number before you go.
I got one here called Cannonball Rag.
Cannonball Rag, sure will. Go right ahead.
Ding 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 ding. Why is it so fucking weird? I didn't say to touch the readme file, you fucking dumb fuck. Like, see, this reveals some stuff. Like, why are we scheduling loads? What is this format called? I don't care about state ownership terms.
How about doing one more tune for us?
Yeah, I'll do you one here that I know that you like called Saturday Night Show.
All righty, go right ahead. Mighty fine taking there, Len. Lone Pine Junior. Now, I think we better get one more number before you go.
I got one here called Cannonball Rag.
Cannonball Rag, sure with you. Right ahead.
Mm. I gotta start eating them like that. That is so good. Mm. Except I can't do it with the melatonin. That's why. I'm sick now. Gotta call someone. We're gonna sleep. I'm gonna go. We'll work on this tomorrow. I think I want to get annotations in. I think that'd be awesome. If you get annotations like in the code base, but like actual useful annotations. I mean, it's basically gonna turn. I mean, I don't know. It's gonna be like a better. It's gonna be like a better ID. Because like I don't know a single ID that shows the call graph. Like a pipeline implementation. I think this might be better. May or may not even be worth it. But I need to sleep. So, anyways, bye bye. But real quick, let's see if it's even working. I think we're gonna wait till this is done. Better take some olive oil as well. So I'm going to take some. Okay. What time is it? Good, I mean...
How about doing one more tune for us?
Yeah, I'll do you one here that I know that you like called Saturday Night Shopping.
Alrighty, go right ahead. taking there. Len, Lone Pine Jr. Now, I think we better get one more number before you go.
I got one here called Cannonball Rag.
Cannonball Rag, sure will. Right ahead.
如果把 MC 里面的像素牛排放到现实中，它这3成熟。MC 里的牛排来到现实，到底能不能吃？切开尝。
日曜日は何をしますか？
If you open up your mind.
Divorce is the only option at this point. Bonnie, why does the house smell like sex and bad decisions? Joe, is it what you think?
She's begging them and delivering it, that bitch.
He was just delivering the pallets to life. Oh, Joe.
First time I'm trying the grape juice. Come here, son. I want to introduce you to the best grape juice known to mankind. All right? You officially a part of the family. You look. My hitter. My hitter. My hitter.
Man. I feel like. Go for it. Come on.
日曜日は何をしますか？私たちと一緒に教会に来ませんか？私たちは末日生とイエス・キリストの教会の宣教師です。もし
Do something for me just to show. Look at the cameras.
Fucking thick. Fucking thickly kickly.
How about doing one more tune for us?
Yeah, I'll do you one here that I know that you like called Saturday Night Shuffle.
Alrighty, go right ahead. Fine, taking there, Len. Lone Pine Jr. Now, I think we better get one more number before you go.
I got one here called Cannonball Rag.
Cannonball Rag, sure will. Go right ahead.
Oh my god, it's all gone then. Okay.
one more tune for us.
Yeah, I'll do you one here that I know that you like called Saturday Night Shock.
Alrighty, go right ahead. Mighty fine picking there, Len. Long time junior. Now, I think we better get one more number before you go.
I got one here called Cannonball Rag.
Cannonball Rag, sure will. Go right ahead.
out.